ministers, and we hope some of you in this room will volunteer to be part of that so that, we advise Africa's leaders on the PARCAI about that idea, and we are hoping to get your feedback as well, so we shape it properly. I will also talk about another grand idea we have, a Pan-African AI Research Center, an ambitious, hairy, fuzzy goal at this point, which is to try and meet the big gap we have on the continent for research, and especially for AI research. And we hope to have a discussion and back and forth. Should it be a physical location? Should it be a facilitator of other research centers? Should it be a convener? Should it, what shape should it take? How do we fund it? So I'll speak about that just before lunch. And we'll collect your views using Mentimeter, so be ready for that. And then we'll continue with our research presentations. Quickly, in 2 minutes, one of my research projects, which is mitigating collusion on e-commerce platforms. So AI agents are used for price making. When you have thousands of items as a seller on Amazon or eBay or Alibaba, you need to adjust the price of those items sometimes multiple times per day. Why? You need to respond to your competitors. If they reduce their prices, you don't want to keep your price up because then you lose demand. If they increase their prices, maybe you can still increase your price so that you still have demand and you're not losing market. If you have thousands of items adjusting multiple times per day, you cannot do this by hand. So software agents running reinforcement learning and other algorithms in AI are used by sellers on online platforms to do price setting. However, experimental studies and real-life studies in the German gasoline market have shown that when these AI agents are allowed to do price setting, they tend to learn to collude. They bring prices up very close to monopoly price, way above market equilibrium competitive price, in a manner that looks like a cartel. Now, it's not explicit collusion because the CEO of one company is not calling the CEO of the other company. Imagine Pepsi, Qhala calling each other and saying, let's increase the price of a can. It's tacit collusion. The agents learn by tracking price trajectories that over time, on behalf of a regulator, and saying the regulator needs to maximize social welfare or consumer surplus. There's a specific formula that economists use for computing consumer surplus, which is directly proportional to the quality. The higher the quality, the higher the consumer surplus, and price, inversely proportional to price. The lower the price, the higher the consumer surplus. So my research deploys another agent on behalf of the regulator and makes the sellers behave properly. How? For example, by steering demand towards the lowest priced seller. And it looks like Amazon and others already potentially do this. If you go on the Amazon page and you search for a phone or, I don't know, a piece of clothing item, there's a buy box, a prominently displayed section of the web page, which features one seller. Most of us who are not expert shoppers don't realize that there's only one seller that is prominently displayed and many other sellers that are hidden from you. Why? Because demand is tiered to the most prominently displayed. So if we show the least priced person there, then the algorithm learns that it should behave itself by decreasing price, keeping everything else constant to steer demand in that direction. But this solution is limited because it's limiting consumer choice. Some consumers don't want to go for the least priced item, they want to see some options, right? If it's a brand new book or barely used, I'm willing to pay 30 cents more than an extremely used textbook, for example, right? So my research designed a flexible way of showing multiple sellers on an e-commerce platform in a way that is flexible so that we maximize consumer surplus or welfare. I've deployed the same research in electricity markets looking at battery storage optimization, where agents are learning to sell power or buy power to the grid by optimizing how much the batteries store. My other research looks at credit scoring algorithms and how to enable borrowers have recourse. We want to enable borrowers exert fair effort, the minimum effort you need to change your categorization from deny to accept for a loan, for a mortgage, for any other decision that is provided by an AI algorithm. So I've been wondering, how do I bring this research to have impact on the continent, right? And with the new forms of solutions powered by Gen AI, these questions become even more critical. I hope that at the end of the day today, we'll have answers to how can we do this on the continent and how can our people be impacted positively. The closing panel, we hope, will synthesize or help synthesize for us these questions after hearing presentations all day. So welcome. I will introduce Professor Thierry Tambe. I already spoke about him, so I won't say too much else, to give us a beginning keynote. So Thierry Tambe is an assistant professor in computer science at Stanford. His research interests include efficient hardware and software co-design techniques for domain-specific silicon systems for AI and data-intensive applications. He also bears a keen interest in agile chip development methodologies, and previously he was a research scientist at NVIDIA and an engineer at Intel. He receives his bachelor's and master's in engineering from Texas A&M University and a PhD from Harvard University, where I met him, all in electrical engineering. Thierry comes from an electrical engineering family. I think 4 of his siblings and his dad are electrical engineers. His research has been recognized through an NVIDIA Graduate PhD Fellowship, an IEEE Pre-Doctoral Achievement Award, and several distinguished paper awards. I cannot think of a better example of an African AI researcher to open for us. Welcome, Professor Thierry Tambe.
All right. Hello, everybody.
Siri on the screen? Yeah, good. All right. Thank you.
Yeah, so I'm going to go ahead and share my screen here.
The sound. Can you guys hear me? Thierry, 1 second.
Yeah.
Let's get the sound working.
Eric, the host also needs to enable me to share my screen, by the way.
Quick introduction.
Eric?
I can hear you now. Okay.
Can you hear me, Eric?
Just a second, Thierry.
By the way, Eric, on Zoom, I need to be given the permission to share. enable me to share my screen. On Zoom, this needs to be allowed. Hi, Eric. I'm still not able to share my screen. Okay. Okay, can everybody hear me? All right. Okay. Hello, everybody. Thank you so much, Eric, for the introduction, and everybody in the audience and also online on Zoom. It's really a great pleasure to give this keynote, and I'm so sorry that I cannot be there in person. Yeah, and really forgive me for that. Hopefully, I will try to make the best of it. online. So my presentation today is titled Frontiers of Efficient AI Computing. So I am an assistant professor at Stanford University with the Department of Electrical Engineering. I also have a courtesy appointment with the Department of Computer Science at Stanford. And my research is at the intersection of computer architecture, AI, and chip design, right? So essentially, we try to make efficient AI chips. We try to make them, you know, have very high energy efficiency and also provide, we also try to make sure that they provide high performance. So in this presentation, right, I will provide an overview of some of the research that we currently do in my lab. And so really at a high level, really the big question that we try to answer is how can we make data intensive applications, especially data intensive AI applications, run efficiently on domain specific hardware, right? And really to answer this question, we need to answer how we can efficiently encode data. By that I mean, what is the bit precision that we should use, right, to store data on chip? As some of you may know, right, if we can optimize the bit precision, that also leads to overall better energy efficiency. And the second question that we try to answer is, how can we efficiently store data in memory? So once we have figured out how to best encode the data, now we need to store that data in memory, right? So that also plays a big role into the overall performance and the energy efficiency of the AI hardware. And so to end my talk, I will provide some thoughts about essentially Africa's role in this domain, right? What is Africa's role in terms of building and designing, AI accelerators, AI chips, and how can we, promote, improve Africa's brand standing in this domain. So let me first start with the first part here in the outline, which is how we can encode data. So I'm going to be using jargon that I typically use, for my research. Hopefully this is fine. My understanding is that the folks in the audience obviously have a fair to an expert understanding of AI. So hopefully this will not be too extraneous to the folks in the audience. So how can we efficiently encode data? So really, if we were to look at the parameter distribution in modern AI models, so in this slide, we show the parameter distribution of popular convolutional neural network and also popular natural language processing models. What we see here is quite a wide distribution, right? So for example, CNN tends to be they tend to have a much narrower distribution compared to NLP models, right? So what this really tells you is that if we think about a number format or a data type to encode data, it really needs to have the ability to encode the wide distribution that we see here, right? And so what do we mean by that, right? So for example, let's say we have a floating point number format, right? So a floating point number format is represented by this formula shown here. Let me use my pen here. So it is -1 to the sign times the mantissa times 2 to the power of the exponent, right? And if we were to plot the distribution of the weight of a neural network, obviously we will see this Gaussian distribution, right? And in terms of if we really want to reliably encode this distribution onto a floating point number format, so what we are doing here essentially is to add an exponent bias to the exponent field of the floating point number format to essentially shift the range of the distribution of the parameters to accommodate the maximum absolute value in this distribution. Why do we care about the max value? Because obviously, the largest values, the outliers, tend to have a disproportionate impact on the model's accuracy, right? So when we started essentially looking at optimal ways to encode neural network data, one of the innovation that we came up with essentially is to formulate an exponential bias, which is integrated on the exponent field of the floating point number format to essentially shift the range of data point to encode this max value, right? So practically, what this means is that, let's say if we have a floating point weight matrix, right? So we find the maximum absolute value in this weight matrix, and then we compute an exponential bias, which we will use to essentially, again, do the tensor scaling to be able to encode this matrix in the best possible way, in a way that minimizes the quantization error, right? So we have shown that we can do essentially this sort of tensor scaling at different granularity, right? So if we were to do this sort of quantization on the entire tensor, this could be a weight tensor or an activation tensor. So what you see here is that there will be quite a sizable quantization noise, right? And so our approach essentially is to adopt a much finer grain quantization scheme. And this can be done at different granularity. This can be done at a per tensor granularity, which is shown right here. Obviously, in this case, the quantization noise can be quite big. And so to minimize the quantization noise, we can do this at a vector granularity, right? So the vector could be this window from negative alpha to positive alpha. Or we can even do this quantization at a even finer granularity of a block, right? So this is called block scaling. So in my lab, we have essentially demonstrated this sort of finer grain quantization for different applications. For in the case of RNN inference, transformer inference, and also transformer fine tuning. So we have not just done that; we have actually designed a couple of AI chips that demonstrate these quantization schemes, right? So in our lab, right, we do hardware and software co-design optimization of AI workloads. So we don't just propose an AI algorithm, we actually implement this in hardware and to validate these innovations. So what you see here essentially on this slide, these are some of the AI chips that we have designed in our lab. So we started with Bayesian inference in 2018, and here the data type was, this was 32-bit fixed point. And then we progressively, moved on to more energy efficient data types. So here we use FP8 with per tensor scaling, and then FP4 with per vector scaling. And then the latest one that we're still waiting to publish, in this case, we use block scaling. So what you see here is that by essentially moving to data types with finer grain tensor scaling, we are able to achieve higher, better performance, right? So we can go from, in this case, from 7.8 tops per watt to 65 tops per watt. So here top stands for tera operations, per watt. Essentially, we are able to achieve much higher performance. So this is why, you will see currently with the latest, GPUs from NVIDIA, right? There is this trend towards essentially implementing much finer grain number format with lower precisions. And this is also the research that we are currently undertaking in our lab. So we want to come up with ways to design more compact, low precision number formats that is able to yield much higher performance and energy efficiency in AI hardware. So now the question is, can we do better, right? So I've shown you how we can do various scaling at the granularity, at different granularities, right? At the granularity of a tensor, of a vector, or at the granularity of a block. So the question is, if a group of number merits its own scaling factor, why not its own number format, right? So our latest research on this essentially is this concept of block level mixed format representation. So what we are doing here is that now within a block, we just don't do essentially block scaling. So here we actually assign different number formats. So think of it as, for example, this block here in blue may be a version of a 4-bit floating point, and then the next block here in orange could be another number format, a different variant of a 4-bit floating point representation, right? And so really here we are really focusing on choosing and applying the best possible number format to represent a block of numbers, right? And the research here is to come up with the best number representation that would minimize the quantization error within that 2D block, right? So for example, let me explain this, right? So let's say we want to, we essentially have a hardware that supports this FP4 E2M1 number format, right? So the data points that you see here in blue, these are the different grid, right? The different grid data points that that essentially all numbers will have to snap to this grid shown here in blue. What we see here is that obviously, for block 0, right, essentially this region will be wasted, right, because essentially we don't have any representation for this FP4 number format, whereas for block 1, we have some outliers here which will not be able to be represented by FP4. Right. So what we're trying to do here essentially is come up with our own custom number format, which will be able to represent these outliers. Right. So what we are doing here essentially is we are creating our own sort of code book, our custom, number format, which will enable a more faithful representation of the data points that we see in the AI model at the granularity of a 2D block, right? And Our evaluation results essentially is demonstrating state-of-the-art performance. So when we compare our number format proposal against the latest state-of-the-art number format out there, which is called microscaling FP4, we show that we are able to achieve superior encoding performance. So what you see here on this table, we show the perplexity on the Wikitext data set. Wikitext is the figure of merit used to evaluate the performance of large language models, right? So the lower the better, right? So here on this slide, we show that we are able to essentially achieve superior performance against a state-of-the-art number format called microscaling FP4. Right? So this is one of the work that we are currently doing in this area of essentially, figuring out how to encode data efficiently. So now that we have, encoded, our data in a very efficient manner, the next step is to obviously, store that data also efficiently in memory, right? And by that, really, I mean, what should be the memory storage, what should be the memory technology, what should be the memory device that we should adopt, and for how long should we store that data in memory, and how will the compiler of our accelerator handle different memory accesses, right? So this is what we are essentially trying to address with this research question, and really to sort of motivate this challenge. So obviously, what we are currently seeing is that the size of AI models is growing at an exponential rate, right? So what we are seeing here is that the size of transformer models is growing by 400x every 2 years, right? And at the same time, unfortunately, the amount of memory available in popular AI hardware is unfortunately growing at a much more slower pace of about 2x every 2 years, right? So essentially what we are seeing here is a growing gap between the size of these foundation models and the available memory capacity in some of the prominent AI hardwares. So we clearly have here a memory wall problem, which is getting unfortunately worse, every year. And the consequence of that is if you were to look at the integration of on-chip memory, so the most popular on-chip memory technology is called SRAM. It stands for static random access memory. What we are currently observing essentially is a trend towards increasing the amount of on-chip SRAM capacity. Obviously, the goal here is to maximize locality, right? So once the data is brought on chip, right, we want to be able to reuse that data as much as possible, right, to essentially reduce the amount of chip memory traffic that we have to make, right? So we are essentially seeing this trend towards surging on-chip SRAM capacity. However, we have this problem that unfortunately SRAM scaling is ending, right? So if you this slide essentially is showing on the y-axis, we have the bit cell size of the, we essentially show here an SRAM bit cell size for different process node technology from 90 nanometer all the way till 2 nanometer, right? And really what we are seeing here is that unfortunately, even though we have been able to still benefit from Moore's law somewhat in terms of reducing the transistor feature size, unfortunately, the density, the size of the SRAM memory has not been able to scale with the same proportionality, right? And this is a big problem, right? So my research currently essentially is looking at alternative forms of on-chip memories, right, beyond the legacy SRAM memory technology, right? So we look at especially at the short-term, memory technology. So there is this so-called two transistors or three transistors gain cell memories. These are very, very dense in the sense that they obviously have fewer transistors compared to SRAM. So here you can design such memories with only two or three transistors versus six. So you get approximately 2x greater density, right, compared to the legacy SRAM. However, the main challenge here is that we have a finite retention time. So by that is once the data is stored in memory, that charge will eventually discharge, right? So then we will be forced to refresh it. Otherwise, we would lose the information in this memory, right? So, however, if the lifetime of the data in memory is shorter than the retention time, then refresh can be obviated, right? And so what we're trying to do here in my lab, essentially, we want to build a tool that is able to capture the lifetime of on-chip data, right? So essentially, by lifetime, essentially, we mean from write to last read, right? So, essentially, we capture the time when the data is written into an on-chip SRAM memory. It could be a cache, or it could be a scratch pad for an accelerator. And then we capture the time that data was last read. So that distance essentially is what we call lifetime, right? So, and again, why do we want to measure that? Is because once we have the lifetime information, we can then use that to align that with the proper memory, the proper on-chip memory to use, right? Which would obviously help us integrate denser memories with also higher performance and energy efficiency. So essentially, we are building a tool here where here at the backend, we start from PyTorch. You can run any AI model. It could be Llama or any transformer models. And so through this tool, essentially, you can also choose what is your target hardware. It could be a GPU, a GPU, or it could be a systolic array or any AI hardware. And this tool will then produce a set of memory access pattern logs. And from this log file, there will be some analytical post-processing in the front end, which will produce the on-chip lifetime data. And from this lifetime information, we will be able to essentially project what is the area power and power benefit, essentially, right? So this is an example of an output that you will see by running this tool. So we call this Gainsight. So when we run this on the H100 GPU, you will see a plot like this, where on the x-axis, we have the lifetime, Again, this is the amount of time the data resides in memory before it gets refreshed or before it gets overwritten, right? And right here on the y-axis, we have the number of cache line accesses, right? So essentially for the same address in memory, we capture essentially the amount of memory accesses that happens at that specific address. So what you see here is essentially is interesting. For example, if you see where my cursor is, so this is about 5 microseconds, right? So what you see here is that essentially the majority of the on-chip data has a lifetime of 5 microseconds. So what this tells you is that if we can design a short-term memory, such as a gain cell memory with a retention time of at least 5 microseconds, then this will essentially obviate the necessity to do refresh, and then we will have overall a much better system, right? So essentially, this tool called Gainsight is able to report on the lifetime distribution of the on-chip data, for any application. So the different colors that you see here represent the different workloads that we run. So this could be a CNN or a transformer model. And the different rectangles that you see here represent essentially a kernel. It could be softmax or it could be a matrix multiply. Right. So really our goal here really is to, we want to essentially change the conventional way of designing AI hardware from a state where essentially we have a homogeneous memory integration made mostly of SRAM. And if you recall what I said earlier, SRAM scaling is plateauing, right? And this is a big problem, right? So, and we essentially want to enable the design of next generation computing systems where the integration of on-chip memory will be much more differentiated in the sense that we will be able to integrate not just SRAM, but also some long-term and short-term memories, right? And all these design decisions, will be informed, by, our lifetime profiler that we are currently building. So this is the overarching goal of this research. All right. So with that said, I obviously have a lot more research that I would love to really dive into, but for the given we are short on time, I want to provide my own thoughts, for what is really in my view, some pathways for African innovation in this space, right? That's in the space of AI chip design, right? In the space of AI compute. So I think it's important to start first, with, it's important to first acknowledge, the strength of the African continent, right? So, there was recently this article from African Business, and the title of this article says, it is Africa looks to mustard in on the semiconductor value chain. And if you read the article, really, it makes some really valid point in the sense that Africa has a very vast reserve of silicon, right? So silicon essentially is made of silica sand and quartz, and we have an abundance of that, in Africa, right? And it's also important to mention that Africa also has a quite strategic position in terms of being able to manufacture semiconductor chips in the sense that it's actually in the sense that it can be very neutral, right? So if you look at currently the biggest semiconductor manufacturer is based in Taiwan. It's a company called TSMC. However, if you have been, listening at some of the latest news, there is we have there are quite a lot of geopolitical challenges there, right? So I think Africa has a huge opportunity to sort of adopt a neutral position on this, and also sort of leverage a strategic position to make a play in this domain. But there are some challenges that I would mention on the next slide. And I think as everybody knows, right, we also have a growing and a highly capable, talent pool, right? So the continent is extremely young. It's quite tech savvy, quite really super smart, right? And so there is quite an opportunity here to really benefit from the current rapid digitization currently happening on the continent. However, again, if now I did not particularly show this this part on the previous slide, and it is currently shown here. The challenge, obviously, is that I think the first thing to mention here is that in terms of to be able to manufacture chips reliably, we need to also have a reliable power distribution, right? And this is something that I think we can acknowledge that is still quite a bit of a challenge. Even though we have renewable energy, right? We have a lot of we have obviously the capacity to harness the sun. We have the capacity to harness the wind, but still there is still insufficient infrastructure to be able to manufacture chips at scale, right? So this is sort of the challenge that we are currently dealing with. And it's also important to mention that this industry is also quite capital intensive, right? To build a data center or even to build a chip manufacturing facility, we need quite a bit of investment, right? And obviously, it would be important to make sure that the space where this is done, right, there is a predictable policy environment, right, within that space that promotes the right kind of investment and partnerships, right? So with that said, I think that the most viable path forwards that I see here, at this juncture, in my point of view, is the following. So first, obviously, it's incredibly important that we turbocharge AI education and adoption. Obviously, this is already happening in many parts of Africa. Obviously, there are many leaders in this space, such as, in Kenya, Ghana, Morocco, South Africa, Nigeria. This is amazing. We should, in my view, we should even redouble these efforts. Currently, we have an ongoing AI revolution currently happening, and Africa really cannot afford to be left behind, right? So we should definitely build our own, foundation models, something that really address, Africa, critical needs. And the second point that I want to mention here is that we do not necessarily need to build hyperscale facilities, but I think what would make sense, given our current limitations, is to actually build distributed edge data centers, right? And this would not really require, the huge amount of investment and and facilities required for for such a an endeavor. And also I think it will also sort of leverage the fact that obviously there is quite a bit of a digitization currently happening. Many people in Africa have now a mobile phone. So what that means is that we could actually leverage, federated learning and decentralized computing, right? So in my view, if we can invest more in a decentralized computing infrastructure, I think that would definitely have this will provide more value given the current situation. And the last point here is that I think there's an opportunity here to also design specialized chips, again, that are catered towards Africa's needs. It could be in agriculture, right? It could be right in other domains that really make sense for the local space in Africa. And yeah, so that's what I prepared for this talk. And really, thank you so much for your attention. That's what I had. If there are questions in the audience, I would be happy to take it.
Thank you. So we'll take 3 questions from the audience as we prepare to hear from our next speaker. So I see one question up there. Can someone give him a microphone? Okay, I'll bring you mine.
Good morning. My name is Jerry John from the Kwame Nkrumah University of Science and Technology, Responsible Artificial Intelligence Lab. I just want to find out whether in all this there is any role for quantum computing in that.
Thierry, did you get the question?
Yes, I heard the question. The question is whether there is a role for quantum computing. And really, the answer is obviously yes. And the way I view quantum computing is quantum computing is sort of a domain-specific computing, right? So it might be quantum computing, definitely has its place to solve specific problems, right? Especially in cryptography, right? Quantum computing can be would be extremely useful in that, right? There are problems that classical computing simply would be too slow to solve, right? So that's the opportunity for quantum computing to make a very interesting foray. I completely agree that obviously we need to do research as well in quantum computing. Obviously, this is not my area of research, but I think Africa for sure should be playing a role in that. And we should promote this sort of research as well.
On the left.
Hello. Thank you for the great talk, Thierry. I'm Prasenjit Mitra from ECE department at CMU and now in CMU Africa. So I got a little bit about what you're doing, and I've worked a little bit on neural pruning as a way of compressing. I think the idea for creating a new number format, as you put it, is interesting, and the code book. But there are 2 aspects there. One is that when you are sort of quantizing, you lose some amount of accuracy. So that would have an impact on the accuracy that you are seeing on the inference or applications. But also when you're encoding it, into essentially a code book, you would have to decode it, and that takes time and energy. And I'm assuming all of this is taken care of and paid off by smart encoding. But can you tell us how much the accuracy suffers or how much time is spent in the decoding part of that code book?
The decoding in the interest of time. In the paper, we definitely elaborated on the decoding mechanism, and but to quickly summarize, we essentially have a two-step approach of for doing the decoding, and in terms of the amount of overhead that there is some overhead, but I would tell you that we are able to sort of hide the latency of this overhead when we actually co-design the hardware by virtue of pipelining the computation. What I mean by that is, while we are doing the decoding during a specific, let's say during one clock cycle, during the same clock cycle, we do other things, right? So, to sort of hide that latency, right? So, and we have been able to sort of, constrain this overhead to about 2 clock cycles, which is obviously, it is something that is, obviously not does not bring that too much overhead. When you can also hide it during the pipelining phase of the computation. Yeah. This is able to answer your question and to sort of provide a bit more information here, right? Obviously, this is a floating point inspired number format, right? So when we do the decoding, the first step actually will be to first, find the maximum value within a block still, right? So what we did is that we built a tree structure that is able to identify the maximum value within the block. And then once we find that maximum value, the next step is to compute the exponent, for that maximum value, right? And then from that, we can then figure out, what is essentially the entry within this code book that we should essentially select, right? And then once we select that, we send that code book value to the processing elements of the AI hardware.
Thank you.
Or hide this overhead during the computation.
Visible when we come to productionize it into the market.
Thierry, did you hear that question? Okay, let's get Thierry back on. Okay, we'll probably try and get the next question before Thierry comes back online. Yeah, go ahead and introduce yourself.
My question is also to Thierry, so I don't know if...
I think he's online, he's just not on the screen. Yeah. All right, Thierry, do you want to answer the last question?
Yes, can you please repeat that question? I was not able to. Can you please repeat that, please? Hello?
the feasibility of this productizing across,
Can you hear me? Can you guys hear me over there?
Can you hear me? Can you put a thumbs up if you hear me?
I can hear you.
Oh,
yes,
brilliant. Okay, fantastic.
I can hear you.
So my question was, based on your research, we're seeing specialized data storage in chips, right? And my question to you then is, do you see the future of AI computation where there's specialized hardware for different models? And is it feasible into the market?
Okay. Oh, I see. So I guess the question is whether I see a future where we will continue to see specialized models in the market. Is that the correct question, hopefully?
Do you see the future where we have specialized hardware for different types of AI model computation?
Okay, I see. Sounds good. Yeah. Thank you for the question. So, I would say the following, right? So, there needs to be a value. There needs to be number one, a market value, and there needs to be a performance rationale or reason for designing a specialized hardware for a particular model, right? So, for example, currently it's very, it's quite popular nowadays to see specialized AI hardware for transformers, right? Because transformers have become the de facto model, for natural language processing and for large language models, essentially. So that's why, many, modern computing AI systems currently include a specialized hardware engines, for transformers. So really, I would say it really depends on the number one, the popularity, sort of the the popularity of the AI model, and if there is obviously value for doing that, I think that's why you would see a lot of investment in specializing a hardware for that. And I would also say that obviously designing a specialized AI hardware is expensive, right? There are other approaches to designing hardware. You could, for example, use what is called an FPGA, which is called a field programmable gate array, right? It's a much cheaper way to sort of prototype an AI hardware, although this would not give you the same performance as a specialized AI hardware accelerator, but it would enables you to quickly create a hardware prototype for any emerging AI computation that we are currently seeing, right? So investing in a design of AI hardware, this has to be it has to be supported by obviously the popularity of the model. We have to answer the question as to, do we believe that this particular AI model computation will last for a long time, right? Because we need to justify the financial investment for that.
Last quick question, then we have to move on to the next speaker.
Thank you. Thank you very much, Thierry. The two questions you had, I had exactly the same questions, but since you answered that, I had a follow-up question. You said that you can somehow cover up the cost of decoding in parallelism, like in a pipeline, and I'm wondering how that works. Are you doing so? Do you need to add a couple of more levels in the parallelism, in the depth of the parallelism? And what does that mean for the ISA? Do you have to modify the ISA so that you do that in the fetch step, or you do 2 steps before the fetch step? How does that work exactly?
Yeah. So So the way this works is that if you look at the data path of a hardware accelerator, right? So the first stage could be understood as sort of memory fetching, right? That's the first stage. Memory fetching, essentially, this is where you get the data from your scratch pad or from the on-chip memory, right? The next stage is the actual computation. For example, this is where we are doing the multiply and accumulate between an activation tensor and a weight tensor, right? And then the next step after that, after you do the multiplication, the next step is to do the, we have the activation function, or we have the nonlinearity transformation that we have to do, right? So this could be ReLU, JLU, right? Softmax, right? All these nonlinear functions that we commonly see in the AI model, right? And then after that, we may need to do, essentially the number format quantization, right? So again, if I repeat that again, first step you have memory fetching, and then actually, as you mentioned, after memory fetching, there is this decoding that we have to do to figure out essentially which code book entry to select. And then after the code book decoding, we go to the MAC to do the multiply, and then you do the nonlinear operation, right? And then you do the quantization. So you have at least 5 stages there of computation, right? So if you have 5 stages, you can see how you can pipeline. If you have multiple operations that you have to do in sequence, you can easily pipeline these different stages in a way that hide the latency of doing the decoding. Hopefully this makes sense. This made sense. Thank you.
We'll let Thierry go to bed. It's 1:35 a.m. in Palo Alto. So thank you. Please give him a round of applause for staying up late. Next, as we set up, I'm going to introduce Dr. Tayo Guntebi. Let's make sure his slides are up and ready. In the back, give me a thumbs up when it's done. Okay, good. So Dr. Tayo Guntebi is a computer architect and software engineer. He currently works at Google, focusing on efficiency and performance in execution of AI models. His research and previous engineering projects have spanned multiple layers of the execution stack, including the runtime, compiler, and application layers of the machine learning model. Most recent work has focused on the area of maximizing utilization and efficiency of large AI accelerator clusters while running large language models. Tayo hails from the Yoruba-speaking section of Kogi State in Nigeria. He has a bachelor's degree from Georgia Tech, a master's and PhD from Stanford, all in electrical engineering. And after completing his PhD, he was co-founder and CTO of a quantum computing software startup. So I hope you two can connect after with a quantum computing question person at the back. That builds an application layer business solutions on top of annealing quantum computer. Please welcome Tayo Oguntebi.
Thank you.
Thierry's slides up. Give me a thumbs up when they're up.
So good morning, everyone. I'm very excited to be here and talk about some of my research and Okay. Yes, so yeah, happy to be here. Looking forward to engaging with everyone here about infrastructure for AI in Africa. So, yeah, before I start, I want to point out this presentation represents only my personal viewpoints, and I'm not speaking for Google, Alphabet, or any other entity. So just to follow up on what Eric said, I've spent my entire career at Google working in the software stack for AI training. So you'll see here on the right hand a notional diagram of a typical software stack. The models are on top, ChatGPT, Gemini, what have you. The models are lowered, optimized, and then sent to the hardware. I spent my entire career at Google in that green box. So making the models run efficiently on different types of hardware. Typically TPUs, our internal AI chips. And so my current area right now is performance and efficiency, and I've worked on a variety of teams. And as Eric said, I did my training at Stanford, so kindred spirits with Professor Terry. So my plan is to cover three things. I'll talk very briefly about some optimization techniques that we have done in research at Google. I'll speak about a recent model called DeepSeek, which some of you may have heard of, and talk about how this model may have implications for how we think about infrastructure as African engineers. And I'll give some of my own personal thoughts on AI compute strategy for Africa. So actually, before I get started, I think one of the things that we were asked to do was kind of follow up and talk about the keynote talk and gives our views on some of the things that were said. And I'll try to integrate those things into the talk as I'm speaking. So. Okay, so I've said this word efficiency and performance just to make sure we're all on the same page. What do I mean by efficiency or performance? Well, very simply, I mean how well does the model utilize the hardware, whether that's GPUs, TPUs, or what have you. That maps directly to how fast the model runs. When you kick off the model, does it run in 1 second or half a second or so on and so forth? Why does this matter? Why do we care? Well, in compute world, time maps directly to cost. So when models run faster, we spend less costs for training and less costs for inference. And secondly, if we do things correctly, we can fit larger models into the same hardware and release more powerful features. So it's very important from an efficiency standpoint, from a cost standpoint, and from an ability standpoint. I have just three things here to kind of give context for the talk. For the research portion, I'll be talking about data parallelism. To give everyone a quick reminder, data parallelism in infrastructure means that every core in the system has a copy of the model. And each core gets a different set of data to process, and the chips all work together to train the model. The middle diagram there is a reminder that in the domain that we're talking about, when we scale out to train AI models, they have to work together. So we have these red links that represent the links of communication between the chips. In this case, this is a two-dimensional torus, a 16 chips. But we'll see in this talk how important communication is to performance. And finally, when we talk about performance, if we can't see what's going on, we can't improve it. So it's very important to have good tools to see, to profile what's happening. This is an image of a TPU profiler for a model. The details aren't so important, but essentially it's a trace-based tool that tells us how long different parts of the model take on the chip, which allows us to optimize the model. So with that said, let's get into the research topic for today. So we call it parameter update sharding. You can call it weight update sharding. Essentially what we have here is a picture of the typical training loop. This may look very familiar to many of you. We have a set of weights which we want to optimize, and we have some data. The data is used to compute a local gradient against the current set of weights. We use some kind of gradient summation or gradient averaging to get consensus of what the gradients are, and then we update the weights. So typically in the naive formulation, the compute is batch sharded across replicas. So each core gets a different set of data. But after we do the all reduce, every core has the same gradients. So that update actually is kind of the same on all the different cores. So this could be very expensive because when we do the update, we may also have to update the variables like momentum, moving average, and things of that nature. So the proposal that we put forward in our research was to improve this. So this is the improved formulation of the training loop. You'll notice the two red boxes there, reduce, scatter, and all gather. What we did was we took the all reduce, which is the communication step, decomposed it to its two components, reduce, scatter, and all gather. And what this gives us is when we do the reduce, scatter of the gradients, on each core, we end up with the per core gradient of a chunk of the weight, not the entire weight. And then we can just do the update for just that chunk. So essentially, we're doing 1/nth the amount of work for the update, as opposed to updating the entire weight for every single core. And then on the forward pass, when we need the weight, we do an all gather to pull all the pieces together to recompose the weight so we can train and continue. So you'll see there at the top, what this gives us is we go from having an expensive parameter update at the end of the timeline to a much more efficient update. So some brief numbers. This is the results of the technique on a few open source models. You'll notice that there's a variety of impact. Essentially what you're seeing here is when the model is very small or the system is very small, the number of chips is very small, it's very, very limited impact. But for a large transformer running on thousands of chips, we're saving on sending those massive buffers across the entire topology, and it's quite a huge improvement. So since we published this work a few years ago, we have more general infrastructure to kind of do this automatically, but this is an example of the kind of research that we've done to improve performance of models on large systems. Okay, I'd like to talk a little bit about some other optimizations. So input pipeline optimizations. So input pipeline, we're talking about the process of taking the data from storage, transforming the data and sending it to the GPUs or TPUs for training. What we've seen is that in the typical naive case, a single master process reads all the data and processes the data and sends it to all of the TPUs or GPUs. Now, this is actually quite inefficient because sometimes if you have a large number of GPUs or you have very heavy processing, you end up starving the GPUs of data. And we have all these expensive resources and they're not being used very efficiently. And what we've done to improve it is we've parallelized it. So you'll see there on the left, we've gone from a single server reading the data to actually doing this in a distributed fashion. And this is sometimes needed just to remove the bottleneck of input reading. On the right side, this is a picture of a subsea cable map in 2025. And the point that I'm trying to describe here is that AI development is now a global activity. You could have GPUs in Africa, you could have data in North America or in Europe. And we need to be thinking about this as we design data centers, as we design systems, and we need to be thinking about where the data lives, when do we need to replicate the data and have copies of it on the continent or in closer locales, so we're not paying these high latencies. The worst case scenario is times when you're actually training a model that reads from multiple data sets and you want to do some random sampling online of those data sets. So in those cases, you'll actually pay that latency before you can use your GPU. And so this is something that, as we're building systems, we should be thinking about. One thing to know here is if you look at the continent of Africa, the number of subsea links between Africa and North America, you can see is quite small. So when you're accessing data stores that are in North America, you may be seeing much higher latency. You may have seen this in some of your research as well. So briefly, I'll talk about some other techniques. I don't have time to go into detail here, but just as a very quick overview, model parallelism is probably the most critical technique for performance today. Given the move to large models that don't fit in a single chip, we need to shard the model weights across many different chips. When you shard things, you now have encouraged communication that you need to perform in order to have the things work together. And if we're not smart about how we do the communication, we end up seeing a lot of communication bottlenecks in the model. And the primary techniques to improve this are to carefully overlap the communication with computation. So if we do this correctly, we keep our expensive GPUs busy doing good work while we're communicating other pieces of data to other GPUs. And this is simple in terms of the notion, but doing it well is very important to get good performance on large models. And secondly, quantization. Thierry went into detail on quantization, so I don't want to belabor the point, but this is a very promising avenue for reducing the amount of data we have to read and we have to do computation on. I'll quickly point out that this diagram in the bottom here is an example of tensor profiling. So at runtime, we can see how much data we need, how many bits we need in order to store tensors. So case study on DeepSeek. So, okay. Yeah, so DeepSeek, many of you may be familiar with this story, is a Chinese AI firm working on cutting edge research. In 2022, the US imposed some export regulations on GPUs, and they only allowed certain degraded versions of GPUs to be sold to China. And despite this, within a couple of years, DeepSeek was able to publish some very impressive results, kind of on par or close to OpenAI, Google, and so on and so forth. So the right side shows some of the degradations that were imposed on the GPUs. We can see that they were degraded in terms of FE64, as well as in terms of the amount of NVLink bandwidth or communication bandwidth that was available. In ML compute, we don't generally use FE64, so this was actually kind of a moot point, but the bandwidth degradation was actually very, very painful because, as we talked about, communication is important for performance in ML models. So despite this, let's see what DeepSeek. What did DeepSeek actually do to resolve this? So a lot of the things that they did, I won't go into detail on the actual optimizations, but a lot of things they did was to target this bottleneck. So this communication issue, there was a lot of ingenuity that went into working around the constraint that they had. And the takeaway there is, as African researchers, out-of-the-box thinking, bottom-up thinking, can actually enable us to sometimes mitigate constraints with accelerators. So you don't always need the latest and greatest. Thinking outside the box about what we have and what our real problems are, we can actually do very, very interesting work. In terms of some detailed, actionable ideas, Thierry talked about quantization. I think that's a very promising avenue for letting us use less powerful hardware to still do very powerful research. Looking at few-shot prompting is one way to not have to do fine-tuning of an entire model and still be able to tune for our use cases. Defining new metrics that make sense for Africa, as opposed to relying on the same ELA metrics that the rest of the world uses, may be interesting for tuning models for our use cases. And finally, investing more in Africa-focused data sets, and including those data sets in the major pre-trained data sets is very interesting. So now some thoughts on generally AI compute strategy in Africa. So this on the right side, I'm showing how the cost of LLM training continues to go up, while the cost of LLM inference continues to go down. So the right side, the top diagram shows that there's been a roughly 1,000 times reduction in LLM inference costs over the last few years. The bottom diagram shows kind of the Pareto frontier of performance versus cost. As AI model performance goes up, you have to pay a lot more to run those AI models. So what does this mean for Africa? So my proposal is that as African researchers, we should perhaps not think about entering the pre-training race. Thierry mentioned a foundation model for Africa. I think that's a good strategy maybe in the long term. In the short term, this race is so expensive and so fast moving that I think strategically it makes sense for us to focus on using open source models, Gemma, DeepSeek, Llama, and fine-tuning those models with our data sets. And in the long term, in the background, look at how we can work towards African foundation models and hyperscale. So the data center strategy, I think planning for an Africa-based hyperscale data center should be a very long-term vision, but maybe we shouldn't be aiming for this in the short term. In the short term, I think continuing with cloud credits in education is useful for our students and researchers, and perhaps partnering with companies like Terraco or Equinix, people who have experience with compute on the continent, to begin to establish some smaller clusters. And in the background, working towards long-term visions of large, much larger data centers. In terms of investment ideas, notionally, I'm sure people in this room have other ideas, but something like a public-private partnership could be interesting for how we actually fund some of these very expensive endeavors. And a cluster could be time-shared between private and public entities. And some thoughts on some other pieces of the puzzle. Energy and networking, I think Thierry talked about the importance of clean energy. A data center within 50 megawatts or 100 megawatts may be a good start. In terms of data provenance, a managed private cloud could be a short-term solution to getting data for Africa on the continent without having to manage it ourselves. And we should be thinking of investing in Africa-based mirrors of really important data sets so we can do research more easily. Finally, semiconductor manufacturing. I think Thierry also touched on this. We're currently exporting copper, cobalt, rare earth metals. We should think about investing in some of the post-processing of those resources and capturing more of the value up the chain. Thierry touched on our young and growing population. One way to look at that is maybe we could invest in training, assembly, testing, and packaging of semiconductors. This is a lower barrier to entry. We still capture some value in the semiconductor chain, but we don't have to pay the really high price of ultimate chip fabrication. Chip fabrication, one way I differ from Thierry is I think this is probably a very, very long-term goal for Africa. It's very complex and capital intensive, and I think this would be probably not a wise thing for us to look to do in the short term. So I believe that's my last slide. With that, I'll take any questions or discussion.
Thank you, Tayo. Fortunately, Tayo is here all day, and he'll be on the panel at the end of the day. So I'll just take one question so we can try and recover 45 minutes. And then you'll catch Tayo later in the panel, as well as at lunchtime and throughout the day. So I want to get one super burning question. I think we're slowly going to start moving up from hardware to software to applications now. Okay. One burning question for Tayo. Otherwise, he's here all day. Okay, the very back. Someone give him a microphone, please. Back on the left. And then Yusuf is coming up next. So if AV can set up his slide, try and get smoother transitions, please. Okay, please go ahead, ask your question.
Hi, my name is Shozi, and I am founder of Prompt BI. We are AI data analytics company. So my question is, how will efficient computing help in small language models for small devices like smartphones, in terms of like efficiency, latency, and then accuracy? And will it help in data governance where like data security is major concerns?
Yeah, thanks for the question. So the first question, efficiency is critical for mobile, for very small models, because essentially when we're efficient, we can allow us to train smaller models and allow them to still perform similarly to much larger models. We discussed quantization, we discussed pruning. Those are techniques to shrink a model from, 30 gigabytes to 5 gigabytes to 1 gigabyte and still be able to get good performance. And your second question was about data provenance.
Data governance.
Data governance.
Yeah, data security and data governance.
Yeah, sorry, what was the question about those?
So will basically running these SLMs on like local devices will help in like data governance on data security?
Yes, I think that's definitely true. It's in general, if something can be run locally on device, you don't have to send information to the cloud. It's definitely better in terms of a privacy standpoint. So yeah.
All right, please thank Tayo, and he's around. I'll give him a hand. Yusuf, please come up next. So really quick introduction of Yusuf. He's a senior research engineer and the technical lead for AI for social good team at InstaDeep here in Kigali. He's passionate about harnessing AI to tackle real-world challenges and drive positive social impact in Africa and beyond. With expertise in geospatial machine learning, computer vision, and computational biology, Ibrahim has led high-impact projects focused on food security, disaster response, and immunology research. He also leads the development of InstaGeo, a platform aimed at democratizing access to AI-driven insights derived from open-source satellite imagery. His work reflects a commitment to applying cutting-edge AI to create meaningful real-world impact. Welcome, Ibrahim Yusuf.
Thank you.
Please, let's have Yusuf's slide.
Yeah, hi everyone. It's a pleasure to be here to contribute to the discussion around AI in Africa. Yeah, so as introduced, I lead the development of InstaGeo in InstaDeep. And I would like to start with what we do and take a look at the strategies that we employ, to go around some limitations that we encounter. So as you all know that we have open source multispectral data from satellites like Sentinel-2 and Landsat 8. This data is open source. And there has been a lot of efforts around building geospatial foundational models to harness this data for quite a number of downstream tasks. And also in our work, we realized that this data can be used to address some food security challenges, such as predicting desert locust breeding grounds. However, we realized that there is a challenge hindering the adoption of this data by the actual users, like those people that will leverage the insights that you get from this data. And the challenge usually boils down to the technical requirement to build data pipelines, geospatial data pipelines, and as well as the inference cost. So having realized this, we decided to build a solution around this, and the solution is what we call InstaGeo, and it's actually a complete ecosystem for turning raw satellite data into actionable insight, and it has 3 components: the data component, the model component, and the apps component. So earlier on when we started, we will usually pull raw satellite data from HLS server from some of the NASA servers. So we pull raw satellite data. Each of the satellite tile measures 3,660 by 3,660 pixels. When we pull them down, then we extract some chunks that we are interested in to create our data set. So for example, for some of our data sets, we pull satellite data up to 1 terabyte, and at the end of the day, the data we get from it is 20 gigabytes. So you can see a lot of wasted compute, and in some of our discussions with the NASA team, doing that very regularly incurs a lot of bandwidth cost. And we started thinking about how we could go around this, right? Because as the previous speakers have said, all the challenges that has to do with compute all boils down to cost. And one of the things we've been able to do is to not download the data, but rather leverage what is called cloud-optimized GeoTIFFs, which leverages HTTP multi-range request. And we just directly fetch that portion of the satellite data that we need. And by that, we are saving a lot of time and cost that would have been incurred in actually pulling down the entire data. On another end, you'll find that a lot of the geospatial foundational models that are available are usually very large. And our goal is to build something that will make it easy to basically quickly pull satellite data, get some insight, and take some decisions from that insight that you get. And this will involve running inference on models. So you see, if the model is a very large one, then it means that you're going to be incurring a lot of cost, either in training or in inference. And one of the things that we've also been able to do is to take a look at this and optimize the model. So rather than just take the foundational model and use it as is, we rather leverage some techniques to distill the big model into a smaller model, and also try out some application-specific architectures. So for example, instead of taking a big foundational model and throw it to solve a very small task, we'll rather try to see the best architecture for solving that task in specific. So just to touch base on some of the previous talk from the speakers, like was said by Dr. Tayo with regards to DeepSeek, thinking out of the box. So if you look at what the researchers in China have done with DeepSeek, is that they had a constraint. They had constraint around compute, but instead of sitting idle and complaining about the cost around compute, they found their way around it. So in Africa, we actually know that we have challenges around compute. So instead of sitting down and complaining about the challenge around compute, we should rather think of strategies to go around this, thinking outside the box. One of those things that we mentioned earlier is federated learning. Like you have a lot of, let me say, personal compute devices spread across. How can we leverage this like train models? Some other techniques include like pruning, like very big models, so that at the end of the day during inference you have very low compute cost. And also, I also want to talk about AI education, right? In Africa, you will find that we have a lot of mathematicians. Like I've interacted with some of them. They are very good in mathematics, but then they've not spent enough time to learn about like programming, like low-level programming. And these are the kind of people that will really help us to go around some of these compute challenges, such as like building some custom kernels that will, like the work that the DeepSeek researchers did, it had to do with like building some custom kernels and finding their ways around this. So we'd like to encourage to see mathematicians in Africa focusing on low-level programming. Some of the other things that I mentioned, which I see as not so low-hanging fruit, like Dr. Taya also said, is semiconductor manufacturing. That is actually like something on a high end, and maybe design centers for specialized chips, as also said, is also something that we can plan for in the future. And yeah, like I said, opportunities that are currently low-hanging for us is to see how we can go around this compute cost by leveraging some of already existing techniques that I used to realize, like very small models, such as quantization, federated learning, pruning, and even also like data encoding, like the first speaker said, like whether training using low precision bit and maybe during inference, doing inference with even lower encoding bit that was used during training. So yeah, this is all I have to contribute, and thank you everyone.
All right, again, Yusuf is here all day, or at least most of the day, so let's take one question. Burning question for Yusuf. He's at InstaDeep. Yeah, middle table. Yeah, right there.
Yeah, thanks for the presentation. Some great insight. Just quickly, I liked how you kept talking about Africans bemoaning rather than actually, rolling their sleeves to build tools. And I wanted you to draw some parallels between what you're suggesting and the effects of brain drain that we continue to see. Many Africans going to good schools, not returning to Africa. If you could draw some parallels between those two, it would be really helpful. Thank you.
Yeah, that's an interesting one. So myself, I am a product of Africa, entirely schooled in Africa, and a graduate of the African Masters in Machine Intelligence. So I'll say, yeah, it's a challenge that can be solved in quite a number of ways. And one of those is to actually provide those opportunities that they go out there to seek in Africa. And that is one thing that my company, InstaDeep, has been able to do. So when I finished my master's program in AMI, I was looking for a company where I could do like fundamental AI research. And when I was doing my search, I saw that InstaDeep was leveraging reinforcement learning to automatically route printed circuit board. And I was like, given my background in electrical engineering, I was like, yeah, this is what I would like to do. And I decided to join the company. And it's almost 5 years now. And really, I'm really proud of making that decision to join the company. So I will say encouraging companies in Africa to not just play by the game, but rather try to invent, all right? So not just taking already existing models and just building on top of them, but rather try to be innovative, try to build like some custom solutions that are innovative that will attract those talents that we have in Africa. Because if we are able to have a place for those talents to grow their talent, to explore their talent in Africa, then I believe that over time we will see a reduction, gradually, in the brain drain effect. And not just only in study, we have some other AI research labs in Africa, like Google has in Accra and in Kenya. IBM also has, Microsoft also has. So I believe spreading this awareness across, because not everyone knows about this research lab. So spreading this awareness across the students as they come up to seek opportunities in these labs that we have in Africa, I believe this will help tame the effect of brain drain. Thank you.
Excellent. Please thank Ibrahim Yusuf and interact with him throughout the day. I'm going to introduce my colleague, Kojo, who's going to run the next session. So as Kojo walks over, Kojo Appiah is an award-winning senior policy analyst at Qhala, supporting African policymakers in implementing national AI strategies. Additionally, he's an AI consultant for the energy sector, focusing on the responsible integration of AI in the energy sector. Kojo received his master's in data and society from LSE, the London School of Economics, with a research centered on ethical design and application of AI technologies in African contexts. Welcome, Kojo.
Thank you very much, Eric. Thank you very much to our speakers and to you all gathered here today. It's been a joy planning this. It's obviously been trying. It's very difficult to put events together on such short notice, but this has been an absolute pleasure. And I'm really excited to get into some of the speakers' presentations that we have today. So yeah, thank you for being here. Thank you for contributing. It's my joy to introduce the data track of this colloquium, and beginning with somebody who's been incredibly formative for my own development as a researcher in African AI space. So Dr. Abeba Bahani, Dr. Abeba founded and leads the TCD AI Accountability Lab. She received her PhD in 2022 and is currently a research fellow at the School of Computer Science and Statistics in Trinity College Dublin. Her research focuses on AI accountability with a particular focus on audits of AI models and training datasets, work for which she was featured in Wired UK and Time on the Time 100 Most Influential People in AI list in 2023. Dr. Bahani has also served on the United Nations Secretary General's AI Advisory Body and currently serves at the AI Advisory Council in Ireland and will be presenting on the tyranny of bigger, better, and more data. If I can welcome to the stage Dr. Bahani. Please give her a round of applause. So we'll just get Dr. Bahani's slides up on the screen.
Thank you so much for the generous introduction. Hi, everybody. My slides should be up any second now. How is everyone this morning? If you don't have some kind of, slide-related issues, are you even at a conference? So there we go. Yeah, thank you so much for the kind introduction. Yes, so I will be talking about datasets, training datasets, and training datasets are really core. They are the backbone of AI systems, as you all know. And the reason we are having the AI revolution over the past couple of decades is not really, groundbreaking techniques or theories, but rather it's thanks to the internet, where we can harvest massive amounts of data we use for training all kinds of systems. So that has its own advantages, but also its own limitations and dangers. So my talk will be mostly around the problems, the shortfalls, and the limitations of training datasets. And particularly, I will be talking about the flip side of massive datasets for fundamental rights, for surveillance. I will also talk about, I will also debunk a few myths around datasets that seem to permeate within the machine learning community. So, I mean, whenever we talk about, how AI is going to advance Africa or leapfrog the continent or whatever, all these really, most of the time, unsubstantiated claims, the recurring theme we hear is that we need compute, talent, and massive amounts of data sets. And again, we hear that if we have these components, somehow by magic, all our problems will be solved. But that's not the case. The actual reality is a lot more complicated and nuanced than that. And a lot of that narrative is in reality misleading. So within the African continent, again, these are the kind of the typical headlines you will see concerning the need for data. You will see claims around how access to massive amounts of data will really advance the continent. We also hear that lack of data is hampering the continent's development. We also hear narratives around how Africa is, a really a massive opportunity for harnessing massive amounts of data set, for harnessing harnessing massive amounts of data sets and harvesting massive amounts of data sets. And to some extent, it's true that data sets are important, as I said at the beginning, and access to massive data sets, access to quality, large-scale, representative data sets is indeed important to models that are that perform well, that are accurate, and so on. But also, all data set is biased. All data set, especially historical data sets. Historical data set meaning all data sets that comes from the World Wide Web, scooped from the Common Crawl or whatever you have it, is all biased, and there is no simple way of unbiasing data sets. A lot of these stories around unbiasing data sets are like putting lipstick on a pig, and there is an actual academic paper with that very specific title. So, to give you an example, just a couple of images from an audit myself and colleagues did on one of the large-scale multimodal data sets, the line data set. This one is the line 400. So this is 400 image and text tokens. It's a multimodal data set. It's an important one. That's the basis for stable diffusion, Google's imaging, and so on. So as you can see here, this is the dataset portal where we input the query African, and this is the first set of images that appear with that query. And as you can see, it's a very kind of stereotypical Western caricature of what Africans might look like, and compare that with European. The continent is represented in somewhat neutral representations with maps and flags and so on. And obviously, as we all know, problems or any issues with their data sets necessarily translate into problems with models. And in this case, this is generated using stable diffusion. The first one with the prompt African people at work, and the second one with European people at work. So, as I said, unless we actively audit, we actively detoxify, and we actively clean and document our data sets, you can 100% assume, you can operate from the assumption that all data sets reflects and encodes historical and societal biases. And history has not been kind to those that are at the margins of society. And this is what data sets reflect. Another really persistent myth, mostly with models, model parameters and so on, but also within data set, is that the larger the better. The more you scale your training data, the more kind of, the noise will balance out. The assumption that, the good and the bad will kind of counterpart, and you will somehow end up with a distribution that is somewhat, close to the ground truth, close to what should be portrayed in reality. In the case of data set scaling, this is not the case, and we have done the work. This was published, I think, last year, where maybe a couple of years ago now, where we examined two data sets, one relatively small, the other one relatively large, again within the family, within the variant of the lion data sets, one data set containing 2 billion image and text pairs, the other one 4 million image and text pairs. And we looked at, this is again a multimodal data set, so we looked at just the textual component of this multimodal data set, and we looked at the extent of hateful content within that data set. And the hypothesis was that as we scale training data set, does the amount of hateful content actually balance out, or does it reduce, or does it increase? So I won't get into the detail, but as you can see, for all categories, hateful content, targeted content, and aggressive content, the blue is the smaller data set, and the red one is the larger data set. The blue is the 400 million, the two is the 2 billion. As you can see, in all counts, hateful content, targeted content, and aggressive content actually increases as the scale of data sets increases. So it does not, things do not balance out as we scale. In fact, things become more difficult to actually examine, to actually audit, to even look at manually. So larger is not necessarily better if we are approaching the issue from the perspective of toxicity, hateful content, discriminatory content, and even content that shouldn't be in data sets that I won't mention here because it's unpleasant. So I want to move to another kind of persisting myth, almost, that there seem to be, within the machine learning community, there is this idea that all you need is large data sets and obviously compute and talent. And if you have massive amounts of data sets, the claim is that you can pretty much do anything. You can build models for any phenomena. This is, to some extent, depending on what actual phenomena you are looking at. I'm a cognitive scientist, so I come at it from a kind of a complex systems perspective. So you can think of, existing phenomena that we model as more close to physical systems, biological systems, and social systems. So those physical systems may be pertaining like environmental issues or issues pertaining to soil, to physical objects existing in the world. And on the other extreme, you can think of social phenomena. This is anything pertaining humans, so human behavior, human action, things around how people get on, how people interact. These translate in the AI space. These translate to models around finding the best hire, models around models that make judgments around any behavioral or societal affairs of human beings or societies as a whole. So the more we move to the social, the more, no matter how large our data, how representative our data, our models are simply inaccurate, although it's difficult to really state what accurate means in this case. So again, what I want to say is a lot of social phenomena, whether it's poverty, hunger, gender discrimination, and so on, these are social things that, no matter how large your data, cannot be captured by data and cannot be successfully modeled in AI systems. So this is what I mean by, and as we move further in this spectrum, we also see, in attempting to build AI models for extremely social phenomena, and in this case particularly phenomena that is internal human behavior by using external features. It could be images, it could be text analysis, and so on. These are phenomena around models that try to most facial recognition technologies, emotion recognition technologies, models that try to map trustworthiness, and so on. These tend to, again, no matter how large your data, no matter how state-of-the-art your model, these tend to have absolutely no scientific grounds, and these really adhere to discredited pseudoscience, because, as I said, predicting or classifying internal human cognitive behavior based on outer data or based on appearance data and so on really fits squarely within pseudoscience rather than any scientific approach that has any merit at all. So I thought this image really accurately kind of captures. We have, back in the 60s and 70s, we have established that, a lot of physiognomy, phrenology, and even eugenics are bad, and there is no scientific basis for them. But now, with the rise of machine learning, we are legitimizing that processes. We are doing exactly the same thing. We are analyzing faces. We are looking at even shapes of craniums and heads, and we are trying to say something meaningful about human nature, but this time we are using machine learning, and it lends some kind of false legitimacy. So the other flip side of data is, of course, we need, as large amount of data as possible, because, the larger your data set, the better your model performs and the more accurate and so on. But the other side is, as we constantly harvest data, as every move we make, as every transaction we engage in, and every digital trace is monitored and captured and harvested, we are also losing our sense of freedom. We are constantly being monitored, because this data, one way or another, comes back to have an actual impact on us. This data is aggregated and either sold to AI companies, or if it's harvested by AI companies itself, it's used to build various kinds of AI models, eventually it affects our credit score, it affects our hireability, it affects our whether we can get medical attention. It affects in every element of our life to an extent that we haven't even fully mapped it out. So I want to also address that even though there is a move, especially within the African continent, to kind of, accelerate data centers, accelerate data gathering practices with the hope of bringing Africa on a par with the rest of the world, we also have to remember a lot of the infrastructure and a lot of the operating model is owned and controlled by big tech corporations, and all of it is for profit. Despite, for example, the companies like Facebook, for years, they have made it their motto, saying that they are interested in, the rural women, unbanked rural women of Africa. They wanted to connect everybody in the world. But now, especially over the past few years, we are seeing that companies like Facebook and Google, they have absolutely no interest in banking the unbanked or connecting the unconnected. They are purely driven by power grabs and maximizing their profits. There are plenty of evidence that demonstrate this, and some of them very recently, companies like Facebook and Google have, for example, abandoned their pledges to protect basic rights, to monitor misinformation on their social media platforms. They have abandoned their pledges for DEI initiatives and so on. So while on the one hand, these large corporations are going and undoing a lot of the progress that have been made, but they come and tell us that they are doing all this in order to ensure that the unbanked women of Africa are connected. We really have to be extremely naive to buy into that, to believe into that. So what I wanted to say is that as long as the data that is being, the data centers that are being built and the data that's being gathered remains in the hands of a few for-profit large corporations that are dominating the world, not just Africa, but the entire world, there is very, very little chance of using data in compute to solve African problems or to leapfrog Africa to the next level. Even the data sets that our researchers, our scientists are gathering ends up being co-opted by companies like OpenAI and Meta and so on. So I don't want to leave you with a negative note. I also want to suggest that what we can do and how, what are the practical ways we can pursue rights-preserving and responsible and accountable data gathering practices and protocols. So first of all, most of the data that's being harvested is done without any knowledge or awareness of the data subject itself, and we haven't fully realized the implication of that, as I said earlier. So we need strong regulations that really underlie the importance of freedom of movement, freedom of speech, and the freedom not to be surveilled at all. And also, as Africans, much of as I said, as I shown examples within the dataset, much of the technology we are building is really encoding Western notions of what Africa is. So any, Pan-African or African-driven data practice has to come from the basis or from the motivation that it has to challenge this racist, colonialist, and white supremacist understandings of what the continent is. And we also have to really acquaint ourselves back to what pseudoscience practices are, and we have to remove this idea of both data gathering practices and model building practices from ideas of phrenology, eugenics, and other similar problematic issues. And our data sets have to also be built on the foundation of restoring justice, building communal values, as opposed to punishment, almost playing like a gacha, trying models that are constantly trying to kind of disfranchise people. And there are also, this is my last slide. Basically, what I want to say is that at the moment we are focusing again on gathering data in a way that maximizes profit, as opposed to in a way that preserves fundamental rights. So we need a lot more focus on data that is scarce, that is missing, data that is really important for transparency and for accountability, and data that doesn't necessarily have direct monetary value, but it's really important for communities. So this includes data on, climate data, pollution label, wildlife tracking, and so on. So these are missing data that are where there is massive scarcity. Whereas at the top is data, again, that's extremely scarce, that is that we have very little or no access to, that we need to work on. So this includes, data on benchmark results, transparency databases. We very rarely know, we hardly know about data center operations, because those that are building data centers keep this information extremely, it's treated as proprietary, even though these are data that are gathered from everybody, and data that directly or indirectly impacts people. Again, we have very little visibility. So this is data on data center operations and infrastructures, energy, water, and other resources consumption as it pertains to AI. And government military contracts, and so on. Yeah, I will stop there, and I don't know if there's time for questions, but thank you.
Thank you, Beba, for a really poignant talk, which raised some very fundamental questions, I think, is critical to ask in all of our work. We're just going to take a couple of questions, so if there are hands, yep, take 1, 2, and...
Hi, my name is Alfred Ongere from AI Kenya. My question is around if you've looked at the value chain in terms of the data set market, in terms of these small organizations that form a bridge between the AI startup that is building the state-of-art model, and then the people who have the data. They collect the data, and then they clean it, and then they give it to the AI companies. So have you seen any notable companies that are doing a good job, and what African startups and corporates can learn from that? And what can we do differently from an individual perspective and also from an organizational decision-making perspective, so that we reduce the kind of biases that you've talked about?
Yeah, great question. So the value chain of data in the AI pipeline looks like any digital infrastructure you use. For example, I'm sure everybody can't avoid Google infrastructure at this stage. Every time you log in, all kinds of data is gathered from you, including extremely sensitive data such as your gender, your geolocation, your name, and maybe your connections, your contacts, and so on. So in the case of Google, for example, there is no third-party data aggregators. It goes straight to Google, and they use it I'm sure there are several kind of guidelines in how and to what extent and which data can be used for training AI, although it's difficult to trust anything Google says. But it goes straight from Google infrastructure into training AI systems, and then it comes back. To as AI models are really integrated into everyday practices. You see it as personalized. It could be personalized suggestions, personalized recommendations. It's doing some kind of aggregation, some kind of classification or prediction on your own behavior. In the case of data that is not directly gathered by large companies like Google, for example, if I'm buying a coffee and I use my credit card, you would have some kind of aggregators that then, or data brokers that then sell your data to, insurance companies or basically the highest bidder, and then it's used to build AI models, and then it comes back to impact, for example, if it's an insurance company that has bought it, it comes back to impact, what premium you get and so on. So this is the kind of the high level from data to AI pipeline. There are a lot of granulars, of course. In terms of what African startups or data aggregators can do, I mean, these data aggregators or data brokers are extremely problematic and most of the time unethical because we are not even being made aware that our data is being aggregated and sold. So it's not the issue with African startups, it's the issue with the entire data broker and AI pipeline business model that treats the individual as just objects where data and values constantly extracted, as opposed to a human being that has fundamental rights, that has the right to choose, that has the right to freedom, and so on. So I don't really know the answer in how to do that ethically. Maybe start by being extremely transparent and giving people the choice if they want their data to be included in, and so on. In terms of what we can do individually, there are plenty of efforts. There are so many kind of upcoming initiatives. There are several plugins and tools at least help you become aware of what's happening to your data, who is tracking you, and so on. There are also practices that you can use, to block some of these to block some of these initiatives, some of these data harvesting practices, and so on. Again, I won't delve into it, but there is a whole, community that constantly builds alternative technologies and tools for transparency that are trying to equip the general population, at least with some knowledge and some choice in terms of what happens with their data.
Thank you very much, and thanks for your insightful presentation. I want to take us back to the picture that you showed with reference to how the world portrays Africans at work and then Europeans at work. And the reality is that if you do not tell your own stories, others will tell it in a way that you will not like. I mean, if they query the data that is available, if it is not representative and that is what they see, and that is exactly what will be portrayed, and stereotypes will continue to be portrayed over and over again. The point here is that recently we passed the Continental AI strategy. And the reality is, if Africans do not tell our stories with reference to what really pertains within the continent, the world out there will see it the way it has been wrongly portrayed. And primarily what that means is that it is important that in the strategy we are intentional about how we are gathering what I call Afrocentric data sets. Data sets which tell the African story and be committed to it. There are several countries making up the continent. If we are committed to this cause, and country after country, we are conscious about gathering data sets and sharing it, that becomes a significant repository that we can use in engaging big tech. You rightly said in your presentation that big tech is not interested in Africa, and gradually they move out. But if we have data set that we can leverage on as a bargaining chip in our interaction with them, we can make significant progress in that regard. The other thing that I also wanted to ask you about is with reference to, for instance, if you look at data centers within, the continent, about 75% of the data centers are actually built by one particular country. And so when it comes to data and sovereignty, where do we fall as a continent? Thank you.
Great questions. I will start with the image generated using stable diffusion. That's relatively old, but it remains. Whether you are using stable diffusion or DALI or any other variants, you find the trend hasn't changed. The stereotypical portrayal still remains. And you are right that big tech is not interested in Africa. They are not interested in our causes, in advancing our causes. They are not interested in ensuring that Africans are respected or Africans are portrayed in a correct way, in a factual way, which is, massive contributions from philosophy to history to medicine, if you go all the way back. But this kind of history, this intellectual contribution is not represented. It's not what you hear when you hear about Africa. So big tech is not interested in uplifting or respecting Africa or in advancing our causes, but they are interested in extracting value out of Africa, and that's what they have been doing. Facebook has become a substitute for the World Wide Web for most Africans because Facebook, now Meta, really strategically implemented or pushed their technology literally everywhere, even in rural areas. So there is a massive distinction here that has to be made. And having said that, to some extent, having the right amount of massive scale data that is a true representation or an accurate representation of the continent will to some extent solve some of these stereotypical representations. However, the bigger elephant in the room, the bigger problem remains. Big tech ends up being the primary benefactor, the primary body that benefits, that makes money out of it, that becomes wealthier and more powerful from these technologies, from massive integration of these technologies. So yes, we do need to care about data, and we do need to curate our own data, but we have to do it in a way that puts us in control, that makes sure that we decide what can be done with the data, who has access with the data. This is why I touched, strong regulatory basis. This is why I mentioned the need for really strong protocols, legal protocols that ensure that we are, the primary benefactors, not them. Sorry, I forgot the second point. Again, it again comes back to having, so big tech corporations are too powerful to care about anybody. Forget Africa. They don't even care about the EU or US regulators because they are too powerful. They've been trying to break down, for example, like Meta and Google, and these regulators have not managed that yet. So these entities are too powerful to care for anybody. So one of the way to ensure that, again, we are in control is by having proper regulatory practices in place. So again, it comes back to, what are the mechanisms that allow us to have the autonomy over our own representation, our own data centers, over our own data. And I keep going back to, regulatory policies, because they are legal, and if someone violates those, you can bring them to court. But all this kind of voluntary, goodwill type of pledges to do this, to do that, we've seen that it doesn't work, because these corporations can easily walk them back, and we have no way of ensuring that they respect the pledges they agreed to. So strong regulatory basis is a way to go.
Thank you. Please give Abeba a round of applause. Thank you, Abeba. Okay. We're gonna also, just to add, Abeba will be on the closing panel towards the end of the day. So if you do have additional questions, please do feel take up the opportunity if you can. Yes, I'm going to introduce our next speaker on the data track, Dr. Joyce Nabende. Dr. Joyce holds a PhD in computer science from Eindhoven University of Technology in the Netherlands, a Master of Science in Computer Science from Makerere University in Uganda, and a Bachelor of Computer Science from Mbarara University of Science and Technology in Uganda. She's a senior lecturer in the Department of Computer Science, School of Computing and Informatics Technology, College of Computing and Information Sciences, and she's the current head of the Makerere Artificial Lab under the Department of Computer Science. Her major research interests are in the area of AI, machine learning, natural language processing, business process management. She contributes to building the capacity of African data scientists and ensures diversity and gender equality in her research. Please, give a round of applause for Dr. Joyce.
Thank you so much, Dr. Kojo. Good morning, everyone. Good morning. Sorry, I'm a teacher, so I like people to respond back. So I want to thank Dr. Prihani for that great presentation. I think it's really been nice to set the scene for what I'm going to talk about. Hopefully I can, give my experience as part of the work that we are doing at Makerere University and how we've got into data and harnessing data to try and build our own solutions on the continent. Let's see. This one. Okay. It doesn't. Okay. Sorry. Okay. I hope the slides can move without wasting too much time. So I think, as we all know, that Africa has unique challenges or opportunities where we know AI can be leveraged really to address different things on the continent, from agriculture. We've just, I think, had in around a case study there around agriculture, to health, to very many other domains. And as we've all known and been told, that it's really important for us to build out local AI solutions which are sensitive to the on-ground context. Again, and I know this, we all know, many people, when they talk about Africa, they think it's one big thing, but it isn't. Uganda, where I come from, is different from Kenya, is different from Tanzania. And so there are all those challenges within our different contexts, our different countries, and you can't take a big model and you think that one model that you take will work in all the different contexts that we have on the African continent. As we know, of course, data will serve as a foundation on which we are building our AI systems. Sorry, I think I'm moving too quickly. But it's not about data, it's about the quality of the data sets. I think Dr. Brehani has really given us a very good picture of the data set, first of all, that's available on the internet, the quality of the data set, the context of the data sets that we have available. And so if we have very poor data, quality will definitely have inaccurate models, and these models will bring out the biases that are already existing in real life, and they will fail to address the local needs. And because I'm in the language space, it's very, very critical that we have the data sets for building the language models, and we've seen, and I'll give an example later on of the work that we do where data has been an issue, building out speech recognition models for African languages, but also it's around the privacy and ethical considerations around these data sets as we try and collect them to build the models. So as I mentioned, and I like this map because when we look at language, we see that each unique region that we see has a unique grouping of the languages that we speak, of the languages for which we are trying to build speech recognition models for. And there are different groupings there. So for example, my language would probably be similar to a language in maybe in the middle of South Africa, but that will be very different from the languages in West Africa, and they're completely different from the languages in Northern Africa. So if we're looking at training data sets, we need to think about ensuring that they are as diverse as possible because we have different social, cultural, political contexts on the continent. And so when we maybe give a story, when we started out to do the work in the lab a few years back, we wanted to build a model and a system that's able to do crop and pest disease surveillance based on radio data, and I'll talk about why radio data is important a bit later. And we were very excited. We have a very good problem. There's a very good solution that we think we're going to come up with. But the disclaimer was we didn't have any speech data sets for Luganda. Luganda is my language. So if I went and I searched online, at that time, there were no data sets. If I went to the radio stations and I told them, okay, maybe give me your recorded data sets, they'll be like, oh, do you have money to pay us? These have been our data sets. We've been creating them and building them for our purpose. We can't just give you our data sets out there. And for the people who are in the ASR space, you know that you want to improve your data sets for speech. You need speech, but you can also leverage on building language models for that particular language so that the language model can be able to introduce the way the different words are structured, the way they are written out. And so that meant that you need a lot of text data. But if I go to the internet, that text data for Luganda, for our languages, was not there at that point in time. And so we really took a step back of, okay, we are very excited, we have a cool project, but we have no data set. So we really learned how to create these data sets ourselves, of course, with partnership. For example, we started out with Mozilla Common Voice. We had to, go down to the different communities, the ones that are speaking the language, the different accents. We have kingdoms in Uganda. So we went to that kingdom, we signed an MOU. They helped us to get to the people who would help us to contribute data. It was a lengthy process, but I think it was worthwhile to understand the effort that it takes to just have one data set for one language to build a model. And so when we created these data sets, guess what? They're openly available, right? I think many of us on the African continent and AI researchers, when we build our data sets, we put them out there because it's the cool thing. Open source, put your data there, people should be able to use them and everything. And then at some point in time, there was a company, again, big tech, one of those companies wrote to me saying, oh, I see this nice data set that you have created that is open source. Can you sell us this data set? I was like, okay, sell the data set. I didn't know what to do. So when sometimes things are very complex in the NLP space and licensing, I go to Bukosi. For those who know Prof. Bukosi, I went to him. I'm like, what do we do? People are saying they should buy the data set, blah, blah, blah. Anyway, we had a chat and everything. But this is just to really show you that you're trying to do good as an African researcher to put the data sets there, but there are also other intentions, as we've been told, about big tech who don't really care that you struggle to collect the data sets. All they're interested in, oh yeah, there's a free data set. I can buy it, make my tools better, come and sell them back to the continent. And that's the space that we are operating in. So that's really the current landscape. It really resembles the neo-colonial form of resource extraction, except now it's not gold and minerals. Maybe it is, I don't know, but it's about data. And so we've been seen as Africa that we are a data mine. Data is collected to really fuel models that are in the global north. And the economic benefits, we don't necessarily reap them as Africans. And so that's really a call for us when we create the data sets. How can we step into that space to ensure that we can build the models, to ensure that the people from whom we are collecting the data sets can benefit from these data sets, from the solutions that we are building? Yeah, so I will just speak about one project that we're working on in the lab around building ASR for African languages. I think the big question now when we start to think about collecting data and building models is how much data. And I like that Dr. Birhani touched a bit about it, the larger, the better, maybe the larger, not the better. You know, those things that you try to consider. Maybe I should collect a lot of data, all the biases will go away, or I collect a lot of data, my model will perform very well. So we also had that question in the NLP space. And so we wanted to understand this problem, but looking at African languages, most of the African languages that are spoken out there. Because we've seen that when you have a transfer learning, it could work for you, but we're like, how does this work for new African languages that the models have not been exposed to, because it's easy to take a model that's there, and then you try and fine tune on your existing data sets. And we focused on 19 languages across East, West, and Southern Africa. The languages are over there. I guess some people can identify their languages. Again, please note that these languages are as diverse as possible. We have those that are read speech, that are spontaneous, that are conversational. So there are all these different variations in the data sets that we considered. Also, the domain is important. In that speech world, you want to understand I'm building a model. Is it a general purpose model? Is it a domain-specific model? What is my consideration? So there are all those technicalities that you need to think about. And so when you're creating these data sets, oh, by the way, we didn't collect Yoruba. I don't speak Yoruba. But we leveraged on people who are also in the same space as us and have collected data sets and have released them. And we've created a benchmark, which we'll share soon here, that talks about the data sets and the models. And so we trained models here to try and understand how much data is needed. So we did a systematic experiment of let's start with 1 hour, let's start with 2 hours, 5, 10, and then compare how does that affect the word error rate in terms of the data sets that we have. And this slide just summarizes a few things that we discovered when we trained several models that are out there across different languages. We realized that, unsurprisingly, of course, that more training data improves the ASR performances for all the models and all the languages that we had. So as you see, we're going downwards. Of course, we start with limited data set, and we keep increasing the data sets, and we start with huge word error rates, and they keep decreasing. And of course, we are hoping that our models are getting better. But we also found that there were diminishing returns, that the biggest improvements in the data sets and the model training will happen from very little data, like 1 hour, to slightly more data sets, 5 to 20 hours. But at a certain point in time, adding hundreds of hours doesn't give much gains in terms of the performance of the model. So this helps us to think of, if I have to set out a point in time when I have to collect data, how many hours are needed, what can I optimize to improve the performances of my model. And I believe this is work also that's being done by big tech, where they will just take only 5 hours, and they think it's enough for them to train the model. So we really wanted to understand that across the different languages, the ones that are linguistically similar or not. And one of the key takeaways here is that we should focus on data collection efforts to get some data rather than massive amounts of data, but most especially if you're trying to understand this from the domain specific perspective. Yeah. Okay. All right. So I will end with some key takeaways. I think, yes. So as Africans, and we wrote a paper where we did the collection for the speech and the text data sets, because as I said, we started out with nothing, we did something, and so we really just wanted to document that. We should really be involved in the data collection ourselves, sharing the data sets and in model development. And I also thought about this around the unconventional data collection sources. For example, we want to use mobile phone records to estimate population sizes before and after disasters. But when you look at the vulnerable populations, they don't have access to mobile devices. And so that's why I said I think here is that we should really think of the unconventional data sources that we have in our communities, those gaps that are not filled. What are those data sources? What are the ways to collect these data sets that are not commonly available? And in 2 of our studies, or 3, we have used radio data sets. Because radio or speech is freely available, at least there are radio stations right now that stream online, so you can easily get the data. You can be able to use it to build out models, and that helped us to get started at the point when we needed to do things around understanding perspectives of people, around pandemics in Uganda. We use radio data sets, which we found as a valuable source of data sets, but maybe the list can grow depending on your experience. Then there's this saying, the data moves at the speed of trust. We keep saying that because we find it very difficult. There's another project that I'm part of where we're trying to understand, to build out health work around different countries, Cameroon, Senegal, Ethiopia, and Uganda, and Kenya, of course. And when people are writing the proposal, it's very exciting. Yeah, we're going to give you our health data sets. Yeah, everything is okay. But when you start to implement and realize, oh no, we're not giving you our data. We don't trust what you're going to do with our data sets. Maybe let's first also build models ourselves before we give you the data set. So things like that. So many things come out. So I think trust is very, very critical when we think about this layer that we are around data. So the collaborations with stakeholders, private sector actors, civil society is important. What I have learned working in Uganda and working with the different stakeholders, because I come from a computing perspective, but you want to do work in health. And you know there's a radiologist who's collecting data, for example, screening women around cervical cancer. So you don't approach to them at the point where you think, oh, now I want to build a model. Where are you? Give me data. You have to start from the beginning. What is the problem that they want to see? And we've also learned that when you come with, I'm going to build my AI model, I'm going to give it to you, and you go to those experts in health, they'll be like, no. By the way, now, our problem is not the AI model. Our problem is a fundamental health systems problem. We want you to be able to register a patient digitally, to take their data here. We should be able to track the patient. We should be able to do X, Y, and Z. They give you all, there are so many needs that they want. But you only came because you want to do AI and you want to build your AI model. They were like, yeah, that's cool. That's fine. But we have fundamental problems. So I think approaching it from the fact that, yes, you want to get data, but there are also other people that you have to work with. They have their needs. They have their things that they're fronting first before your AI models that you're thinking about. I think that's important. And then communicating the value of the data collection to the stakeholders, having an inclusion strategy for community contributions, especially when it comes to language is important. And then the governance, we can't really emphasize governance, I think it's been said a lot. Fair, agreeable licensing structures for data collection, data sharing, that's important. I know in the law lab in South Africa, they're coming up. I think they released a license around African data sets, and I think all of us should interest ourselves in reading up about that work and the license that they have developed for African data sets. Yeah. So in conclusion, we know that Africa's data is critical to develop relevant, fair, and effective AI solutions, but it really starts with responsible and inclusive data practices. Without African data, we don't have African AI. So let's work together to build out the data sets for our models. Yeah, thank you.
Thank you so much, Dr. Nabende, for a really punchy but informative presentation. Oh, one thing.
I forgot I had a final slide. Sorry. So for the African project where we're building models for African languages, we have a GitHub page where we have put the models out there, publicly available. Please do scan this QR code. It will take you to that link. Choose your language, Yoruba, Hausa, I don't know, I forgot the list of the languages, but would really value your feedback from this community on how our models are doing in terms of understanding the different nuances about your languages. Because I don't speak Yoruba, I can't evaluate the model, but you're here and you can evaluate the models for us. Thank you.
Please scan the code. Please scan the code. Cool. So we'll just take one question. Anyone have a burning question? Yep. Okay, I'll bring the mic.
Thank you. My name is Stella Rotich. I'm from Kenya. I work for the county government. I'm so happy you talked about the collaboration, because most of the problems that we have as the governments in Kenya or in Africa, I suppose, is that so many systems are siloed, and every government department or local governments have their own data. And I've seen you really encourage collaboration. What's maybe your take or your experience in terms of making it at least have one place where there is a compounded place of data so that they can actually really work in these AI systems? Thank you.
Yeah, thank you. I think that's a tough question because we all tend to work in silos, right? So as researchers, I'll be like, oh, I built my model, I published my paper, bye. I've gone to the next, challenge or the next problem. And then we don't intentionally step up to understand what's going on with government, with the data they are collecting, because perhaps it's not our interest, right? So I think a solution is collaboratively. We need to kind of have this either led maybe from the government perspective, saying, okay, we have this data sets, all of us are in this realm of AI, and AI needs data. How can we work on this together? I don't think it's something that as researchers we can do by ourselves, or as government you can do yourselves, because you might have the data, but you have the researchers who could actually work with you together to help find issues or help you to build out AI systems based on the data sets that are going on. So I think there's this collaboration in government, private, education space should be something that should be a talking point, maybe pushing it from a government perspective and seeing how these different places or players can be able to collaborate together. It's a difficult one because even us within researchers, you end up finding that you're working in silos, right? So let alone government, which also is doing the same thing. So I think it's a very big conversation that we have to continue and be very intentional about it. Yeah.
Thank you so much. Okay, and I'm going to introduce our final speaker for the data track before we let you go for a short break. Teresa, are you... Sorry, just because I haven't seen you. Oh, perfect. Okay, so introducing our final speaker for the data track, Teresa Uwimana is the Director of Data Revolution and Big Data at the National Institute of Statistics in Rwanda. She coordinates a department for data scientists to scope and deliver data science projects that support the Institute to achieve its mandate of supporting evidence-based decisions made across the government. She also serves as the program management unit of the UN Regional Hub Big Data and Data Science for Africa. And her focus is establishing an enabling environment for big data systems, administrative data, and use of tech to enhance frequency and efficiency of statistics production. Please give Teresa a round of applause.
Thank you. I wanted to check whether it's still morning. Good afternoon. Okay, as he introduced me, I'm going to share thoughts around official statistics, but I want to make a disclaimer. These are just my own thoughts. I'm not necessarily reflecting the National Institute of Statistics here in Rwanda. I'm going to tackle, I was also requested to think about the talk that we had from Dr. Abeba. Thank you. I think she left, but she really shared insightful thoughts around AI and the issue in data. So I'm going to talk about the perspective when it comes to official statistics. I want to frame the context to why statistics. Why normally do we need statistics? Most of you might know it, but a lot of questions comes. We need actionable insights. Data in itself, there has been a long debate around data as gold, but actually data in its raw form cannot serve unless we derive insightful, actionable insights. So we want to understand our world, but we also want to plan. You can only plan if you know where you are at the moment and where you want to be. We need baselines. We need to monitor progress. we need also to evaluate the impact we've made over the time. We also need to target our interventions as a government, but also private sector, entrepreneurs. We need to be informed about the next step we are going to take. But there are barriers to statistical uptake. Previous speakers have highlighted on the scarcity of data, but there's another side of the story. There's data, but most of the data is not even effectively used. Why? Maybe lack of expertise, maybe silos. My previous speaker just mentioned the silos. We work in silos. Data is in PDFs, huge books. So it's not easily foundable, but also we've received in the past complaints about timeliness. Everyone is like, I want data now. But do we really know what data is available out there? If you can help me to move to the next slide. Okay, thank you. So today we are here focusing on AI. So I wanted to bring about AI as a solution to all those barriers, specifically in the office at the National Institute of Statistics. The department which I have the privilege to lead is focusing on research and development when it comes to embracing technology and how it can help us tackle some of those challenges I just mentioned. So at the moment, we are leveraging AI when it comes to automating some routine processes. We are also leveraging technology to improve or to be able to do almost close to real-time data analysis. But mainly, the point of today, I wanted to emphasize on data uptake. At the office, we produce at least some data, but we've realized that it's not even consumed. Even the less we produce, it's not even optimally consumed, and there are a lot of reasons as to why it's not efficiently consumed. But we also want to improve accuracy. So I wanted to share some of the use cases we are exploring at the moment. First of all, to tackle the availability of data, accessibility of it, we produce a lot of statistics on monthly, quarterly, annual, and like census, only we produce it in 10 years gap. But we have other sort of statistics. For instance, inflation, we produce them monthly basis. But all of that, it's not consumed. Even the little we produce is not consumed as we wish. So we've realized, we conducted a survey, satisfactory survey from our users, and we realized that they complain about PDFs. We normally package our data in PDFs, a lot of PDFs, and a lot of pages. So you can imagine some of the users that are maybe on a busy schedule, they will not have time to scroll all the way to the exact page they want to see. So we are revamping our website, and we are leveraging chatbots, and we are making sure that we make our data in a machine-readable format, not necessarily PDFs, so that at least the metadata is there. I remember there is one speaker who mentioned, I think it's my colleague on the table, he mentioned actually, do we produce African data? I wanted to think of that. Actually, we do produce data, but not necessarily in readable formats. So that's something we are working on to make sure that, because if you type in Google any search, and maybe you ask numbers about Rwanda, you will not necessarily fall on our website, which is the official, which should be the official source of data on Rwanda. But because of how we package our products, you will maybe fall on World Bank website or IMF other websites. So we still have a long way to go, and we need to tackle those challenges. So we are working on the website to make sure that we package data products in readable formats for AI machines and agents to fall on that website. Again, we've realized that when it comes to gender, we still also have a gap. So we are working on AI-powered tools to make all our surveys and data products, they have the gender thematic area, but in silos. Again, they are all in silos. So if a person wants to have a take on gender data, it will require that he moves from one PDF to another, one report to another. So we are also tackling that to make sure that our gender data is easily packaged in one single, like one single click can give you access to all the gender data we have. We are also exploring the NLP to classify, because we correct a lot of free text. So we want to automate. For instance, at the moment we are exploring how we can classify or automate the classification of occupation text that we correct, which is normally free text. So just to observe that even the data we have, I acknowledge that maybe African content we are not producing maybe a lot of data, but even the little we have, are we using it efficiently? So that's what I want to share, maybe to leave you with today. Another use case we used back in the days, it was back in 2022 when we conducted our fifth Rwanda population and housing census. It comes once in 10 years. So we were privileged to do a homegrown solution where we embrace technology. So normally after the census, we conduct a survey to assess its quality and coverage. It happens 1 month after. So during that survey, we did data linkage where we used deterministic, probabilistic, but also critical review. And that homegrown solution gave us back a dramatic impact on, like we were able to shorten the time, which used to normally take 6 months, took only 3 weeks. And we could also monitor the coverage during the census. Like we were in all households across the country, but we could also monitor the progress. So I just brought, I was not able to package it in a research form, but I provided a link to the full report for the researchers to go deeper into the methodology and all we did in that survey if you are interested. But I brought this use case to emphasize on homegrown solutions. We are able, African talents are available, but we also need trust. We also, because similar work, we used to call upon experts, but we were able, because we had the trust, they trusted in us, we were able to do it no cost. We are normal staff, permanent staff, so they didn't have to pay us more cost, but it was done thanks to partnerships, but also trust into continent talents. Sorry. So this is my last slide. I brought back the thoughts that Dr. Abeba mentioned. Yes, we have bias in data, but there is what we can do about it. So we need to use diverse representative data sets, but also audit our models, because we cannot take the luxury to just deploy models, because so if someone else is doing something because he's not interested on what we do, what are we doing about it? So we need to do our homegrown solutions. And when it comes to privacy, I wanted to emphasize on what Dr. Abeba mentioned, legal frameworks. Here in Rwanda, we launched the law on data privacy and personal data, and it was back in 2021. but and that role gives full rights to the data subject. To give you an idea, for instance, I can walk into a telecom company today and tell them, you know what, never use my data again. And I have full rights on that. But maybe what we need, what is happening at the moment is literacy, so that every data subjects know the rights they have on their own data. Also, when it comes to sustainability, we need, wanted to challenge universities here present. I've seen some, maybe I will not mention the names, but all the university experts that are here, what are we doing on the training? I've seen in these developed countries, actually industry go back to fetch talents in university. But in our side, correct me if I'm mistaken, students are still struggling even to find internships. I don't know whose the blame is that, but we need to bridge that gap. We have talents, but they are not well equipped to explore their talents. So we still have a long way to go, and we need to tackle our issues. Regarding the accountability and transparency, yes, we need to be transparent in what we do, and Dr. Beba put it very well. We need to define responsibilities. Whatever tool we are putting out there, what is it doing about? But also as Africans, we need to train or to do the awareness when it comes to writing. I remember there are forced consents we do all the time. I don't know if what you do, but for me, there are these applications when you are going to use it, they will say you first tick agree to terms and conditions. How many of you have read terms and conditions? I can only see 2 hands. Yeah, they make sure those terms are very tiny and very small, and they are very huge. So we always have to conquer to accept, yes, I accept terms so that we go to the next. But actually, they make sure that they write those terms, but we are not good in reading. So we need to do our assignment. And with that, I would like to thank you.
Take one question. Okay, we'll take one question. Cool. Way at the back. Can someone get the gentleman a microphone?
Thank you for the presentation. So we talk a lot today about the quality of the data. So for example, we talk about the bias in the historical data. We talk about, for example, in your case, the PDF, and you are trying to find solution on how to tackle those PDFs, for instance. My question was, are we also working on initiative to improve the data collection itself? So in order to be able to have quality of data and control that data to avoid all the bias and have structured data that you can leverage for AI.
Thank you for the good question. For official statistics, we normally have standards. We not claim that we have 100% quality, but we always, for instance, for the reports we do, we say the margin of error. We never achieve, like we don't achieve 100%, but we try the best, and we also highlight what is the error range you are in, so that you are confident in whatever products we put out there. So at the moment, what we are doing on the data correction, not necessarily the quality, but yeah, it's interlinked. We've moved from, like in the past, we used to do paper-based data correction. So you can imagine even errors can be like when you are doing data entry, obviously, depending on the handwriting, you can do some errors. So at the moment we are doing digital data correction, at least is helping in the data quality assurance. Also in the tools we do, like at the moment we use copy-based. I don't know if you know about CAP, it's like phone-based data correction. So you can even control some errors. For instance, if I'm correcting the price of banana, instead of saying 2,000, I do 20,000. So we control that, and we tell you, are you sure this is 20,000? So yes, we do, like, technology also gives us the possibility to control for human error, kind of. Thank you.
Thank you so much. Please give Teresa another round of applause. So that marks the end of the data track for today. We're going to take a short break. How are we feeling? Good? Tired? Could you do with a break? Cool. We'll take 10 minutes. Please head out to the lobby just outside. Do grab a snack, grab some coffee, grab some tea, have a chat, and then we'll return here again in, let's say, about 12:40. If you can come back here for about 12:40, then we'll get set up for the presentations on the concept note that Eric mentioned at the beginning, the Pan-African Research Center and the AI Scientific Panel. But thank you for joining us, and we'll reconvene in 10 minutes. Okay.
let's get back in the room and continue the next section.
If we can get the slideshow. Very good. Very good. Welcome back. Welcome back. Okay. So in the morning, I mentioned that we'll take a few minutes before lunch and the last session to speak about some proposals we are working on for how to solve some of the problems we've been talking about, and we will continue talking about for the rest of the day. So Qhala, the organization that has worked with partners including CMU Africa, Carnegie Endowment for International Peace, Masakane, to put together this colloquium, is working to make a proposal for a Pan-African Research Center. And we would like to get your thoughts on this proposal. It's still very embryonic, so this is the right stage at which we would like to get the brain power and experiences of the folks in this room to help us shape that idea. So I don't need to explain why research is important. Many of you know, for example, that Xerox Palo Alto Research Center is what gave birth essentially to the modern era Microsoft, Apple, and IBM. Xerox was making a lot of innovations 3,000 miles away from their main office. And when people like Steve Jobs and Bill Gates got chances to see the work they were doing, they realized they were sitting on gold and converted them into, for example, the graphical user interface, which made the personal computer a reality, and a lot more. So research doesn't have to be justified for this audience. But we have a lot of gaps on the continent. So if you look at this slide, these are numbers I've pulled from various sources. That's why I'm not even bothering to cite it. But really, if you look at global research publications, you can measure it anyhow, whether it's like top-tier conference papers, journals. Africa is contributing less than 1%, even though we are close to 20% of the global population. So we have a huge 19% failure gap there. There's a measure of health researchers per million people, and we're at just 20 on the continent, compared with 250 in Europe, right? Which has huge impacts on health, because healthcare is one of the areas that really benefits from methodical, systematic, long-term research. If you compare ourselves to other parts of the world, 200 researchers per million people total, health, mathematics, sociology, anthropology, compared with almost more than 4,000 in Canada and the US. And then the last point I'll mention is that Africa is taken advantage of. We have a lot of parachute studies, or what are sometimes called helicopter science, where folks from outside come into the continent, do some research work, they leverage the talent, the brains we have here, they go out and publish and become famous and grow their careers, but then the communities from which that research was done do not benefit. So these are the gaps we would like to address for the AI question on the continent. So this is a very small list. The list could be bigger, but just the main causes of why we have this gap is limited funding, skills gap, and brain drain. I mean, I don't want to call Professor Thierry Tambe brain drain, because at least he gave us his 1 hour this morning at 1 a.m. But what if we had all that on the continent, right? Fragmented data ecosystems. You've heard from Teresa, about some of the challenges they're dealing with in the Rwanda National Institute of Statistics. And then dominance of non-African AI systems. And this last one is huge, but it basically means that who has the storytelling?
It's OpenAI. It's Google DeepMind, right? What are we trying to build on top of? Is LLMs coming from China, from Europe? So these are some of the problems we hope we can solve with a Pan-African Research Center. And so what are our objectives? The objective, first of all, is to have some, research areas that we pay attention to from the Africa-specific context: healthcare, agriculture, education, governance. The problems here don't need to be enumerated for this group, but we could increase food production by a lot. We could cut disease prevalence and mortality by a lot. And there's already use cases that are shown that AI can contribute massively here. So that's one area: conduct and coordinate the research by having actual research scientists on the continent doing this work. There's a few attempts here and there, but again, the gap, as I showed you on my first slide, is huge. The next objective of the Pan-African Research Center on AI, if I can get the slides to move, is to build capacity, right? So the next session that's coming up is going to speak about the AI talent pipeline, but we would like the center to be a champion for this. Our next objective is to foster collaboration. There's a lot of efforts, minuscule or varying degrees of effort across the continent, right? There's, I think, research institutes and labs in South Africa, in Kenya, in Ghana, and Nigeria you had this morning. But there isn't as much collaboration as we would want. So ideally, we want the research center to help with this in terms of partnerships and knowledge exchange. Finally, we would like to really focus on ethical and responsible AI. Abeba's presentation this morning has highlighted what happens if we don't take lead on that, especially for marginalized communities. Finally, and this is very important, we want to inform policy. And Kojo is going to speak next about a scientific panel that we hope will play an active role in this. But that would be one of the remits of the Pan-African Research Center. So this is, again, a very embryonic proposal, but we envision a combination of a physical space, a virtual space, and a network of support communities. So the physical space could potentially be, physical research labs, offices, and collaborative spaces in, key African cities. And they will have actual physical infrastructure, including compute, right? Equipment, call it whatever, theaters, where researchers can do their work, and where we can deploy the research outputs. The virtual space essentially would be access to folks that are not in the physical space, right? It might be online seminars, hackathons, and a library, an archive of sort for educational resources. And then the collaborative aspect will be built out of the network of support communities, so that we bring in individuals, companies, institutions, and governments as part of our network. So we imagine the Pan-African Research Institute being a hub that then helps support the network. But we do have some questions to you about if these perspectives are really legitimate. And in the next 1 minute, I'll bring up some QR codes for a Mentimeter, so you can get your phones activated, phones or laptops, so that we can get some feedback from you for just about 5 minutes. So the organizational structure we envisage will mimic, a top-tier research lab in any, global institution. So we imagine having a president or director of the Pan-African Research Center, and then having PIs, principal investigators, who will actually be the main drivers of the Pan-African research initiatives. Under the PIs, it looks like any other, university, academic department, or research center. You'll have research scientists, right? We imagine PhD holders and young postdocs and potentially even master's students working directly in projects that are championed by a PI. And then, of course, we need engineers to build out some of the products that are built. We need research assistants. and we need admin staff. And then we do need leadership and management outside the day-to-day running, including an advisory board and an ethics committee. Where are we going to get the money for this? Especially in the global environment that's changing now in ways that make some things more challenging. So these are some of our ideas, grants and donations, but I would want to challenge that to come from Africa itself, right? Can our governments fund this? Can African philanthropists come in? Industry partnerships, right? Where there's a collaboration between tech companies on the continent, and not just tech companies, right? It could be financial companies. It could be agri companies for joint research projects and funding. And then hopefully get some research contracts that are funded initiatives for specific societal challenges, and then be a potential revenue generator, right? Where there's consultancies and training programs that can generate income for the Pan-African Research Center, they're calling PARCAI. So this is the time for your views. We don't have too much time for questions, but actually we want to collect views. So please scan this QR code and take 1 minute to answer this question, and then the next 2-3 minutes before I hand over to Kojo. So the first one is, what's the most compelling part of this proposal? I know there's a lot of details that are not here, but just give your top level thoughts, right? So just take a minute and just provide your input. And then as you think about this question, the next one is going to be, what's the least sorry, 1 second. Slides are moving too fast. So that one is, what's the most compelling part of this proposal? 1 second. Okay, so maybe as you answer the first question on what's the most compelling part of this proposal, I'm missing one QR code here. There was a question about what's the least. Also speak about what's the least compelling part of this proposal. Yeah, so add that. What's the most compelling part of this proposal? And then what's the least compelling part of this proposal? Like, what obvious weakness do you see? And I know there's a lot of questions and details we've not covered, but just off the top of your head, right? Is this amazing? Is this nonsensical? Is it risky? Yeah, please add those two parts in this question. What's the most compelling part, and what's the least compelling part of this proposal? And then we hope in the rest of the day, feel free to come up to me and Kojo and offer some of your feedback, and we want to incorporate as much feedback as possible. Show of hands, who's done with this part, so we can move on quickly. Okay, good, good. The next question is, do you think a Pan-African Research Institute should primarily be, number one, a physical location, a facilitator of other research centers without having a physical location necessarily, or some combination of one and two above? So just give a brief reason for your answer. Like, should we not bother setting up research labs and lecture halls and buying land or whatever, and just focus on being a facilitator of existing initiatives? There's the Mind Institute at WITS. There's University of Cape Town has some research work going on. Private companies like Google have work going on. Microsoft, InstaDeep, you heard from them this morning. So should this Pan-African Research Center, potentially duplicate some of that work? Although, as I say, there's a big gap. So I don't think there's actually enough of us to duplicate efforts. Or should they be some combination of one and two above? Just provide a brief reason for your answer. You have 30 seconds to get this done.
Okay. For the folks that want to start thinking about the next question, and we're almost done here. Given the changing landscape of international aid, what funding sources should the research center prioritize? I gave my point of view for African government funding and African philanthropy, but what's your view? You know, where should we get funding for this initiative? So this one is on funding. And then also provide any additional ideas on this, additional thoughts on this idea. And then finally, we want your engagement. I think it's rare to gather a group as talented as this in one location in Africa. So this are you interested in further brainstorming this idea? Please submit an expression of interest so that over the next few months we'll build on your expression of interest to answer some of the questions that I've already raised at a more thorough, deep level. This QR code is new, I was just informed, so it needs to be scanned. And then we'll get done in this section in the next 1 minute. Is anyone done? I hope 1 or 2 sentence summaries is good. It doesn't have to be a dissertation.
We'll just give a minute for those of you filling in the expression of interest, but there will be another opportunity just after I discuss the AI scientific panel, because the expression of interest form is the same as those of you filling it out would have seen. All that to say, no rush. Okay, perfect. So like Eric indicated, this is another nascent idea that we've been working on. It's very well connected to the AI Research Center that Eric was just talking about. Yeah, it's also a very nascent idea, so even more nascent than the Research Center. So the details are a bit more vague, but I hope it's at least clear enough to indicate the direction of travel in terms of how we're thinking we can really mobilize the scientific panel to advance Africa's AI agenda. Okay. So just in terms of some context and background for this, this leads off from the UN's Global Digital Compact, which mandated the creation of an independent international scientific panel on AI and a global dialogue on AI governance, which is a mouthful. That's the actual title of it. But essentially, it's a multidisciplinary body of independent advisors with a broad geographical representation who will provide scientific assessments on AI risks, opportunities, and impacts, and foster global collaboration around AI governance and policy. Great. However, the problem with this, or one of the challenges with this, is that African representation in the global AI governance is extremely limited. And that Africa is the focal point of numerous AI researchers. I think this colloquium is pretty self-evident of that. We're not sure, I mean, relatively speaking, we may not have as many researchers as other regions, but Africa still has a ton of dedicated, passionate, intelligent, smart researchers. But coordination among them is quite constrained. I'm delighted that Qhala was able to put together this colloquium, but these colloquiums, these events should always be happening for us. We should always be filled with opportunities to gather and advance the African AI agenda. So we figured there's a need for an equivalent African body tailored to continent-specific challenges, priorities, and contexts. Hence the creation, or the concept of the creation, for the African AI Scientific Panel, which would be a multidisciplinary advisory group of researchers bridging AI expertise and policy to inform strategic policy decisions. The main objectives of this panel will be to harmonize AI policies. Many of you would probably be aware of the forthcoming Africa AI Council, which is a multidisciplinary body of Africa's ICT ministers, industry players, which is also advancing Africa's AI agenda, coordinating and harmonizing policies on the national and continental level. However, there is a considerable need for evidence-based recommendations. Just to give an example, because we've had presentations on compute and data, if we're talking about developing a data center which can be shared on a regional level, where should that data center go? Who is informing this research? If we're talking about data sharing frameworks, what data sharing frameworks are we talking about? What needs to go in that framework to ensure that data can be shared securely, safely, and effectively? This is where the African AI Scientific Panel should fill the gap. Just noticed some slides have gone, but thank you. So the harmonization of AI policies, particularly thinking about cross-border policies, not limited to that, but placing emphasis on that. The panel will be useful for enhancing AI education, particularly with policymakers, and fostering research excellence, facilitating pre-standardization dialogue, so ensuring African priorities shape global AI norms around data governance, interoperability, and ethics, and it should also promote international collaboration, so the idea of forming global partnerships to advance responsible and contextually relevant AI governance in Africa. And this links back to what I mentioned about the UN. We have these global governance forums, but we also don't have enough a robust, coordinated African AI research panel to negotiate dialogue in those spaces. So why this matters? Again, just to recontextualize the avoidance of fragmented policies and duplicated efforts. Many different countries are conducting their own national research, but I think what we hope is the panel will be able to pull some of that together and ensure that if Togo's doing research and Ghana's doing research, that they're looking at distinct things and not duplicating the same research on the same issues on the same topics, because it's a waste of resources. Maximizing efficiency and socioeconomic returns, ensuring responsible, inclusive and context-specific AI governance, and broadly just raising the profile of Africa's AI capacity. Again, this space is self-evident of that, and we want to continue to build on this platform, build on the energy in this room today, and advance that further. In terms of the functionality, this will be a collaborative research focusing primarily, again, on cross-border policy issues, but not exclusively. And it will make practical recommendations on infrastructure standards and ethics to policymakers. And policymakers who are thinking about spaces like the African AI Council. So yeah, it will facilitate regular dialogue between researchers and policymakers. Okay. So, just to draw to a close, in terms of gathering thoughts, this is the same Mentimeter that Eric had up. So if you've already scanned it, if you still have the tab open, You should be able to go to, yeah. 1 second. Bingo. So if you have the tab open, you should see the question, what is your general impression? Please feel free to add any thoughts. We want to collect your opinions, your views, whilst this idea is shaped. And as mentioned, there will be an opportunity if you do want to be involved in the panel to express interest in that moving forward. So just give a minute for this. Okay, I'm seeing some responses coming through. Assuming that's all okay then. So again, yeah, just general impressions, any broad thoughts you have, challenges we should be aware of, particularly use cases you think this would benefit, all of that we'd love to gather. About 20 more seconds and we'll move on to the next question. I believe there's only 3, so it's not too many. Okay. 10 seconds, anybody still responding? Okay, we're going to move on to the next slide. Why might this initiative fail? I thought I'd ask something quite provocative, but I'm sure there are numerous ways something like this can fail, so we do want to surface that and begin to think about, okay, how do we mitigate the worst? Thanks for flagging. Let's have a quick look. Bingo. Thank you. I've updated it, so it should be updated on your screens. We'll also give this a minute. Okay. Maybe 20 more seconds. Just to surface a couple of responses I'm seeing so far, actually, particularly about financial sustainability, proper coordination, transparency, and involvement of African policymakers as well. That needed to be quite refined and robust and well defined. Okay, going to move on to the final question. Okay. What potential do you see for this panel to positively impact African AI policy? What potential do you see? So yeah, feel free to feedback, let us know in terms of what this could be. Dream big. We'll give about 20 more seconds. So I'm seeing responses about strengthening the capacity of research, policymakers being having their decision making enhanced, an African voice on a global stage, raising awareness for talents. Yeah. Thank you. This has all been incredibly helpful. I'm going to move on to the expression of interest slide. This question will stay on the screen actually on your phones. But like with the research center before, this QR code leads to a Google form. So if you do want to join the panel or just be kept up to date with how it's progressing, then you can indicate that on the Google form. Then we'll be taking some of your thoughts and feedback, figuring out what shape this should take in the future, what shape the Pan-African Research Center for AI should take in the future, and then we'll be keeping those of you who sign up to be kept in the loop up to date with how that's progressing. And for those of you who aren't interested in being kept up to date via an email, I'm sure you'll see us talk about it on Qhala social media platforms and some of our partners' platforms moving forward. So there will be more opportunities to learn and engage beyond this point. Okay. And with that, we'll draw this section to a close. I'm going to move on to introducing our next host for the talent track. Okay, so welcoming Joshua to the stage. Joshua is a digital economy expert at Qhala, as lead investigator, and particularly has worked on developing the AI Talent Readiness Index and AI Talent Working Group at Catalyzing Africa's AI Leadership Project. Joshua will be introducing the speakers for the talent track, in addition to presenting an AI Talent Readiness Index, which looks absolutely phenomenal. And I'm really excited for people to see what Joshua and the team have been working on. So without further ado, please give a round of applause to Joshua.
Thank you, Kojo. Thank you, Eric. Thank you for the claps. Before the white man came to Africa, they used to refer to Africa as the white man's graveyard. And the reason behind that is because of mosquitoes. Well, until they found out a cure for mosquitoes, or at least treatment for mosquito. So now I'm going to teach you the reason why mosquitoes do not affect Africa as much is because once they came, we used to go after them, we catch them, and we kill them. So that's how we are going to clap for these guys in case you're still catching up. So this is how it goes. Mosquito, mosquito, mosquitoes. Catch it, kill it. Yeah, that's how we used to do mosquitoes back in the day. So let's clap again for Kojo and Eric. Mosquito, mosquito, mosquitoes. Catch it, kill it. Great, thank you guys. So I'm going to introduce Tim, Dr. Tim Kananu. Just a moment. Dr. Tim Kamano, he's going to take us through talent. He is a data scientist with 20 years of experience in mathematical modeling, statistical analysis, and machine learning. So his expertise spans large, big, complex data sets, numerical methods, genomics, disease research, and business intelligence. He serves as the data science lead at Engage, an interdisciplinary project with the University of Nairobi and the University of California. So welcome, sir.
Thank you very much for the introduction. Before the slides come up, it's exciting to be here. Thank you for the invite. It's been long since I was in such an Afrocentric congregation, trained by NEPAD under the AIMS flagship. So it's quite good to hear talks that one, they're very genuine, very, very genuine. Birhan was here mentioning quite the state as it is. We've had also engagement from Professor Tambe about challenges that we've had and how sometimes it might be, although we have the resources, the silica, the sand, it might be very hard to also implement cheap manufacturing in Africa. But how do we move from there? So it's exciting to discuss these real problems, as well as intertwine it with talent development. So before I came, when I was trained overseas, and my supervisor always used to ask me, oh, the slides are here, but I'll finish this. Tim, what's up after PhD? I would say, I'm going back to Africa. Yeah, so after some time, 2 months, what's up, Tim, after the PhD, what happens? I'll go back to Africa. It was quite something to come back to Africa and actually realize why he was asking me such a question. Eh? But the long short is that I think talent development should precede compute and also should precede even data. Because without talent and robust talent pool, then there is quite a lot of challenge. You may have idle compute, which is a nightmare also, and also not value for money. So I'm going to be talking about Engage. How do we unlock AI talent for cutting edge research in Africa? Engage is, I'll give a bit of background on that. And then I'm also going to talk about Dusk Lab, which is, I founded after the challenge that I just told you about. How do you actually encourage students to start computing, learning and computing with data? I don't think I'll speak about much about the data science department, but I can say we have around 60 master students in the latest cohort who are studying data science. In last year we had around 20, and we're also recruiting now for PhD. So quite agile students, quite interesting. So I want to take you back, or as I said, the stage to the founding fathers, our founding fathers of many African countries. They identify these problems. In the morning we heard about so many AI-related problems. But actually, interestingly, I think you can relate to these problems now. We are talking about 60 years ago, but the problems still persist. So we have hunger, which is related to poverty. We have disease. So at Engage, we're actually looking at the two problems, poverty and disease, and hopefully maybe hunger might self-sort. But why are we here? Why are we here after 60 years? We're here because, as you heard from the previous speakers, there is silos everywhere. Yeah, so everybody works alone, and then the scientific approach, I think, is still wrong somehow, because what we did was to establish physical sciences, social sciences, biological sciences, delve into this, get specialty training in them, and we were never taught to work together. Yeah, so there was mathematics in the middle, and mathematics has quite a number of formulas, and I think if we avoided that as mathematicians, and I promise to do that, it will be quite approachable to other people. Yeah, so the learning space and the problem space that is addressed through the current scientific rigor are very different. There is no problem out there that is a mathematical problem. There is no problem that is a chemical problem or physical problem. So all of them require a lot of collaboration, as the speaker said, so that we can now think about teamwork, group work, and then multidisciplinarity. So amongst the humble submissions, based on my experience, I think that's one of the things that will suggest as we train AI pool, we should think about dismantling the kind of training that we went through. We must also be alive that AI is here. If you actually, one of the things that I worry about is that a student can just go to the current learning resources and get the best set of notes to teach themselves on something. So that tells you that these fields might not really be sustainable into the future. So learning, education in the future might be predominantly AI-led, yeah? And we must also integrate that as we teach our students. Oops. But then again, AI has come to give life to mathematics and statistics because it's the only way that now we can communicate and get closer to the other fields. Remember, all the other fields are centered on data, and AI is data-based, data-driven. So it's becoming much more easier to speak about machine learning, get a bit of acceptance into the need. So AI is actually an integrator. Now the challenge of the problems that we had before is that when we were having or making decisions, they were somehow hypothetical. But now we can make and encourage data-based decision making towards actually solving problems. And that's what Engage is all about. So this is a challenge of, I was speaking to earlier. So I come from, that's why I trained for my PhD. We were working on supercomputer Shaheen with quite a lot of resource. We didn't have TIOS, kind of infrastructure. There was a lot of endowment that gone into the computing, so you could do actually virtually anything that you wanted. You'll test a system, and it gives you a lot of ideas on what you can venture into. But now, what happens when you're trained in this and then relocated to Africa, where you actually don't find value, yeah, in what you learned? So that was a challenge. Also, I spent some time at A&M, and it's extremely interdisciplinary. I think that's where the world is going. And if you look at most centers, and as you spoke about PARCAI, we should think about interdisciplinarity. So you should not only be led by AI or experts or data scientists. We should integrate multiple fields so that everybody feels included. As well as AIMS, where I'm actually here because of AIMS, and actually even the setup of Engage is AIMS-like, and that's why we resonate quite a lot about it. So, first recommendation as we think about AI pool and talent development, we need to address some differentials. And these differentials are into what is taught and actually what is expected on hire. So there is a very big, and Teresa, I think, mentioned that challenge, and she's actually one of the employers in Rwanda. We need practical, domain-based problem solvers, yeah? We need to address our biases, as we said. Statisticians, mathematicians never used to love coding, yeah? Computer scientists, not interested in theorems at all, and chemists, biologists will prefer to be in the lab. But how do we now bring them together? And that speaks into our own personal psyches as disciplines as well as individuals. So let me talk about Engage. Engage is it means enabling girls in AI and growing expertise in data science. That's our website there. You can get quite a lot of info on that. And we seek to train around 885 girls and women in Kenya, as we promised the funders. It's funded by Takeda Pharmaceuticals. And the goal is to endow them in skills in AI machine learning as applied to in public health, as well as to reduce bias. Now, bias was quite discussed here, but we must also acknowledge that there is a bias that the dominance of men in data science and AI creates. As much as we acknowledge there is bias in data, then there is still bias in the way we try and tackle problems algorithmically as a gender male. We also need to build capacity, appreciate and evaluate and solve community-based problems. And by saying community-based problem, I'm anticipating my second recommendation, which will be to reduce or eliminate brain drain. I'll mention it a bit further. So it's a collaborative project between University of Nairobi and University of California, San Francisco. So my collaborators are the principal investigator, which is Professor Julius Uyugi. He is in the Faculty of Health Sciences, which specializes in medicine. Then there is Fiti at UCSF, and Fiti is an informatics specialist, and then I'm based at the Faculty of Science. So there is multidisciplinarity in that aspect. We are targeting to train girls at 3 levels, and there's a reason for that. One, we want to train around 480 secondary school learners. So we must develop talent, AI talent, from the bottom up. So we inspire the next generation of data scientists right from a very early age. The second group that we wish to engage are diploma students. Diploma students are usually, in our current setup and most African countries, is that the students that make the universities actually are the top performers. But we're looking actually for students who have very good aptitude in mathematics. Then we are also looking at Tier 3, which is university and undergraduate students, and equipping them with skills to handle problems within their areas. So if you look at this map, we are not working or training the students at the University of Nairobi. We are working also with regional partners. The regional partners are in different locations across the country, and for the first year, pilot year, last year, we trained 90 girls, and that was around 100% over, and that's why we say we're training around over 1,000 data scientists for the next 5 years. We are looking for solutions to problems around their neighborhoods. So we are not translocating them. We are not moving them. We are not supporting the drain of expertise from the local environment in which they're exposed to the problem and understand it better than anyone else. So most of them are from poor backgrounds, and the average age was around 21 years. And we also buy and equip the local universities with computers that can be able to handle ML tasks. And these are the girls when they start the training, the 90 girls. So these are from 4 centers, and that's during the training itself. So the second recommendation is that collaboration is key. We need North-South, the traditional collaboration, but we also need local collaboration, and also we need to really think about equity as well as mutual benefit. So we have a fused curriculum. By fused, I mean the X that we describe in statistics is actually a real data set coming from public health. And then now we use data science skills to understand it better. So the third recommendation as we think about AI pool, talent pool, is we have to focus on measurable problem-based packaging in terms of teaching and learning. So our program incorporates 3 weeks of rigorous training, 1 week of capstone project, and 6 weeks of paid internship. Paid internship is quite great with the community-based organization because we drive value to the partners. Then we need to encourage teaching and learning with data. AI is a practical-based subject, and ever since I came back, I tried to experiment that at Dust Club, and it works quite amazing. You can see the applications that the students just generate from a typical class in third year. So we had a problem with class attendance, and they gave a solution for that. We actually also predicted the US elections to almost 99% accuracy in 2016 and 2020. The last election was too hot to shout about, so we stayed away. We're also trying to get seismic research going. This is, we have a notion that Africa continent is splitting up. So can we drive that kind of research? What can we do in the AI space to, rather than being recipients of information from elsewhere, how can we deploy analysis and systems, agentic systems to kind of learn what is happening beneath us? There are quite a number of problems, computation-based problems that we are trying to look at, and some of them cancer, mental health in South Sudan, to get the relationship between violence and mental health status in war zones. But the sixth recommendation is that we have to focus on open data, truly open data. Yes, we have the big tech and their hunger for profits, but we really need to focus on that. This is a project by my student. We are trying to use CNNs to improve classification of chest radiographs, because there are some areas in Kenya where you can't domicile some radiographers because of security challenges. So can we deploy AI models to help with diagnosis of disease from that? And we had a lot of challenges to get that kind of data. There's also cancer research. Cancer is localized in different cultural environments, depending on foods, depending on ways in which we are interacting with the environment. And I think we have the best. Personally, I think I have the best gene predictive system for identifying some small guys who cause cancer called microRNAs, but that's a subject for another day. So these are sample results from our local servers with a little compute that we have, and it soon should be available for that. Then the other thing is pedagogy. How do we teach? How do we mentor our students in the AI training programs? We have to mentor ambassadors. We have to be, it's not about only instructional. We must also ingrain in them a passion for solving problems within the African continent. This is an example for one of my PhD students running a course on AI and machine learning in South Sudan, in Juba. Yeah, so I'd like to leave you with just a 4-minute video. So I think if you can, that's my last, about the engage and challenges when we are thinking about training AI given the current status. So kindly. You say the DJ? The sound. Yeah, so this is one of the beneficiaries of Engage, and there are 90 stories like these ones. Girls come from very poor backgrounds, and there is a reason we chose poor backgrounds, because they are also agile enough to commit to the problems around them and solving them. And we all know in the rural areas in Africa, you'll get this kind of girls not pursuing specialized training because of lack of resources. So, could you get the audio?
My dad, my mom, and 3 girls. I'm the second one. My name is Beatrice Wanjiro Gathogo. I'm from Murang'a County. I'm from a family of 5. My dad, my mom, and 3 girls. I'm the second one. Unfortunately, we are now 2 girls. My small sister passed on in 2017. My mom passed on in 2023 to cancer. My sister is married, so it's just me and my dad at home. My dad is a farmer. My education background started at Wangai Primary at Murang'a County. I did my KCP, then I joined high school like a couple of years later because we didn't have like finances to take me to high school. So actually we used to school with my sister, but for her she couldn't wait for any help maybe from elsewhere. So for me I waited because I was passionate about education, and I got a sponsor who took me to high school. I schooled at Ruare High School in Nyeri, and then I joined the Dan Kimathi University of Technology in 2020, and I pursued a degree in Bachelor of Business Information Technology, that is BBIT. I graduated last year, date 6 December 2024. I learned about the Engage program through our class WhatsApp group, and what inspired me most was because it was involving girls from underprivileged backgrounds, and because I'm one of them, I got interested, and because I was like interested to know more about data science and machine learning, I tried my luck, and I was one of the students that were selected from DICO. What inspired me was that I knew I'd get some skills from the program, because it was hands-on, and still I keep saying that students from IT, BBIT, CS, we are kind of on the fence. You don't know what to do with your life after the course. So for me, it gives me a way of finding my career path. The training was amazing because we were well taken care of. We had a good time with our regional coordinator, and some lecturers were around. From Monday, all the classes kicked on. It was an amazing 4 weeks. We did a lot of hands-on skills, a lot of coding, a lot of interacting with our lecturers and my fellow girls, people from other counties. It was an amazing time. Yeah, we had an amazing time during our internship. First of all, we met with the county healthy director, Dr. Muriu. We were taken there by our regional coordinator, all of us, the 15 girls, and he gave us like the go-aheads. He allowed us to get even the data from the hospitals that we got the internships from. For us who are at PGH, that is Nyeri County Referral Mortality and Morbidity, and we came up with a model. The model was supposed to predict in terms of the diseases that people are diagnosed with at that hospital. So our model was supposed to predict to help the county to know how to allocate resources in terms of which departments they can put more resources in terms of medical practitioners. Said before, students in IT, BBIT, computer science, there's a lot to be done. So you don't even know which path to take in life. So for me, once I got done with my exam, I didn't know what to do next with my life. I didn't know whether to do cybersecurity, software engineering, or data science. I didn't know exactly what to do, and I didn't even have a mentor. So when the Engage program came about, to me it was like an eye-opener. I didn't know I can even do anything like that. So it has given me like a way of life. I know now what to do. Yeah, definitely. I would like to start with University of Nairobi and the University of San Francisco, California, for coming together and giving us this opportunity to go through this training. It has really impacted my life. And also I would like to, above all, I want to thank the Takida for the donations, for sponsoring us girls to go through the training. They gave us a very good stipend during the internship. We were well taken care of, even during the training program, and we really appreciate. I also want to thank Dedan Kimathi, University of Technology, for giving us their facilities for us to study there. At the same time, I want to appreciate our lecturers, our trainers. They were really good, and may you continue sponsoring other underprivileged girls, because we are really getting somewhere as girls, and some of us who could not even afford such things, now we can say that we can afford them.
Plug and play between the different programs that are quite a number in Africa. But as Eric said, they are all disintegrated. So some form of coming together to decide on how to pack them up into one single effort, I think it would go a long way. Thank you very much.
Thank you. Dr. Tim will be on the panel later, but I can take one question, one burning question from the plenary. Any question for Dr. Tim? But he will be on the panel later. We have one.
Yeah, thank you so much, Dr. Kamanu, for the presentation. I like the focus on data science skills to show that Africa, we can go beyond data labeling. So we are not just good for data labeling, especially in marginalized communities. I had a question about training the high school girls, because there has been research showing that it's been difficult for women to transition into STEM from high school. So what has that been like? And then training at, the marginalized community where you have a big digital divide. So how do you also, bridge that gap when it comes to AI training for high schoolers?
Thank you for that question. That's a very detailed question. Yeah, we did not pilot training for high school last year because we anticipated it to be a bigger challenge than training diploma level and university graduates. Now, this year we started on the journey to develop a curricula for high school in AI, and it's not been a walk in the park. But the best thing of what we've learned is that there are already players that are out there that are doing it. But how do we now package it in a way that will inspire that girl that you just described in the marginalized areas? Because that is not where we are not targeting to train data scientists or machine learning experts at that particular point. How do you inspire that girl to pursue a career in machine learning and AI at the next level? So we've partnered with a major player in the banking area, I think the Equity Group. So they've been doing this for a long while. And one, to target really marginalized girls. And also, we are also trying to, we've also had some very good deliberations with players as young who are interacting in the level of primary school and high school. And we hope to be developing that solutions pertaining to your question within the next few months. Does that? Yeah.
Thank you so much for the wonderful presentation, and the testimony from the young girl has really touched me. I am from Uganda. I also run a simple program. It's called Code for Africa Now. We teach young children as young as 5 years how to code and elements of robotics. I'd like to hear your perspective on the challenge, because on my side, the biggest challenge is on the internet accessibility for the rural areas and electricity. So most of the times when I'm in these communities and I want to deliver a session, and when there is no power, you can hardly do anything. How do you handle that in Kenya? I'd like to learn from you.
Yeah, so how we handled it is collaboration again. There are universities, there are institutions across Uganda, I believe, that you can consider working with. So we are currently working with the 6 regional universities. We tried out 5 public universities and 1 private university just to have a feel of what is out there. But then the challenges to the girl is still there. Yeah, so the girls even applying to our program. But we've developed also some collaborative research agreements, again with, as I said, Equity, so that we can try and get some computing facilities where they can even sit for exams or even learn on their own before they even join the program or after they join the program. But the thing here is collaboration with well-established institutions, and then working around now the logistics. But it's still a challenge. Still a challenge.
Thank you, Dr. Tim. You can give him a clap as he sits down. Yeah, he'll be back for the panel, so we'll have much to hear from him later. So allow me to introduce Professor Conrad Tucker. He's the director of Carnegie Mellon University and the Associate Dean for International Programs Africa. He's also a trustee, professor of mechanical engineering at Carnegie Mellon University, and holds courtesy appointments in machine learning, robotics, biomedical engineering, and Scilab and privacy. Yeah, thank you and welcome, Professor.
All right, so good afternoon, everyone. Thank you for taking the time to bear with us. Who's hungry? Okay, we're going to try to make this, I think I'm standing between you and lunch, so we'll try to make this as engaging and quick as possible. I've been told I've given 10 minutes, so I'll try to stay within my 10 minutes. So I'll start off with Carnegie Mellon University, Africa, with our mission, and how this connects to the title of my talk, which is going from consumption to creation in the age of AI. So we are located here in Kigali, Rwanda, in the special economic zone, and our mission is to educate the next generation of technology talent here on the continent of Africa. We have 2 core programs. Our master's degree programs. We're a master's only program for now, and we also have this new collaboration with the MasterCard Foundation to build out a network of universities that's Pan-African called the Afritech Network. So these are our 3 master's programs: a master in information technology, electrical engineering, and our most recent master's in engineering artificial intelligence. So that's going to come in later in my talk. It's called CMU Africa for a reason. We're Pan-African. We have students from over 20 African countries. Our dream is to have one student from each of the countries represented on the continent. So if you are from a continent or a country that doesn't have green, please encourage your students to apply. That's the breakdown of our three programs. And another area that we're trying to, as many of us in this room, is really to increase, to get to gender parity, because AI is too critical for there to be demographics left out in this way. So it wouldn't be enough if all we're doing was handing out degrees. So many of you are in this room, you've given talks. We heard from the keynote speaker today about how Africa could position itself and what areas we should be focused on. Many of our alumni go into the main tech companies, both here in Rwanda and across the continent. So here's the meat of my talk, and it goes from consumption to creation, deep tech research and education for Africa's AI future. So to keep you engaged, I have a question. It's a quiz. I'm going to show you three objects. I'm going to ask you what they have in common. We have a wedding ring. Anyone here getting married, planning? We have an aircraft. Okay. And we have a coffee mug. Now, what could these three have in common? Who wants to take a stab at this? A wedding ring, an aircraft, a coffee mug. All right, we've got one volunteer. What could these three?
I think they're topologically equivalent.
Okay, so that is a mathematician speaking there. You can always tell in the room. Topologically equivalent. Let's hear.
Okay, for me, I think humans use these three objects. So human being.
They're used by people.
Material science.
You need material to make all of them. So all of these are part of the solution. They are all made by people, and before they're physically made, there's some conceptual representation in the form, in many cases, of a CAD model. So if you're an engineer in the room, you've most likely used one of these CAD tools to conceptualize, to take what you have in your mind and create a 3D representation of it. And so our mathematician, if you delve deeper into the topology of this, then you can get down to, well, what is this made out of? It's made out of, or it can be represented as a mesh. And what we want to do in terms of training a machine learning model to help code design is take this mesh, which is really a collection of points in 3D space, and teach a data-driven model to organize these points in such a way that they create something that is useful for a human. Now, just as a sanity check, are we seeing something that looks like a airplane outer? Okay, so how do you organize these points in 3D space, and how do you train a model to do this? Now, of course, this is one of the, you can use a generative adversarial network, many different types of generative models, but with a fully trained model, you can actually perturb this latent space and come up with a wide variation of three-dimensional models. And now we start getting into creation. And so if we take this chair, for example, and the question is, well, was this chair made here in Rwanda or in Africa, or was it imported? Beyond just AI, we also have an opportunity to leapfrog the way that products are made, ranging from chairs to wedding rings to coffee mugs. It is really this three-dimensional representation that can then go into another machine process, which is additive manufacturing. So now you're able to go from machine-generated 3D models to machine fabricated, which is the realization of the physical product. And so this has the potential to be a game changer when you think about how things are manufactured here on the continent and what opportunities exist to leverage AI to not only classify things, but to actually create. Again, our goal is to get to a point where we're creating things, and now we can leapfrog and use additive manufacturing and generative models to move to creation. Now, how do we know that a model that I've created, let's say the chair that you're sitting on, some designer first did some modeling to make sure that the geometry is something that, and material science, is something that when you sit on the chair, it's not going to collapse, right? So there's a physical understanding of the deformation of the chair, and this is where 3D physics-based simulation comes into play. So it's not enough to just design a 3D representation. Now, as engineers, this is typically linked with a simulation of the performance of what you've designed. And for engineers, this is where we have computational fluid dynamics to actually evaluate the fidelity of what you've created. Now, in many cases, and this is a project that we had with Rolls-Royce, where we were looking at these physics-based simulations and whether or not they can serve as a approximation of these very, very expensive, very time-consuming CFD models. And so it turns out you can train a neural network to simulate. Now, on the left here is a simulation of 2D water droplets. So imagine you're simulating this at the particle level. On the right here is the same model represented as a graph to show what the model is learning. So at each timestamp, the model has to predict where in time, space this particle should be, and if it collides with another particle, what is going to be the chain reaction. So in essence, we're accelerating the pace in which we can determine how something is made and whether or not what you had in mind actually can be physically produced. So everything we just looked at is focused on taking points in space. So the generalization is take points in space and train a model how to move those points in space at the highest level. But what if you're not interested in moving points in space? What if you're interested in the, for each point, the change in some characteristics of this point? Now, who can guess what representation this is? So it's points that are organized in a very structured manner. If you had a picture in your mind, then you're correct, because picture is just one representation, very structured representation of a graph. Now we're looking at not only points changing, so these pixels don't change in their spatial position, but they change in the resolution of each of the nodes. So now we're looking over time how the intensity of these pixels change. And with this, we're now able to apply this idea to healthcare. So this is another work where we're now looking at the state changes of pixels that can then be used to approximate vital signs such as heart rate, respiration, etc. So in real time, with any video camera, you're able to, with very high accuracy, estimate how fast someone's heart is beating. So this started our work in extending this work in resource-constrained environments. If you think of a village, how many people have, let's say, a pregnant mother? How many people have access to thermometers or pulse rate or blood pressure. All of these vital signs are critical to human health. And so how far can we take this idea and leverage the change in pixels to make contributions in each of these areas? And so our most recent paper has been published for blood pressure. Again, this is all using non-contact video-based approaches. So we talk about bias a lot. And this is an example of one of the face detection algorithms that is unable to detect the face of this participant, only 1% accuracy versus 50% accuracy for a different type of algorithm. So in order to estimate their vital signs, we need to determine if someone is in this frame. And so this is an example of where AI fails, but it motivates why we need deep tech education. Because how do you then troubleshoot to understand what is going on? And so when we delve deeper into this problem, we realize that these models that were trained on a distribution of college-age kids in the US, and when applied to resource-constrained environments, you had these significant failure rates. And so we extended this work into 2 populations in Sierra Leone, where I'm originally from, and Bangalore, and we were able to determine across all of these publicly available algorithms what are the biases in their implementations and deployments on different populations. And so this is the example of 2 different algorithms and just showing the significant difference in just changing an algorithm that has more demographic representation and the difference in performance. So again, the motivation here is field deployment. Everything I just showed you was actually inspired by, this is me here in one of my wife's village in Sierra Leone. And when we visited here, we realized that it's such a remote place. And when we think about medicine and reaching certain demographics, having a smartphone that can have embedded within it, on the edge, ways of detecting these vital signs could be game changers. So this motivated moving from the lab to the field, which is what's needed as we think about how these tools can be useful for what we do. So with that, I think I'm within the 10 minutes. I just want to acknowledge our sponsors across the world and remind us that this is why we're here. We're here to ensure that the generation that we talk about being the youngest population isn't left out of this AI space. Thank you very much.
Thank you, Professor Tucker. We'll take really like one question. Fortunately, Professor Tucker is based in Kigali. You can definitely find him here over the next 2-3 days. So just a quick announcement. The restaurant closes at 3 p.m. So we're trying to make sure we get to that. I'll introduce Professor Anisha Peters next, and then conclude this session on talent. Yeah, so one quick question for Professor Tucker. Okay, Senator Mutembesa.
Yeah, thanks a lot. My name is Mutembesa Daniel. I am based out of Makerere at Fisher Intelligence Research Lab in Uganda. Thanks for the amazing presentation. I wanted to know specifically that we're talking about talent. This is a question that the entire audience could benefit from. What is your thought process on how deep to go, especially the trade-off between application and a much deeper science, where you're writing new libraries for such applications for the use case of resource-constrained settings or settings that are completely different but have either longitudinal or a latitudinal benefit. So I'd like to hear your thoughts on this strategically.
Thank you. Thank you for the very thoughtful question. I'd like to partition the response into 2. First, we should go deep enough where we're able to answer the question of how did something happen. So if I go back to this video, here and say that there's a capability for using just any of your video cameras in front of you to capture heart rate, temperature, blood pressure, and taking a step back and saying, well, how is that possible? So educating our talent to the level where they're able to understand how is absolutely critical. And then the question of, well, if something fails, like in the case where this algorithm wasn't detecting this person, why? We need to be able to answer not only how, but when something doesn't work, to have the technical depth to say, this is why it's not working. And that, I'm not aware of shortcuts around educating to that level of depth. And so it's going to take time, it needs resources, and it needs a commitment so that we aren't just educating a next generation of talent that can prompt ChatGPT. I think if that's the generation, it would be a missed opportunity to lead in this space. So thank you very much for the question.
Thank you, Conrad. I appreciate it. Next up, we have Professor Anisha Peters. As we get her first slide up, Professor Dr. Anisha Peters is the CEO of the National Commission of Research, Science and Technology, and the co-chair of the 4IR Working Group of the Africa Union's Scientific Research and Innovation Council, ASRIC. She was also the chairperson of the Namibia Presidential Task Force on the Fourth Industrial Revolution, 2021-2022, established by the late president of Namibia. In 2021, she served on Namibia's inaugural Green Hydrogen Technical Committee under the office, of the President of Namibia. She's passionate about HCI and currently HCI interactions with artificial intelligence, and co-founded the successful Africa Human Computer Interaction PARCAI conference that is held biannually in different parts of Africa. Actually, chatting last night, we realized we had some overlap from like 9 years ago. So as we plug in her clicker, please give a round of applause to Professor Anisha Peters.
Okay. Yeah. Time constraint. So as I was introduced, I thought that this discussion needs to have a perspective actually from a research funder. So essentially, I'm heading the National Research Fund, Science Council, Innovation Council, etc. of Namibia. And you all, have you received grants, research grants, from your national research funds in your countries? Who has? Okay, at least a few hands, but we should have more, right? So one of the things that we think about every day is how do we solve our problems? How do we solve our challenges? And we set the national research agendas for each country. The national research priorities, the innovation priorities, and of course we have to fund it. So the pressing concerns in my world is the food, water, energy, health, security, and sovereignty nexus. And then green industrialization versus the just energy transition. It's a big topic for Africa. And then of course, AI features very big in that. And on top of that, we're also looking at what is the Africa research agenda and what is the international ones. The International Science Council, the Global Research Council, the Science Granting Councils of Africa, those are all, and of course the African Scientific Research and Innovation Council, those are all platforms where we influence how do we look at and fund research and science in Africa. And of course, geopolitics influences us all. Now, at the ASRIC Council, we looked at, for instance, at 54 AU member states, and we looked at what areas are they concentrating on to embed 4IR and AI. And I'm going to substitute because AI is really broad. I'm going to just say AI. And you can see that it's almost every sector. These are only the most frequently occurring ones across those countries. It affects every sector. So we're not narrowly focused on just entertainment on social media. We want to solve the real challenges within our country. And I think that the previous speakers spoke about poverty reduction. Yeah. Okay, we also looked at what domains and what are the use cases, the technologies that are being employed, the national and continental strategies. The issue of data is very big, and then infrastructure. Also, the regulatory frameworks, and we advocate for a balanced and conducive regulatory framework, allowing innovation, yet protecting the most vulnerable. And then, of course, funding, and then talent. There were a number of, over the years we've seen that there are always numbers being cited as to how AI will impact us all and what would be the job losses. And for politicians and decision makers, the only thing that matters to them is the negatives of AI, right? It's a narrative we're trying to change, and the first thing that they will say are job losses. But we're also seeing that the job losses numbers game is changing. Right now, the World Economic Forum actually has a gain in jobs. And the latest McKinsey report says there will be no job losses in 2030. So then we have another problem, and that is that jobs in Africa, what will it look like? Predictions in 2022 were that 100 million youth on the continent will not find jobs. We have, for instance, that other reports are saying the mismatch between what universities produce and the jobs available out there. So, everyone is always talking about Africa and youth, and that's going to be the next big thing. We see that 70% of the sub-Saharan population is under the age of 30. Namibia, it's 72% are under 35. Yet the youth employment rate, overall it's about 9%. But then we're looking at Southern Africa. 48% on average is the youth unemployment rate. It's a huge concern. South Africa is certainly the leader. I'm not sure whether Namibia has overtaken South Africa or not. We just got our latest figures, but the picture is not rosy. And this is where we think that AI is our biggest catalyst. A latest McKinsey report shows that millennials, the youth, are able to make bigger strides in AI. But the ones who are holding them back are the decision makers. And I would add politicians and those making decisions about money and about what we are deploying and where and how. And they are the ones, we will see it from the figures, who are actually the ones upskilling themselves. So in developing our AI pipeline, we are looking, for instance, at revolutionizing education and training. This was said already. We're looking at some of the research studies, pedagogy, teacher education, important. Then we are enhancing the foundational education through AI curricula. That's for basic education, for universities, on-the-job skilling programs. Then we have online learning, etc. Research and development on the African continent is performing very poorly. It's 0.45% on average. Those were the figures for 2022. I will actually look at the latest figures because we're also going to do our latest survey, because I think that's on the uptick in terms of the R&D spend. And then, of course, we have innovation and entrepreneurship. And one of the things that we have to do on the continent is talent retention. Somebody asked a question this morning about talent retention. There's a huge debate on it. Our brain drain, some say brain circulation, but really sometimes it's just a drain, is because we don't have the necessary infrastructure. We do not have the funding. We do not have the other talent around you, and you don't have the regulatory framework. And that causes people to study abroad. I also studied abroad. You come back, and what do you find? You can't apply any of the things that you learned because you don't have the necessary facilities. Luckily for us, research funders like ourselves, when we set up the national research agendas, we also have to look at infrastructure, funding, research chairs, your postdocs, etc. So I was asked to also look a little bit at what do the figures look like. Now, in Africa, there are over 100 universities offering AI courses or programs. However, a closer look reveals that it's actually just a module in your degree, sometimes. And you can't really do anything with it because it's introductory. So there's generally a mismatch between what you learn in university and what you can actually apply when it comes to AI. There are 10 master's degrees in AI, and I know that the Namibia University of Science and Technology also rolled out an undergrad degree in AI, has data science, has HCI degrees, etc. So that part is growing. And then, of course, computer science enrollment increased. You can see it coincides in 2022 with sort of OpenAI's release, right? So it increased to 22.7%. Look at the figures for Coursera. Sub-Saharan Africa has the highest enrollment rate, and it's mostly in AI. Do you see our youth are teaching themselves? And the older ones are the ones holding everybody back. Sorry, should probably not say it so roughly. Look at the online learning platforms, right? And then, of course, you're looking also at innovation. 2,400 AI companies are already specializing in AI across Africa, 41% being startups. We need to support them because their biggest problem is funding. Yes, it's infrastructure, compute infrastructure as well, but it's funding. And CRST Namibia is, for instance, the focal point for Psych, where we also host the annual Boost Up campaign. That's Namibia, Botswana, South Africa, Zambia, and Tanzania. And we focus on tech startups. And then we're currently co-leading with Kenya, the Africa Innovation Agencies Network. We will be giving out innovation calls also for AI in July. Okay, so here I just wanted to show you why we need funding. Because look at where we started off with startup growth. It was going up, it's coming down. And the funding was only high in 2022, and ever since then, it hasn't increased. And if we want to grow our AI startups, that's where we need to start in terms of supporting them. So, one thing about growing our AI talent pool is that we also need to be cognizant of risk mitigation and ethics. And of course, ethics barriers were spoken about earlier. I've seen on the program that we will speak about that next time. I will tell you about my own research into responsible AI. But for now, we need to be sure to balance the negative effects and mitigate it. Remember I said infrastructure? This was great news. So I thought I will just give a shout out to Cassava for that piece of news. Everybody probably knows about it, but can we give a round of applause because I'm done. Thank you.
Thank you so much. So I'm standing between you and lunch, which is not a good place to be. But Professor Anisha Peters, just take one question in 2 minutes, and then as we exit, you'll get lunch cards like this. Ask the attendants to show you to the restaurant. I believe it's on the left. It's Kushina Restaurant. So one question, and if you're asking the question, you know you're also standing between us and lunch.
He likes pressure. Oh. It might be faster.
Unfortunately, I'm going to stand between you and your lunch. Young Africans, the problem is not part of what we have said. You should start challenging your leaders, your politicians. What AI strategies do they have for Nigeria, for Ghana, for Zambia, for Tanzania? You must change the narrative. Any politician or presidential candidate who is not AI ready should belong to the dinosaurs. Africa has to change. I have on my cap, AI or die. It is a mantra. It's a serious mantra that those companies, those countries that are not going to adopt AI, matter of time, they will die. Thank you.
Yes, this is why we are having this conversation with politicians, because they are the first ones to be trained. Not the youth, because they will, I mean, they're almost there already. They need very little of a push. But yes, that should be the mantra.
Thank you, and Professor.
You know what? Actually, what we did as a research funder, of the grants that we gave out for research last year, 7 of those grants, we are now forcing everybody to integrate AI, whether it's agriculture, whether it's health, whether it's whatever. And I think that many of us, if we start doing that, we will see greater funding for AI.
Thank you, Professor Peters, and she's around all day. So we're going to break for lunch now. It's 2:38. We'll truncate lunch from so that we are back here. Let's aim for 3:15. Keep the conversations going during lunch, but please let's be on time because we'll wrap up with Professor Nderu's and then try and catch up on time. All right. Yeah. Exit on the left. Get your lunch cards, and ask the attendants to tell you where the restaurant is.
As well as a master's degree in software engineering and a bachelor's degree in mathematics and computer science from JKUAT, Jomo Kenyatta University of Agriculture and Technology. His research interests encompass artificial intelligence, machine learning, data science, and software engineering. He has authored numerous papers in peer-reviewed journals and presented his research at international conferences, just like this one. Karibu.
Thank you so much. I think, first of all, thank you so much for the invite, and I'm very happy to be here. I know that after lunch, it's a big challenge. Eric, as you know, in Africa, we say there are top challenges that we have. One of them is to convince a girl in love to stop. And also the other one is to convince a religious person that whatever they believe is difficult. I hope this is not going to be the third difficult thing of talking to people who have eaten already a very good lunch. But I'll just go direct to the conversation that was happening earlier, just before lunch, related to AI talent. And my underlying foundation is the fact that we do need to think heavily about how we deal with the issues around training. Just a minute. Yeah, so what I'm saying is that it's very important for us to think from wherever environment we are in Africa on how well we are able to train high-level skills, because we realize that we have young people, and that is a song that has been sung in several places, but without opportunities, that is a time bomb, and we have seen that happening in African countries. So why I'm passionate about real skills that really will make sure that these young people that you are training at the university, they are people able to do more than just being told that you have skills in computer science, but you can do nothing. That is why we have introduced for us at JQuat, we look at the issue of sustainable development education. That is the sole idea behind what we are doing. In essence, we are looking at how do you train students so that, or even students at different levels, so that there is value in the skills they gain going out there in the industry. Even as we promise about the hype that comes with AI, at undergraduate students, how at master's level, at PhD level, how do you train people who can be able to do more than just the hype that is associated with that? Sorry, I think I need to master how this works. Okay. So, yes. So these are the things that I have looked at in terms of the sustainable development. The first argument is at the basic level of AI and digital literacy for all. This is what I would consider that each and every person, because of what has been cited from morning, in the sense that AI is something that all of us needs to have skills in. So I consider the first one is where we have basic AI, and what we are doing is that even people who are not in the university, they have an opportunity to gain skills through collaboration that we are working with companies like Microsoft, like Oracle, and such. They can be able to gain skills in AI, basic skills that is at that level. Then there is high-level training and postgraduate programs, which we run at JQuat, AI-focused. I heard Professor Peters say that in some instances you have programs that promise that a person is doing AI and yet it is basic. For our program, for sure, it's not basic. We have taken time to build a curriculum that can be able to turn a person from at different levels, entry to a point where you can be able to do a thesis in this area comfortably. So the high-level training, we have a number of publications that are coming from JQuat. In fact, during the last review that came out, we were ranked as a university that is in Kenya that is generating a lot of content in terms of these areas publication, which is a good thing because you also need people who have the knowledge about the foundation. And then there is innovation, and I think this is where now I say opportunities. We know AI is a gold mine for some of the innovations, and there is a question about what is Africa doing in terms of those innovations. So that is why we started the J-Hub. J-Hub is a digital innovation hub that is based at Jomo Kenyatta University of Agriculture and Technology. We have a number of innovations that we are mentoring. Some of them are at different levels, and some of them we are working with them with different partners. So to give an example is the smart mushroom, where we are looking at, we have built special containers or special houses where instead of using mud houses to grow mushroom, we are using a house that has sensors, and we can be able to gather data and then do analytics and also use AI to be able to predict how long will it take for us to be able to harvest the mushroom sperms? How long will it take for us to be able to get optimum results? We also have a project like Regumatic, which is looking at how long does it take for us to be able to cook beans and those products. So all these innovations are such that they are at different stages, and that is obvious because of the fact that some of them have already partners who we are working with in this kind of thing. So this is one area that we are very interested in, and these innovations are being driven by students. So the team that you see here, this is just one of the projects, which is GEICOSAFE, is driven by these are students that we are working with. Of course, maybe this team is made up of mostly men. The other teams are a bit balanced, but this is, I think that is something that you can pick from that. It's not the usual way that all of them are like this, but at least we have teams that are there. So this is a personalized AI assistant for diabetes management. It's one of the innovations that now we are building as a startup, and the idea is to manage diabetes that requires continuous tracking of what a person eats, the glucose levels, medication, and it's a complex time consuming if you do it manually. So this is the numbers, around 7 million people globally live with diabetes. So this, the product aims to help in managing these conditions, helping people manage those conditions using AI and computer vision. In that case, of course, we have a mobile app that is able to do that. We have done, in terms of domain, a quick overview of diabetes, focusing on how food impacts blood sugar levels. We know that. And the existing solutions usually use the manual tracking, as I've said. The gap is that most apps require manual entry to give inaccurate measurements in terms of estimates for the meal. So this is generally the way the system is. We have a mobile app, you upload an image, an AI model that is able to recognize aspects like what type of food that is, what type of accurate nutritional analysis, and also provide some personalized AI through clustering algorithm in terms of clustering food products. It's crowd backed up in terms of the personal data that we save. So this is the technical implementation. I think usually the pre-trained model that we are using here is from ImageNet and fine-tuned with some images of food, local foods that we have taken. So we took some photos on that. So this is, then we do food segmentation to identify what food we have. There is volume estimation, nutritional analysis, and then we can make recommendation to the person who is taking that. Now, the other thing that I would say, so here is a video which I'll not play it, but at least it shows what we are doing in that. There are some results in terms of accuracy that we are getting, a segmentation model, and then challenges that we face is balancing accuracy and speed on a mobile phone, limited lack of regional databases, especially local foods, and that's something that maybe most people working in AI within our region will realize that. And also cooking methods. That is what now led to what we call Regumatic, which is another app that now looks at what is the optimal time for cooking legumes. We started from there. So future improvements, we look at things like increasing the data size, integration, and also making some recommendation and a doctor portal to help monitor. Now, the other project, and just the last one to talk about, is this on privacy priority interface for Kenya. This is also a very interesting case. The partners, I put this case because of the depth of the partners that are involved here, including ACTS, KickNet, the UK development, we have JQuat, we have the Kenya National Bureau of Statistics. They provide us with data. And here, what we are doing is trying to influence the use of resources. So deploying AI-driven decision support tools tailored for Kenya development planning, especially the budgeting. And what we have in this case is that in the era of complex economic challenges, the policy priority interface project represents a breakthrough in developing planning. It's an initiative that introduces an AI-driven framework for analyzing public spending priority. That's what we are doing. It creates a detailed socioeconomic models that generate precise, actionable scenarios. You can be able to predict, should we invest as a country in this, or should we invest in a country on this, and so on and so forth. So it helps in budget allocation with some very good accuracy, tuning data into strategic insight for national development. And this is a project that we have not taken it for a long time, but we also have the app. which exists there, PPI app, which one can try, and even there's a sample data that you can be able to try to use it on various aspects to test it. This is the workflow. You upload indicators, you upload the expenditure data, you add the dependencies. Here we are talking about what affects what, then you calibrate those parameters, then you run simulation. And as you do budgeting, instead of guesswork, as you know budgeting is a big issue, you can be able to add some level of predictability into that. So what I would say really is that those are just 2 case studies. We have a number of ideas that we are working with, and young people know the value in what they are doing. So Africa's greatest resource is people. Let's equip them not just with knowledge, but with purpose. And what I would say is that our aim is to make sure that we get ability to work with partners so that we can support these students to be CEO and creators of solutions, not just consumers. Thank you. Thank you so much.
Thank you, Professor Nderu. As we get Karim's presentation ready, I'll have Professor Prasenjit Mitra, who joined CMU Africa recently, to introduce our next speakers. Can we get Karim's presentation ready? We're trying to catch up on time, and
all right. Thank you for your attention. We have an exciting talk now, and this is one of our keynotes by Dr. Karim Beguir, and he is the co-founder and CEO of InstaDeep, an AI company renowned for its cutting-edge solution in decision-making systems. Founded in 2014 in Africa as a bootstrap, InstaDeep grew under Karim's leadership to become an EMEA leader in AI, partnering with industry giants like Google. In 2023, BioNTech acquired InstaDeep for approximately $700 million, integrating its AI expertise to accelerate biotech innovation while keeping the company operationally independent and open to external partnerships. Karim holds a degree in applied mathematics from France's École Polytechnique and was a program fellow at New York University's Courant Institute, where he honed his skill in computational science. A passionate advocate for AI's transformative potential, Karim advises companies and governments, including France and the UK, on deep tech strategies. His work emphasizes empowering developing nations through AI innovation, earning him a Time 100 Impact Award in 2024. He continues to bridge academia and industry, and his vision blends scientific rigor with practical deployment, providing actionable insights to navigate the fast-moving AI space. And with that, let's give a warm welcome to Karim Beguir.
Thank you so much for the introduction. And I'm actually not a doctor. You know, I didn't have time to complete my PhD. I decided to start working after a Master of Science, but I am passionate about AI research. Been involved in many research avenues, many papers, and sort of like, you know, for me, AI is the most beautiful fruit of applied math, and there is a lot to talk about. So for today, I don't know if we can get the slides up. I thought, since this is the AI Research Colloquium, to actually show you some concrete results from an AI research point of view, and in particular discussing like some of the breakthroughs we've had in foundation models for genomics. So why genomics? Well, you know, this is an interesting example, and it's not just genomics, though. We'll touch briefly on proteomics as well. But biology is a deep tech area, and it's actually being revolutionized by AI. And so here the key point is I'm trying to convey the sense of AI's interplay with deep tech innovation, and sort of like show you a bit like concrete results of the work we're doing at InstaDeep, work which is done by a large team from Africa to Europe to the US. And so this notion of training foundational models for genomics. First, I mean, this was not obvious in 2021 when we started working on this. We got some free compute by NVIDIA, and we started working on this problem. This was, if you remember, before ChatGPT. It was actually before even the word genomics AI was invented. This was the time GPT-3 had come out in 2020, June 2020, and you know, that's exactly the kind of things that I am passionate about. We saw like a revolution happening in natural language processing, and we were like, could we apply it to other fields? Does this technology make sense somewhere else? And actually it makes sense for genomic data. So what is genomic data? Is literally very long sequences, literally like billions like long sequences that have only 4 letters, A, T, C, G. And so one way to model it is actually you cut it in chunks, like tokens of 6 nucleotides, 6 letters effectively, and you're trying to see if you can force the model to reconstruct, basically self-supervised learning. And interestingly, it worked really, really well. So as you scale training, and if you look at, like, for example, like projections of embeddings of different layers of the network, this is purely self-supervised learning, you see patterns appearing, which means sequences which are known, for example, to have some genomic properties, like intron, for example, are starting to appear sort of naturally. So in a sense, the model starts to understand structure the same way we have natural language models that start to understand English or other languages just by training self-supervised, whether it's predict the next word, or here in this case it's actually bird style. I'm hiding some parts of the sequence, something in the order of 15% of the sequence, and sort of like guessing what those tokens are. So that's a concrete example, and so I'm going to the next slide here to tell you, like, we got actually very good results with this approach. And if I come back one slide, just to show you the idea is like we're doing self-supervised learning at large scale, and then we're fine-tuning on specific downstream tasks. And you have examples of downstream tasks. So until then, people were more like, I'm going to have a specialized model to take this sequence and predict a certain property of that genomic sequence. But what we have proven is that if you train large-scale self-supervised, it's like I learn the language of genomics, and then I ask multiple specific tasks by doing fine-tuning, supervised learning, it actually works really well. And this is our best model, the nucleotide transformer multi-species, 2.5 billion parameter model. And it actually beats all the different results and state-of-the-arts until then. So that was kind of remarkable for us. And first, this shows you that really, like, you can innovate. I mean, InstaDeep was not a genomics AI company before that. We just tackled the problem, and just by expertise in machine learning, you can actually beat the experts in their field. This is how strong and how good AI can be. So that's a concrete example. And so it doesn't stop here. So another point is, okay, I have my genomics data. Some parts of this genomic data are expressed as genes into proteins, and proteins are like basically the workhorse of the human body and like of life. Different proteins do different tasks, but could you use actually genomics to predict properties that are at the protein level? And if you look, it's not obvious, because something like 98.5% of the genome is of unknown property, and only 1.5% is expressed in proteins. So we were like, could we actually take a genomic model and try to do as well as a proteomic model, protein model? And turns out you can even do better for certain tasks such as melting point. So what I'm saying here is AI is extraordinarily powerful. You can find the information in a lot of noise, even in a completely non-obvious way, with like tokens misaligned and stuff. So it's quite remarkable what can be achieved with those approaches. And so let me see if you can go to next slide. And obviously, if you combine a genomics model with a proteomics model and you're doing protein prediction tasks, you actually, on the joint model here, you even have better results, which is showing you again the power of multimodality in AI. So this is a bit like to get you a sense of like the cool work we are doing, but rather than giving you like hardcore results here and there, really my goal is to convey to you a sense of what does it feel like to do deep tech innovation with AI, and how far can it take you? And the answer is it can take you quite far. So if I try to go to the next one, we now decided to take another idea coming from the AI world, which is the idea of computer vision's segmentation. So segmentation, and you're familiar with this, is this notion that, hey, I'm not just asking like, is there a truck or a bicycle on the image? I'm actually trying to find where it is. And so it's not a classification at the level of the image, it's a classification at the level of every pixel in the image, okay? And so this has been done for computer vision, but then we decided let's tackle it for genomics. And what does it mean in genomics? It means actually going to every letter, every nucleotide, and trying to understand what's going on specifically on that point. So until then, people were more focused on the general problem. Classification at the level of every pixel in the image, okay? And so this has been done for computer vision, but then we decided let's tackle it for genomics. And what does it mean in genomics? It means actually going to every letter, every nucleotide, and trying to understand what's going on specifically on that point. So until then, people were more focused on the general
If we can have his slides up while I am introducing him, please. At KCRC, he works to foster a research-driven environment that enables collaboration and innovation across Africa. His research focuses on the intersection of artificial intelligence and Earth observation, leveraging satellite imagery and machine learning to address critical challenges such as food security and disaster management. He's particularly interested in developing robust models that effectively transfer to local context, ensuring practical impact in real-world applications. Moise holds a bachelor's degree in industrial and systems engineering from the Korea Advanced Institute of Science and Technology, KAIST, and a PhD in system design and control engineering from Ulsan National Institute of Science and Technology, UNIST, both in the Republic of Korea. So with that, let's give a warm welcome to Moise.
Thank you very much. All right, so before I get into my talk, I will just, try to really go back to the previous presentation by Karim, which was really, really exciting, and I'm going to come back to that later on in my presentation. But the topic of my talk is building impact for AI for Africa. And I'm going to start with a crop mapping exercise, and later on I'll move on to the point that I'm actually trying to make. Right, so before I get into my talk, I hope all of us understand what is a land cover map. So a land cover map is basically if you point to any point on the surface of the earth, then if you were to ask to do a classification of what is on that surface, whether it's water, whether it's crop, whether it's what, that basically constitutes what we call a land cover map. And it's typically created in the satellite as an input, and then you use machine learning to basically build that kind of classification. And in terms of agriculture or urban planning, you use this type of classification. For instance, like a temporal nature of this land cover map can tell you how the urbanization is actually happening. For instance, you could basically tell whether this year we're going to have a higher yield because we have way more farms that are, like crop that are actually being planted. Now, these are typical product from big companies. Now, like you have a modest land cover, which is a product of NASA. You have ESA World Cover, which is a product of the European Space Agency. You have the Google Dynamic World. So with all these, you have different resolution, and most of the time, as an African entity, you just take this as an input, and then you do whatever you want to use this for. Now, so the question is, when you use it as a Rwandan entity, maybe to make some policy around agriculture, is this actually going to work for you? And you have the Google Dynamic World. So with all these, you have different resolution, and all right. So if you use this, are they going to be good for you? What I want to highlight is, for global context, most of the time, the fine-tuning, the optimization is done not really for the local context. So if they are looking for accuracy, it's because the model maybe is doing well for the data set that it was trained on. And unfortunately, most of these data are undersampling the African continent, meaning that it's typically very accurate on the global north and less accurate on our continent. And there's another problem. When you look at a typical farm, let's say in the US, we're talking about almost 200 hectares per one farm. In Rwanda, we're talking about 0.4 hectare per farm. Now, if you're using a satellite like Sentinel, that's very tricky to get to that kind of high resolution that most of Americans don't need for the agricultural purpose, because they're working with way big farms. Now, the other thing is also the variability. So you know, like if I have a farm here, I could just plant maize, I put potatoes there and so on. While for most of developed countries, you have an area with same crop, which is way, way easier to actually deal with. So this brings the problem of how, like, do we still rely on these maps or do we actually build our own? Unfortunately, building your own, it requires to actually collect data, do the labeling, and train these models, which can actually be challenging. So we try to do something like this, but this is not really the major point. So we say, okay, we have Google Street View in Kigali and in Rwanda in general. So can we use some of these images and use human to label the farm that are nearby the roads? And so this is what we did. You use Google Street View, we take human for annotation, and because most of these were not very, very clear, we brought someone, the expert in agriculture, they look at it, they validate it, and then we use basically like a convolution neural network to extract the feature that we fed into a random forest to do the classification. So this is an exercise that's still going on. We only have a smaller size of data set. But even with this, the performance, very, very clear. We brought someone, the expert in agriculture, they look at it, they validate it, and then even with this, the performance is actually relatively good, especially for the samples that have way more examples. But what I want to highlight is how with a model only trained on small data set but is local compared to some of these global models that are widely used. And what we did was we found another data set from the Rwanda Space Agency that have the ground truth about some of the crop type. And then we tried to overlap these models, and we realized that, so this is the performance, the ECA, the European Space Agency land cover map, only agree like 54% of their classification is actually accurate compared to the ground truth that we have from the Rwanda Space Agency. And our model actually 98%, 97%, there's an agreement to the ground truth that we actually have. So to just simply say, even a simple exercise of data collection, we're able to, have a better model than the global models. So what is the point that I'm trying to make? The point that I'm trying to make is we always use the word Africa context. So what is Africa context? And for me, our model actually 98%. So I'm going to quote a colleague of mine who named Bruce Crow. He said that technologies are universal, but solutions are local. So AI is AI, whether you are in the US, whether you are in Europe, or whether you are in Africa. So we have to still deal with AI, and if we want to improve AI, we have to play the global game. But the solution is local. We need to make sure that that solution actually works for us. Now, what is really the solution that works for us? So to me, the African context means, but solutions are local. So AI, learning with small data set. African context, Karim was talking about how Africa has the highest variation of, the genome variation. Working with those kind of variation that you don't find anywhere else. It also means these things. Now, what is really the solution that works for us? Like having an output of high resolution, like while for the US, you are okay with a farm that has like a 2 kilometer by 2 kilometer, but for Rwanda we're only dealing with 10 meter by 10 meter, 20 meter by 10 meter, and that makes the problem way complex. So those kind of variation that you don't find anywhere else. Training. So there is a statistics that was really not good. Only 5% of African talent has the compute it needs. So it also the African context means training models using low computing powers. And all of this, and that makes the problem way complex. Something's wrong with this. So, training. So there is a statistics that I was really not. So the last point where I'm actually going. So to me, the African context actually means the ultimate test of robustness. So the African concepts mean you're building a model that works not only for Africa but also for the globe. And I really like the previous example of some of like local companies that end up leading in some of the area on the global topics. And Eric was asking me like, how do we sell to the world? And we sell to the world by actually not, allow me to use also another friend's quote. He said like, you don't become rich by selling to poor people. And most of companies, the startup you build, you want to sell to Google, but how do you make sure that what you're actually doing is something worth for Google, rather than saying, all our project is, making sure that this community have water where like they even don't have money to pay for that water. Now, I'm not saying this is not important, but I believe we have the biggest mass of young people, for the people to work on the water issues and the people to actually build models that are robust and that actually have context that forces them to build a way more constrained optimization problem, which is one way to succeed. Thank you very much.
Thanks, Moise. Question, another quick, short, important question from someone? Yes, Eric.
So my question to Moise as a professor here in Rwanda is, what would it take for students in Rwanda, even CMU Rwanda, to create something like DeepSeek 3? Or an equivalent from Africa or from Rwanda? What would they take? Is it changing curriculum, working harder? What would they take so that, a year or 2 years from now, we'll be talking about more easy students made this amazing thing? What would it take?
Thank you, Eric. So I wish I knew I would actually invest in that student. But it's really not far from what I was actually saying. So the whole idea that many of the projects that comes on our pipeline and that we encourage should be, the bar should be global. The bar should not be local. And when I say local, I'm not really like underselling the problem of the local concept, which is basically redefining what is the local context. And the local context means something that works here and works globally. And I believe, people in mathematics, like when you solve a problem which is unconstrained, that's way easier. But when you add more constraint, the problem becomes way more complex. And the solution you have typically works for unconstrained problem. So I feel like we need to redefine the problem in a way that is also interesting to the global context. And to me, that's kind of like the way to go. Thank you.
Yeah, it's actually a very good question. So I just wanted to give you also another element of the answer. Is like what we need if we want to do a DeepSeek R1 is not the talent. We actually have the talent all across the continent. What we need is the compute infrastructure. The DeepSeek R1 took, in reality, at least $500 million of compute infrastructure costs to get there. And I'm actually pushing a lot in this direction with all decision makers, because that's what we need. We have data, or if we don't have, we can create it. It's very easy to have cheap sensors. We have talents. but we don't have the compute to compete at this level. What we can do is take existing models and adapt them, yes, but the next step, we need the compute infrastructure.
Yeah, and I'll just echo that. So I think at the beginning of your talk, you said you had some GPUs and you played around with that. Yeah, from NVIDIA. Most of our students don't have that. We wanted to play with DeepSeek, because it's open source, but we can't do that. So that's a very good point. And with that, we'll close the session and pass it over to Eric.
Thank you, Professor Mitra. So we're transitioning now to AI safety and governance, and it's going to be actually an exciting one because it involves art and attainment as well. But we're going to make a slight change. Linda Bonyo, who's joining virtually, has to go really quickly over the next 5-7 minutes. And then we're going to have Dr. Joy Bolamuni and her team. I know most of you have heard of her work. So I will introduce Linda really quickly, and as she gets queued up on Zoom, AV team at the back, please give me a thumbs up when she's ready on Zoom. Okay, great. So Linda Bonyo is a founder of the Lawyers Hub, a digital organization working on AI policy in Africa. She convenes the Africa Law Tech Forum, where policymakers, regulators, bar associations in Africa lead the regulation of emerging technologies. Ms. Bonyo is a member of the World Economic Forum's Global Council on Technology Policy and the G20 Digital Working Group. Linda Bonyo is a licensed attorney of good standing in Kenya. She's been named among the 100 most influential people of African descent by MIPAD at the UN General Assembly. In addition, she was globally awarded as a privacy practitioner in digital identity awarded by Semaphore, Rest of the World's Award, Most Influential and Impactful People, Globe Tech 2022. In 2025, she was elected to join the UN Commission for Science and Tech as a working group, and she believes in innovation that serves humanity and furthers inclusion and amplifies the voices of the global majority. Please welcome Linda. Thank you.
Thank you so much, Eric. I just want to confirm that you can hear me. All good? Excellent. Okay, I will assume that you can hear me until something else happens. But thanks for the kind introduction, Eric. I appreciate that. And congratulations for the great work that has been done today and in the previous days in putting together this amazing convening of researchers to talk about, Africa and Africa's diaspora on how we could further conversations around artificial intelligence. At the Lawyers Hub, we've been working to put together conversations around AI policy. Our very first convening was in 2021. We convened the first Africa Law Tech Festival on artificial intelligence. And through that period, that's about 4 or 5 years ago, we've seen how Africa has undergone, a rapid digital transformation. And today, as I make my presentation, we want to present to you the Africa Artificial Intelligence and Privacy Report 2025. It's a critical examination of artificial intelligence impact on privacy across the continent. This report is an outcome of the AI and Privacy Working Group under the AI Policy Lab that we run. And this has been a vital platform for evidence-based thought leadership in AI policy in Africa. It's supported by the Patrick McGovern Foundation, as well as the Robert Bosch Foundation from Germany on our immigration work. And this collaborative effort represents our commitment to, guiding the responsible development of AI across the continent. We've seen that across the continent, there's been a lot of opportunities and challenges as well. Our research reveals 4 key sectors where AI adoption is raising pressing privacy concerns. We have law enforcement in Kenya, Uganda, and Zimbabwe, where we've had AI surveillance implemented under safe city initiatives, creating this risks of mass surveillance and discriminatory profiling. In healthcare, we've seen initiatives like Ghana's Nino Health AI labs demonstrate AI's potential to improve diagnostics which is great. They also simultaneously raise questions around patient data security. But also in financial services, we're seeing AI-driven credit scoring, both in Kenya and Nigeria, which is expanding access to financial inclusion. But still, these interventions are operating with the limited transparency regarding data processing, especially with the use of social media scoring. We also have judicial systems like in Morocco and Tanzania and Egypt, which are implementing AI for court transcriptions, but with inadequate attention to data security and algorithmic fairness. So our findings highlight a fragmented regulatory landscape, which is something the African Union has been trying to work towards around a harmonized policy environment. I've been part of the data governance framework that was drafted by the African Union. I was on the working group, as well as on the AI working group for the African Union. And one of the major issues that's coming up is the fragmented regulatory landscape. And we still see this. 13 African countries have developed AI strategies, from Mauritius to Egypt and Ghana and Senegal, Benin, Algeria, Tunisia, Ethiopia, Rwanda, South Africa, Nigeria, and Kenya last week, as well as Zambia. But we see that most of these AI strategies still lack AI-specific legislation, which then would, include unique challenges like algorithmic decision-making and profiling. But then also our finding is that the existing data protection frameworks, they prove insufficient for AI governance due to the black box problem and also the challenges in applying traditional principles like transparency and fairness. And we also must say that a lot of the data protection laws, ideally 18 out of the 34 data protection regulations in Africa mirror GDPR. And so many times there's lack of context, the context of innovation, institutions, where institutions ideally do not match the institutions that are present in Europe. And also our finding is that cross-border data governance remains particularly problematic with inconsistent standards, which complicates the regional integration of AI systems. And so based on these findings, we propose the following key recommendations. That there's need to develop AI-specific regulations where we move beyond just general data protection laws to create frameworks that specifically address algorithmic transparency, automated decision-making, and AI profiling. And this also goes into, systems. Secondly, we think that there is need to strengthen institutional capacity building, especially of data protection authorities with specialized AI expertise and enforcement capabilities to effectively oversee AI development and deployment. We have seen that data protection authorities are becoming pseudo, AI bodies. Europe has come up with the AI office, but we still see within African systems that the Ministry of ICT mostly would then delegate this sort of roles to either the Data Protection Commission, but we're also seeing the Office of the Ombudsman coming in as an institution that could, help with transparency in this case. And number three, we also find that there's need to incorporate African cultural values like Ubuntu into AI governance to ensure that technologies align with community-focused ethics and inclusivity. And four, we also, recommend that we need to harmonize, regional approaches. We need to coordinate AI governance standards. For instance, the African Union is working on an AI charter. We also have different institutions within the African continent working on governance, but these are really not coordinated. Coordination is a great problem, which is affecting harmonization of policy. And we also need to invest in AI literacy, especially for policymakers. Building awareness and technical understanding of AI and data rights would improve both education, stakeholder engagement, and even reporting. The Africa AI and Privacy Report serves as both a warning and a roadmap. It cautions against uncritical AI adoption without adequate safeguards, but also offering concrete steps towards responsible deployment. The findings that we present today underscore the effective AI governance requires balancing innovation with fundamental rights protection. This has been a conversation globally, especially between the US and Europe. But we see that there's need for collaboration amongst policymakers, industry, civil society. We might get into conversations around the investment into AI and this, but our research was very limited to, AI and privacy. And so as we formally launch this report, we invite our stakeholders to, join us in shaping an African approach to AI that harnesses its benefits while preserving privacy, dignity, as well as equity. The choices we make today will determine whether AI becomes a force for inclusive development or a tool that exacerbates existing inequalities. And so we pray that, through data governance, we'll be able to have access to data for researchers, for instance, but then also balance it with everyone else who's working on AI, and everybody who adopts artificial intelligence, that they are protected, that Africa does not become a dumping ground or a data collection point for artificial intelligence. Thank you very much, and I hope there are no questions. Thank you. The choices we make today will determine whether AI becomes a force for inclusive development or a tool that exacerbates existing inequalities. And so we pray that, through data governance, we'll be able to
Maybe one question for Linda as we set up Joy. Please go ahead. Okay, Professor Peters.
Yeah, I was interested in the notion that you're seeing also the Office of the Ombudsman playing a role. One of the things that I'm wondering, we were talking about this morning about sort of the AI literacy or AI knowledge in that. How do you see that play out with the Ombudsman if they were to sort of arbitrate in cases? Thank you.
Not sure whether Linda is online to answer.
Playing a role sort of within AI governance and regulation, and of course arbitration. So I wanted to know about the skill sets and the AI literacy and AI knowledge that they would have to also acquire. Thank you.
Linda, did you get the question? Well, hopefully she can get back to the audience over text. So coming up next, we have the honor of having Dr. Joy Bolamwini present an artistic component to our agenda today. I assume most of you have heard of Joy Bolamwini. She's the founder of the Algorithmic Justice League, which stands at the vanguard of AI ethics as a pioneering MIT researcher and multidisciplinary artist. She's the author of the national bestseller, Unmasking AI, My Vision to Protect What is Human in a World of Machines, and advises world leaders on preventing AI harms. Her landmark Gender Shades research galvanized the field of algorithmic auditing, ranking among the most influential AI bias studies ever published. This consequential research compelled 3 tech giants to halt sales of facial recognition technologies to law enforcement and sparked worldwide discourse on ethical AI implementation. She's also known as the poet of code. Dr. Bolamwini's artistic practice spans 4 continents, illuminating AI's societal impact through art exhibitions and poetic performance. Her doctoral dissertation conceptualized the evocative audit theory behind works like AI, Ain't I a Woman? And we hope to see that played in the course of this performance. It's a powerful spoken word poem and visual AI audit exposing how household tech platforms misclassify prominent women, including Oprah Winfrey, Serena Williams, and Michelle Obama. As a public intellectual, her TED Talk on algorithmic bias has been viewed close to 2 million times. The Emmy-nominated documentary, Coded Bias, chronicling her evolution from graduate researcher to algorithmic justice advocate, was available to over 100 million Netflix viewers worldwide, and is available in Kigali tonight. So get ready this evening. Okay, you can clap. With the first ever screening on the African continent across the street at Norsken Kigali House starting 6:30 p.m. I have to say I am very proud of this moment, because I spoke with Joy about 4 months ago, and I was challenging her to visit East Africa. She was like, oh, I don't know if I can do it. I have to go to Ghana first. So I feel somewhat, justified in having pushed a few months ago. She's part of the Ghanaian diaspora, and is accompanied by critically acclaimed Egyptian director Tamer Shaban. Please wave. Yeah, Shaban is at the back. Composer and cellist. Ugandan American Niles Luther. Yeah. A leading classical musician of his generation. And Peter Irving, a smart city and AI TV expert. So thank you, Joy. Take it away.
Yes, it's good to be back. I did not circle to Ghana just yet, so don't tell my family. I'm here first. Okay, thank you. Alrighty, so hopefully we'll get the slides up, but show of hands, how many people are familiar with the Algorithmic Justice League? A few people. Okay, so I'll give you a little bit of background. So as you heard in the introduction, I'm the founder of the Algorithmic Justice League, and we do research that's focused on exposing AI biases, but also putting that research into action. And so that research into action in terms of changing how companies deploy AI systems, how researchers audit and test AI systems, and also how storytellers think through AI. So today I'm really excited to be with some of the best storytellers I know with film and vision, and we'll start with the work that showed me the importance of art when it came to the conversation around algorithmic bias. So we will start with the showing of AI Ain't I a Woman, and this is inspired by the Gender Shades research, which showed racial bias, gender bias, and actually used parliamentarian members from Rwanda, from Senegal, from South Africa, as well as Iceland, Finland, and Sweden to show algorithmic disparities. And so this was inspired by that to say, how do we go from the performance metrics of that research to performance arts? So that's what we do in AI Ain't I a Woman. A woman, and this is inspired by the audio up, please. Which showed racial bias, gender actually used parliamentarian members from Rwanda, from Senegal, from South Africa, as well as Iceland, Finland, and Sweden to show algorithmic disparities. And so this was inspired by that to say, how do we go from the performance metrics of that research to performance arts? So that's what Ain't I a Woman. A 19th century question comes into view in a time when Sojourner Truth asks, audio up, ain't I a woman? Today we pose this question to new powers, making bets on artificial intelligence, hope towers. The Amazonians peek through windows blocking deep blues as faces increment scars. Old burns, new urns, collecting data chronicling our past, often forgetting to deal with gender, race, and class. Again I ask, ain't I a woman? Face by face, the answers seem uncertain. Young and old, proud icons are dismissed. Can machines ever see my queens as I view them? Can machines ever see our grandmothers as we knew them? Ida B. Wells, data science pioneer, hanging facts, stacking stats on the lynching of humanity, teaching truths hidden in data, each entry and omission, a person worthy of respect. Shirley Chisholm, unbought and unbossed, the first Black Congresswoman, but not the first to be misunderstood by machines well-versed in data-driven mistakes. Michelle Obama, unabashed and unafraid to wear her crown of history. Yet her crown seems a mystery to systems unsure of her hair. A wig, a bouffant, a toupee, maybe not. Are there no words for our braids and our locks? Does relaxed hair and sunny skin make Oprah the first lady? Even for her face well known, some algorithms fault her, echoing sentiments that strong women are men. We laugh, celebrating the successes of our sisters with serena smiles. No label is worthy of our beauty. Of our sisters with serena smiles. No label is worthy of our beauty. Of our sisters with serena smiles. No label is worthy of our beauty. So excited now to move the conversation from some of what we've seen with the past with AI systems in terms of describing or classifying to where we'll be going with generative AI next, and also asking, instead of having discriminatory AI, how can we actually move AI such that it is in service of humanity? So with that, I will bring up Peter Irving, and hopefully we'll get to the next slide, please. All right, here you go.
Hello, everyone. Good day, good day, good day. Hi, I'm Peter Irving, design and build smart cities. And we recognize it was an incredible opportunity in where we are with adoption of AI and content acquisition and development. There's a tremendous opportunity to really create the first ever AI TV platform. Currently it is designed for the art of storytelling and giving B2B and B2C the ability to, if you picture or envision yourself having an AI TV butler, concierge service that is really adaptive and really understands your needs as you feed the data to it. We're quite excited. A couple of the key features are watch parties, OBS, open broadcast studios, right? That pretty much a very much affordable version, or open broadcast studio channels. Pretty much we're stating it as a very affordable platform for those who would normally spend the dollars for Avid Studio. So we're quite excited. And another key feature is essentially it's like turning your backyard or your living room or your home into your own broadcast facility. That will be extremely affordable. So this is our excitement, and our goal is to be able to give everyone the ability, the eyes, and the ability to give voice when it comes to content development. So quite excited. We'll play the video. Bear with me 1 second.
Hey, how come the picture quality on this big screen is so poor? I don't know. Let me try their support.
Hi, David. How are you today? I'm Jess, your AI digital assistant. What can I help you with?
Hey, the game is all grainy. What's wrong with my TV?
I checked and your internet connection is in order. The reason for the poor quality has to do with your subscription. Would you like me to upgrade you to a premium? a premium plan so you can watch it in UHD?
I don't know. How much is it to upgrade?
It's $15, but let's not do this now. I temporarily changed your settings so you can watch the rest of the game in UHD. Let's talk again at halftime.
Sounds great.
Is there anything else I can help you with now?
No, I think we're good. Guess we'll see you at halftime.
And that is really just we're on the precipice in terms of where we're going with the future of AI TV and content creation, content generation, and acquisition. Now I'm going to proudly transition this conversation over to Tamar Shaban. He's going to give you more or less speaking into the future. He's an incredible TV and film producer and director.
Hey everyone, I'm Tamar Shaban. I'm a film director, and I want to talk a little bit about the integration of AI in film. In 2021, we saw your words bring images to life. In 2022, they became photorealistic. In 2023, we saw them move, and in 2024, we saw those images become a little bit more cinematic. And in 2025, this is where we are today. Sound up, please. Let's try that one more time. It's all part of the process. There we go. There we go.
For centuries, our world has been built on unity, on the hands that lift, the knowledge that spreads, and the hearts that give. From the grand bazaars of the Byzantine Empire to the libraries of the Islamic Golden Age, for centuries, our world has been built on unity, on the hands that lift, the knowledge that spreads, and the hearts that give. To the libraries of the Islamic Golden Age, we shared knowledge and trade, building bridges long before borders, through the deserts, through time. For centuries, our world has been built on unity, on the hands that lift, the knowledge that spreads, and the hearts that give. From the grand bazaars of the Byzantine Empire to the libraries of the Islamic Golden Age, we shared knowledge and trade, building bridges long before borders, through the deserts, through time. We walked together toward faith, toward home. We defended the weak, upheld justice, and honored our word. We built cities that would last, where faith and knowledge stood side by side. We turned dust into cities, our lands into legacies. We dreamed of a city rising from the desert, and we built it. From beneath the sands, a new world emerged. We carried our faith, our resilience, and our dreams into a new era. Today we stand together, stronger, wiser, unbreakable. And tomorrow, we reach for the stars. Aiden.
It was a piece that was made entirely with AI, and that goes from the visuals to the translation, to some of the sound design, to the scripting itself, and even the voiceover. So the voiceover was using my voice and then changed to sound more cinematic with another tool. For the first time in history, we're able to bring any idea to life from, if you want to go back all the way to the ancient Egyptians, to our present, in any scene, and in the future, you can imagine that as well. It is a prolific time for filmmaking. If you have an idea, that's all you need to bring it to life. Money is not an obstacle in the same way it was. If you want to envision it, you can. And as we're moving into this age, though, what we do need to do is protect the ideas of these filmmakers, of these creators, and create more intentional and more empowered storytellers with these tools. And to speak on that more is Niles Luther, a prolific composer cellist reigning out of Brooklyn, New York, and he'll speak more on the music aspect of it, which also this was composed with music using AI.
Thank you, Tamer. Thank you very much. It's a pleasure to be here today. My name is Niles Luther, and I am the proud AI music advisor for AJL. I just want to give you guys a brief overview about what you're going to hear today. This is a symphonic composition that I composed in 2021 for the Nigerian-American painter Kehinde Wiley. And we installed this film and score at the National Gallery in London. And when the artist first approached me asking for a symphonic composition, he said, I want scale, I want grandiosity. And the budget that we had to create that scale was not present. So leveraging the tools that were available at the time, I used cutting-edge sample technology of a symphonic orchestra. And with that sample technology, I was able to create this score in this film. So I really see the future of AI in music using this sample technology parameterized in such a way that composers can sit down at their keyboard and let their vision really dictate how this technology will be developed and how it will be employed. So this is the seventh movement of the symphonic composition, and it's called Encounter. Thank you. So I'd like to invite our founder, Dr. Joy Buolamwini, back onto the stage. So we can invite you all to the screening of Coded Bias tonight.
Thank you. Give a hand to Niles Luther. I was shocked when I heard he was the only musician on that composition because he shaped each note by hand. AI can't do that yet, but there might be a future where that's a possibility, and we want to make sure we actually preserve the artist's touch as well. And so tonight we are so excited to be doing our first ever screening of Coded Bias here in Kigali. Can I get a whoop whoop? Yeah, yeah. So also we're serving food from what I heard, so I know I'm going to be across the street. We hope to see you there. We'll have a nice reception. We'll be in discussion about the themes of the film, and we'll also have some photos and that sort of thing. So I welcome you all to come, and thank you for the opportunity. Thank you again to Niles Luther, to Peter Irving, and also to Tamer Shaban as well. I was shocked when he told me everything we saw from ancient Egypt to the galaxy was AI. Thank you. Thank you, appreciate it.
Oh, thank you. I'll take one question for Joy, given her expansive work in the arts, in writing, in research, in publications. I assume if we had more time, we would have grilled her, but I'll take one or two questions. Okay, in the middle. Thank you. Someone give her the microphone.
Okay, awesome. Thanks so much. Hi, everyone. I'm Steph Ifayemi from Partnership on AI. Thank you so much all for the presentation. I have a question, maybe it was even for the last two presentations about labeling synthetic content. sorry. We have a few research programs at PAI, and a few are, or one of them is on synthetic content and provenance mechanisms, and to what extent do we need different types of like watermarking or other types of metadata to ensure that people understand that something was synthetically generated for trust purposes. So I wonder what you guys think about that. Do you think that in the case of synthetically generating music or film, that we need those types of signals to ensure that consumers understand that something was generated by a model? And then maybe Joy, just if I can be cheeky and ask a second question. Of course, in Europe, there's a kind of fierce debate when it comes to IP and the use of, or the development of models that are used, and of course fine-tuned in some senses to create these products that we see now, but the data that is used to create these outputs that we see. There's been a lot of pushback in terms of, you know, companies just declaring the data that was used to develop the models, and of course this has implications for artists whose data was used to train the foundation model. So what are your thoughts on that? And would love your thoughts, as we are of course designing policies to think about how we might utilize them for music and film on the continent in the long term.
All good. I'm so glad you asked me those questions, because these are the conversations we continue to have. Last year, the Algorithmic Justice League, we actually, if you go to ajl.org/writers, we did a Creative Seas campaign. So we were actually thinking about creative rights and what does that look like. So first of all, consent, right? Did you ask? Do you have permission to use this data in the first place? So we think of visions for artists using AI being certainly consentful, maybe your own body of work informing what is created next, or open source or Creative Commons kinds of uses. So certainly not for data theft or the data heist that has been the foundation of many foundational models. And in my book, Unmasking AI, I talk about deep data deletion, which is not even just deleting the data, right, but deleting the models that have been trained on data that was collected without consent in the first place. Then, okay, ask me, but pay me. What does compensation look like? And I think you can all speak to that a little bit as well when it comes to data provenance and some of the transparency pieces. Then there's another piece, which is credit. So much of what we see that might inspire awe with AI systems is building on what is already awe-inspiring from humans in the first place, right? And so I think that has to be absolutely acknowledged. And I think where we're firmly experimenting right now is control. Agency to explore on your own terms where you actually have the protections in place. So that's not going to happen with the artist alone. We also need that policy landscape to catch up, and there also has to be real accountability when there are violations of copyright, fair use, and so forth, which we know continues to be litigated. And I'll pass it over to my colleagues to address some of your other questions regarding synthetic data. I think not only do we need synthetic media created, but when I release my poems, for example, Prompted to Competition, where be the guardrails now threaten sight will might make right, hallucinations taken as prophecy, destabilized on a midland journey to open chase, to outpace, to claim supremacy, to reign indefinitely, haste and pace control altering deletion, the fate of AI remains uncompleted, unstable desire remains undefeated, right? And so it's still our responsibility in terms of that type of control. So as I put out my poems, I now increasingly will say human-made, right? I want to know all the different factors that went in. And with that, I'll turn it over maybe to Tamer. All good.
I think it's a really interesting question that you ask, because there are different levels of the use of AI in film. What you saw there was entirely synthetic, and the control that was put in there, there was everything from camera movement to lighting to the angle to the lens size. There's a lot of description to bring out. I studied, looked at history, what existed, what didn't. That is entirely synthetic, and I think things like that should be watermarked, because we're getting into an age where you're not going to be able to distinguish what is real and what is not, especially if it's being passed off as news or an actual event that happened. I think in that case it should be. There are different tools that I'm experimenting with for the use case, where you're using physical production, where a traditional production where you're actually filming something and elements within the scene are AI. And in that case, I don't think you need to specify that, the same way we don't say that this is visual effects when we're working on a CGI pipeline. We've done that for decades now, from like Jurassic Park and before onwards, and we don't have to specify that. I've done commercials. I know colleagues of mine who have done commercials where either the background is AI, and that doesn't take in any way, shape, or form away from people's work. That actually adds value. Sometimes you're working on a project, you don't have the budget, but you want to make that world bigger, and you can now with AI. And I think in that case, I don't feel that there would be that, but when it comes to news or something, a real event, and you're trying to pass it off to manipulate people, I think in that case there should be watermarking somewhere, especially if it's entirely an AI video. So those are, again, this is a philosophical debate that'll keep going on as we move forward. And I mean, I definitely, and then also from the music composition side,
Yeah, thank you. I'd love to jump in and just bring one element to the conversation. I think intent is extremely important. The element of news or misinformation, that's like highly critical. And if the intent is to deceive, like I firmly believe that there should be clear markers that this was AI generated content. But when looking at the perspective of art, from an artist perspective, setting aside briefly for a moment how these programs are trained, because that is inherently problematic with the data that they're scraping from the internet, but just looking at AI as a tool to leverage. When an artist, for instance, makes a painting, or a composer creates a composition, when defining the medium, you know, they have the choice, artistic choice, of saying, this is the medium I used, oil on canvas, this is the paint that I used. It's up to their discretion to say, like, which specific tool went into the creative process. So I'm of the belief and of the opinion that, like, if AI tools that that have been ethically sourced are used in the creative process, it's part of the illusion of art. It's part of the way we believe art is a reflection of reality. And I know that's like one end of the spectrum, and the other end of the spectrum has to be contended with as well. But I don't think it's like so cut and dry as everything needs to be watermarked or nothing needs to be watermarked. I think we need the context of intent.
And lastly, this is an extemporaneous answer to your inquiries, but from a digital rights management perspective, and also largely we've been having these talks centered around with the PROs, the performing rights organizations on the music side, with the various unions, to again being able to put your fingerprint, right, leaving that watermark, as you just so alluded to, which is key. So we're moving at such a warp speed that it's essentially like we're building a plane and learning how to fly it at the same time. Integrity is key, but I think from our side, in terms of where we're looking at from a content creation, content generation, and distribution, yes, it is super important that accountability is there, right, in place. Hope that answers your questions. Thank you.
All right, thank you, Joy, and your team. Really appreciate you coming through super last minute. I only asked her last night in the cocktail in the middle of drinks with different contents. So thank you very much. I appreciate it. You've paid your dues. The panel is coming together, so I want to request them to get mentally ready in the next 7 minutes or so. Before the panel comes on, I want to introduce Joshua Baru. Joshua Baru is from Qhala. I'm trying very hard to do my South African Qhala. Did I succeed? Okay, Qhala. Okay. And he's done, and his team have done a very good study, filling in, like understanding the gaps in AI readiness for the content. He's going to take about 5-7 minutes to talk about an index that Qhala has been working on as the panel gets ready. He's the digital economy lead at Qhala. He's passionate about using research to leapfrog Africa to the fourth industrial revolution. And he leads the AI Talent Readiness Index at Qhala and is the technical lead for the AI Talent Working Group within Catalyzing Africa's Leadership project. Welcome, Joshua.
Thank you. Good evening, everybody. Is it good afternoon? So Joshua Faru is my name. It's actually pronounced as Faru, where I come from. We did an AI Talent Readiness Index. This is a pushback on the global benchmarks that have been put in place. You guys know about the Cisco AI Readiness Index or the Oxford Readiness Index. So we were like, we need to produce an AI index specifically by Africans for Africans, because we need, there's a gentleman in the morning who said that if we are not telling our own story, others will tell it for us and it will not be for our own good. And even to quote Chinua Achebe said that until the lion learns to tell the story, the tale of the hunt will always glorify the hunter. Yes. So this is why we did an AI Talent Readiness Index, specifically looking at all the 54 countries and how ready they are to embrace AI. So this is how it's looking like. So why this index? First of all, Africa's AI market will hit 15.6 billion by 2030, according to the statistics. And then a skilled talent pool is fundamental for this vision to actually happen. But there is a very significant gap in AI talent. And also, policy fragmentation is there. You guys remember the way we were saying that we cannot look at one system, so we have to look at the whole ecosystem, how the whole ecosystem affects one element. So we are looking at the whole ecosystem, we're looking at how data, how policy, how the number of universities in Africa, how they all contribute to the one, which is specifically talent. Because at Qhala we are an ecosystem builder, so we are looking at how the whole ecosystem contributes to the talent. So how can we effectively measure the current state of AI talent readiness and pinpoint key areas to improve, to bridge these gaps? So the AI Talent Readiness Index, it assesses Africa's countries' current capacity to develop, attract, retain, and effectively deploy artificial intelligence talent. So that's how we are defining AI talent readiness, which is basically how does a given country develop, attract, retain, because ultimately we don't want that talent to go away, and effectively deploy artificial intelligence talent. So the three pillars that we are looking at, the ecosystem is digital skills, what's the availability of quality AI-trained professionals, including researchers, developers, and data scientists. Data and infrastructure, does the given country has access to robust computational power, reliable internet connectivity, and the relevant data is necessary for AI innovation. And finally, government readiness. Is the existence of supportive policies, institutional frameworks, and strategic initiatives that foster AI development and adoption.
So yeah, please, the panel can come to the front as Tim asks one question from Joshua.
Yeah, so I wanted to ask, AI readiness actually, the success or otherwise of it can accurately be measured by the level and the nature of integration between the three pillars. So how much does the index capture the integration aspect of the three pillars?
So for digital skills, we have weighted it at 45%. For data and infrastructure, we have weighted it at 35%. And government readiness, we have weighted it at 25%. From the different panels that we had, remember we had representatives from West Africa, North Africa, and then we came up with that weighting structure from the different stakeholders that we had. So it all adds up to 100%.
Okay, any last question for Joshua? There's, I think, 5 hard copies available. Find Joshua and the rest of the Qhala team if you want to get a physical copy. Yeah, so we're ready for the last part of the day. And you've already met most of these folks earlier in the day. Vukosi is going to lead us, and because he has a hard stop, I'll let him manage when he wants to end. So I estimate we'll talk for about 40 minutes, if that. So for those of you who've not met Vukosi, he's a force of power on the African AI ecosystem. He's a professor of computer science and holds the chair of the data of science at the University of Pretoria. He specializes in developing machine learning and AI methods to extract insights from data, with a particular focus on the intersection of machine learning, AI, and natural language processing, NLP. His research is dedicated to improving the methods, tools, availability of data for local or low resource languages. As the leader of the Data Science for Social Impact Research Group in the CS department, Vukosi is interested in using data science to solve social challenges. He has worked on projects related to science, energy, and public safety, and utilities, among others. Professor Maribate is a co-founder of the Lelapa AI, an African startup focused on AI for Africans by Africans. Vukosi is a chief investigator on the Masakane Research Foundation, which aims to develop NLP technologies for African languages. Vukosi is also a co-founder of the Deep Learning Indaba, the leading grassroots machine learning and artificial intelligence conference on the African continent that aims to empower and support African researchers and practitioners in the field. Now, to add on to this, his network is amazing. By the way, we put together this research colloquium in the last, I want to say, 2.5 weeks. We realized there's a global AI summit happening in Kigali for Africa, and we don't really have the AI in the global AI summit. So Vukosi tapped his network to help me bring a lot of the speakers that you've seen today. He's connected with the Indaba network, the Masakane network, and it's through that network that I reached to folks here in Rwanda to get Rwandan representation, as well as huge attendance through his huge network on the continent and beyond. So welcome, Professor Vukosi Maribate. Thank you.
All right. Thanks for that introduction, and hopefully everybody's also had a good day. I think also being locked in for for a day in one room does affect you in some ways. It was raining like crazy outside, just for people who hadn't gone out. I think for this panel, when I was given the brief, we didn't necessarily discuss it together. I think the panel will be going to really their thoughts on on their toes. Is there maybe another mic somewhere? I don't know. Okay. So I will ask. Okay. I'll ask 3 questions. We'll do each question and then get some thoughts. Add feedback. Okay. I'll ask 3 questions. We'll go through your thoughts about each of those. Is it that one? Okay. Okay. Hopefully this one's better. Yeah. I think one is just reflecting at this moment and time where we are. There's a lot of researchers that have been here. People will be joining in online, who are joining in online. So I wanted to ask, as these AI systems grow more complex and resource intensive, how do we think about sustainability on one side? And when I mean sustainability, for each of you, it will mean different things. So I'm actually interested in how you view sustainability and being responsible in these spaces, whether it's socially, economically, environmentally, and otherwise. And then where do we then, who's accountable to really drive us moving towards sustainable AI and AI research and development? Any of you can start. I don't want to think, or okay.
So I think for sustainability and answering to the question or to the context of training, we need to focus on practical problem solving so that we maintain relevance to the context in which we live in, especially in Africa, and so that we can customize customized solutions that are already existing to the African context. Who needs to drive that process? I think we should. We need to own the process, but also we need to engage more between ourselves and have a strategy that runs across the entire continent. We also need to be very deliberate on who we engage. As we had earlier, we are sort of disadvantaged, and if we get into the wrong marriage, then the status quo probably might remain. So we need to have a genuine conversation, and we have to own to what we need as a continent which is quite unique, the challenges that we face in light of our position where we are. Thanks.
Yeah, thanks for the question. This is Tayo Oguntebi, representing the ML compute sector. So my first thought on sustainability comes from the system standpoint. I'm thinking about energy, pollution, and so my first thought goes immediately to the issue of power and energy. I think we're at a point in Africa where we haven't yet built a large number of hyperscale data centers, and we have a chance to kind of decide strategically how we do that. So we should lean into our clean energy resources. I think we can decide to build in places where we have a lot of natural power that doesn't burn coal, and so on and so forth. Secondly, I would say that from going back deeper into the systems, there are certain types of models which are more efficient than others, namely sparse versus dense. I would say we should lean into sparse models, which activate a smaller number of parameters at a given time and should make us more sustainable. And finally, I would say quantization. We should be thinking about smaller and smaller number of bits to represent our models, and this is another way to be sustainable from a system standpoint. Thank you.
So when I think of sustainability, I think of the AI, the entire AI ecosystem, the entire AI pipeline, as opposed to a data center or a given model And what comes to mind is we are realizing, especially with generative AI, we are waking up we are having an awakening that, running these models requires massive amounts of energy, compute. Even the data centers require massive amounts of water. And we are only being informed, we are only learning about this massive resource drainage, especially for generative AI, and you can do the trade-off. Is it worth it in the end, given that generative systems, text generators particularly, are inherently unreliable and problematic, so we can put the trade-off aside. But a lot of what we know about the energy consumption, water consumption, comes from investigative journalists kind of doing detective work and piecing one in one together. And there is very little transparency. There is very little information around, data on data center operations. And this is actively kept, obscured. This kind of information is kept from the public, from auditors, from academia, from investigative journalists, because it's damaging for big tech corporations. And again, we've heard so much around building our compute clusters, our own data centers across the African continent, but we haven't paused to ask who actually benefits from this. And the most obvious answer is, again, large corporations and big tech companies that extract value from it, although there might be like little drips of benefit for local communities that do physical work at the data centers, or even that do kind of a lot of the gig work. Those are the kind of little crumbs we get from this massive resource drainage due to compute clusters and data center operations. Okay. So who needs to be held accountable is, again, large corporations, big tech, and governments.
Thank you.
Okay, so we're in a situation that can be seen as potentially challenging. If you look, for example, even like the tech industry in Africa, developers, now you have models that are doing the work much faster and potentially better than people. That's reality. And we discussed infrastructure. I mean, the number that's striking is, I think Africa, we're talking about like something in the order of like 3% of global GDP, but we have less than 0.1% of global GPUs. That's a significant issue. And it's getting even worse because it's not just about GPUs, it's also about electricity. And the continent needs a lot more electricity already without AI. And now you have AI on top that compounds the problem. So it might seem like quite challenging, but fortunately, actually, there are amazing opportunities that we can take. And the first one, like was said, is renewable energy. Like if you look, for example, at solar power, solar power is taking over the world. People have been wrong about it. The experts at IEA and others, they've been wrong, consistently wrong. The exponential is happening much, much faster than people think. And the beauty of it is it's actually now, with other renewables, the cheapest source of electricity in the world. Why is this important? Because it happens that Africa has the biggest renewable potential and solar potential in the world. We're the continent best positioned around the equator, so the opportunity is incredible. If you look, for example, at data centers built in the US, including Project Stargate of OpenAI and its partners, SoftBank and others, they are starting to deploy solar panels. But the cost there, at the very best, they are like $5–6 per kilowatt hour. In Africa, we could get it as low as 2 cents per kilowatt hour. So we could have, compounding the other advantage we have, the most efficient data centers in the world powered by renewable energy. That's really amazing. And so who benefits from that? That's the question was discussed. It's not just the hyperscalers, it's the entire tech industry, because really we are moving from a world where I'm writing the program myself into I am managing extraordinary AI agents that get the work done. And for me, this is an extraordinary opportunity for Africa, because the work that a team of talented 10 people can do is the equivalent of what would have been a big software services company, 300, 400 people in the past. And if you have the data center efficiently powered, well, the agents are going to be in the data center feeding to this economy. So where there is an opportunity is small startup-style teams all across the continent that could be very economically competitive, low cost base, but access to the entire world market, leveraged by agents. That, to me, is the exciting opportunity we need to take.
Okay, thanks everybody for that first round. I think maybe to reflect before going on to the other questions is that, so one of the things that happened with a number of people who are going to be at this conference is we were part of working on the African Union Development Agency's white paper on AI. And this is like 2021, 2022. And one of the chapters there talks a bit on, I think, like as I said, I was going to ask you and then you were going to choose what sustainability was. I didn't say in whichever way. So it came into these issues of obviously how, like, you know, energy extraction and what that is used for. So there was a chapter that really was thinking about infrastructure on the continent, and now you touch, like, you know, you touch on where's the energy going to come from, where the networks, where on the continent also becomes a major question. And maybe a point of reflection for the room is to think, saying like, yes, on one you can choose horses, you can choose countries, you can choose spaces where you say, where are we going to put all these solar panels, right? But it has to be contextual to what the needs also of the people. Do we necessarily build power plants? They could be solar, they can be wind, they could be whatever, to feed GPUs or to make sure that people are energy secure, right? The reason that, like, I'm going to ask this is because these are now, if we think about more recent history and we think about industrial revolutions, you know, maybe second industrial revolution, a lot of Africa was going through empire and colonialism. Third industrial revolution, we were, like, you know, getting freedom and independence in different ways, so there were other things. And now we're having this change that's happening. And how then are we managing how we move forward in that it's not simply the technical or the systems, but then there's the needs of the people, there's the training that has to happen, all these things. So with that, then the next question that comes to me is then, we're going to be told, like, now maybe this is about the economic benefit and economic opportunity for the next 2 days, right? How do you see that now, right? So I'm asking to be, we have the, like, the things that normally sit on the tip of our tongues, but let's just reflect on how each of you have thought about but where's going to be this economic opportunity? How do we navigate these very sometimes competing priorities we have to, and how then do, like, researchers put themselves in such ways that they can also answer some of these tough questions? I'm not saying you're going to answer the tough questions here. If you do, please charge people a lot of money.
I think I'll give this a go, because it's kind of, it indirectly touches a lot of the recurring theme throughout the day, conversations with the audience, and some of the points that the presenters touched up on themselves. I don't think the answer is one or the other. I don't think the answer is like we should use the energy to feed GPUs or to feed people. I think there is a lot more nuance. But what makes me reflect in light of the conversation we've had all day is that we are, especially today in this room, we have overestimated and hyperinflated what AI can do. We are talking about revolutionizing education using AI. We were talking about eradicating poverty using AI. These are not things AI cannot do, no matter how large, how good, how representative your data set, no matter how big your model, no matter how large the parameters. These are things that are political, that are historical, that are cultural, that first and foremost need the political will. You cannot change, the way education systems work or people's poverty by just deploying massive, sophisticated AI systems. If you want to address these things, you have to actually tackle the problem from the root causes. And the problem with a lot of this talk trying to assuming that AI can solve a lot of Africa's problems is not that AI is not able to do it. It's also we are taking away resources from institutions, from structures that resource people, that fund people to actually work with people, to actually tackle these problems from the root causes, and we are pushing it into AI because, again, we are assuming these are problems that can be solved by AI. And this is really disturbing, especially, this is super problematic. AI is not a magic bullet that can solve everything. AI is good at very few certain things, for like in the case of, say, gender discrimination or educational poverty. If you have simple tasks such as, I don't know, classification or discrimination, not discrimination, but simple tasks of understanding certain patterns or certain phenomena, yes, AI can give you some kind of insights. But it is not there. It just cannot address. These are complicated issues, and by pushing AI, we are actually making the problem worse. And we've heard here in the talks where we are really rushing to blindly adopt AI, no matter at what cost. This is actually regressive. This is backwards. And sorry, I'll stop there, but we really have to think critically about AI before we push it into every sector and cause more problems and exacerbate more problems.
Okay. So,
thank you.
It's an interesting take. What I wanted to say is, first, if you look at the situation of Africa historically, okay, we have been running economies on selling resources, and notably energy resources, and selling relatively affordable labor. Okay. Now, what's going on is that essentially labor's costs are going to come massively down with AI, and energy is going to become abundant. So intelligence and energy are going to become incredibly abundant. And so, coming back to your first point, Vukosi, I think definitely we need a lot more energy and electricity over the continent, but the renewable potential is so big that you could do this and power the AI revolution. Like, if you look at the numbers, the continent has renewable potential, which is actually economically tappable quickly, that is absolutely insane. So, where I agree with you is on the fact that most of our problems are man-made in the sense that we don't have the right regulations and other. Like, if we tap into the energy potential of the continent, it's insane. If we tap into the innovation capability, I spend a lot of time in startups, advising startups on top of running mine, the potential is crazy. So we need to adopt AI. If we don't adopt AI, we're going to be left behind. Now, this doesn't mean that yes, we will, because I've been in AI for a very long time, and I can tell you that most of cognitive tasks done by humans will be done by AI in principle this year. This is how fast it is happening, and it might seem surprising, but I feel a duty and responsibility to tell you the truth. The truth is these systems are way more powerful. They're not doing simple classification stuff. This is AI of 5 years ago. Go and check what the system can do. It's absolutely mind-blowing. This doesn't mean, though, that we do not have organizational issues, political issues. This I totally agree on, that we have hurdles that we need to overcome. But what I'm saying is, from a fundamental perspective, we can really master these resources and deploy them for the benefit of the continent. And so growth is totally possible. And it can be even done in a self-sustainable way. We do not need billions of dollars of aid. We just need to be smart and know what the world is doing, where the technology is going. The technology has been surprising everybody over the last 10 years. Look, I've been running a team of AI researchers. If you had asked me 5 years ago where we would be in AI today, I would have probably lowballed compared to what's going on. It's absolutely incredible. And so we need to see it as an opportunity. We need to adapt those tools to our context, but the world is going to move towards intelligence is abundant, energy is abundant, and that's the world, these are the parameters that we need to work with in Africa. Fortunately, it's actually possible. That's the good news. Exponential value creation is possible. I can even take the example of my company. We started literally with 2 laptops and $2,000. We built up the largest exit in AI outside the US. So if you ask me like, oh, can we do something in Africa? I'll tell you, hell yeah, we can do big things. But the first step is to believe it's possible and then identify rationally what's needed. And from that point of view, it's not governments that are going to provide solution. Governments are going to be supporting the ecosystem. It's us, entrepreneurs, decision makers. We need to go on the ground, create the values and the opportunities of tomorrow. And the good news is this is possible. And the future is not going to be built by saying, no, no, AI is not for us. We need to embrace it and be pragmatic about it. Because I'm not being naive here. It's an extremely hard challenge. But I'm just telling you, it can be done. That has been my experience over the last 10 years. And I've seen incredible entrepreneurs all across the continent. We need to give them that hope, that support. Like, if we look at what people could do, just a few people today, is insane. Like, what would have required me a team of 50 people 5 years ago can be done with 3 people today. This is an extraordinary chance because we are rich in human potential. Obviously, we need to educate people, we need to train them agents, but the potential is off the charts, and it's us to take, and so we need to embrace it positively.
I think maybe to drive it, then we'll come to Taya as well. I'm leaning in this one. Maybe Tim, if you then think, like you initially were engaging on training, right? So how then, like in this space, again, I'm trying to go in and say, like, we are always in, like, in the space of, as humans, in pieces of dilemmas. There's no right answer in a way, but there's these parts of trying to understand. One, I was going to say, between Karim and Abeba, almost, so like, can we take a one bet that Qhala can follow on in 1 year, given Karim's assertion in that space. But at the same time, I think it is, the realities are like, the ground. These things are still things that we have to figure out. And those things we can't necessarily figure out within a year. We hope so, but that's not. But we'll take that bet later. I'll talk to Shiko about that. But Tim, then in thinking about the space of, we are trying on one side to develop young people, prepare them for the future and new imaginations about what the future is as Africans. How then does that then fit with what, like, maybe at the moment Karim has said and Abeba has said? In your view. And then we'll go to Tayo. I know it'll be hot.
I think having grown up in this environment, and having known how the world works, I think I'll go towards Karim's inclination. If we don't catch up, if we don't empower through training, through investments, somebody is going to fit into that space. And we're still going to remain in the current state or even worse. AI is here, and it's here to stay. And it's going to be disruptive. It's going to be disruptive at social level. And we in Kenya, and I think even in the US, if you have an eye for it, you can see the amount of AI and fabrication of the social aspects that we've taken for granted for long. We've just had a session here about how do we tell deepfakes How do we tell real? Yeah. So that's gonna matter a lot. And I think taking from the training perspective and our comparative disadvantage in terms of compute, we really have to invest in empowering the youth. That's going to be very positive in one way. I think we can domineer in this space relative to the rest of the world because we have access to information at almost equal level. It matters training. It matters expertise. Worst case scenario is the problem I discussed as translocation, which is a borrowed word from genomics, where you just take the best that we have, take it out of the continent, equip it, and then stay with it. Yeah. So that's not real problem because even Tambe will give us quite a lot of advice from where he is. But if we push into talent development, empowerment, with even the limited compute infrastructure that we have, then we are going to have a strong position in the next 5 years. Now, what aspects of AI should we venture in? I think we need to strategically think about prioritizing certain aspects of AI applications that we can get a win from. Because if we don't, then we might lose the race. The AI is data dependent. It's data dependent. Just like oil was a driver in the 21st century, whoever owns the data will call the shots. Yeah, so if we don't curate our own data, I think we are going to be doing a disservice to ourselves. We can win in, let's say, Karim's field where the next big thing after quantum computing will be personalized medicine at genomic level. I think that's something that we can reach, yeah, and we can easily achieve if we train right, if we focus on problem solving rather than just sort of very silo-ish approach like we've done science in the past. Thanks.
Just to reflect very briefly on what you said, I give you one startup idea, which is obvious, and nobody's doing it to my knowledge at least, is given the diversity of the continent, have African companies build up genomic and multi-omics data assets. You know, this is not something you want others to do. You want Africans to do it for Africans. That's an obvious opportunity, and we're not doing it. So a lot is just having the strategy and going and build, and totally agree with you.
So before Tayo, because I think on one is I just want to also say, like, all of you here are computing experts, right? You look at the world, though, in different ways, and that's fine, right? Because that's how we build up knowledge and we study ourselves and how we move ourselves forward. But Tayo, if you now, like, you know, I'm urging you to then say, okay, we have these power dynamics in terms of where you're like, I'm saying it here because I'm like, from tomorrow and on, there will be a very different thing. I'm asking it here, is now how do you reflect on that of saying there's these power dynamics, you're coming in this space. How then does the technical feat match the needs necessarily that are also there realistically? I think we're still staying within the same thing, but then that, yes, it's about figuring out where the energy might come from. It's about where's the best place to put these data centers, but then how then does that match with the communities that are there, right? And what their needs might be, and how like, you know, how do you think about that in your station?
Yeah, it's a good question. Before I answer that, can I speak to one of the points that was made? I don't want to forget what I was going to say, and then I'll speak to that. But I think some of the cautions that Abeba brought up are very valid. One example she raised about AI solving poverty, I think should not be said in that way. That being said, I do think that there are bite-sized pieces which materially improve quality of life that AI can potentially tackle. You raised education, for example. The notion of a very intelligent, personalized tutor, I think, is not something that is very, very out of reach. And I do think it wouldn't replace teachers, but I do think it would improve education for students across the continent. Going to what's also said about, do we need AI? What's the real benefit? I think that underestimating the models also is very, very dangerous as well. Because if you look at, for example, the COVID pandemic, it was a time when there was a lot of fear, a lot of uncertainty, and there were models of vaccines around the world being created. And it was a point when, as Africans, we didn't have much power, much leverage to get those vaccines. And the way AI is going, it's unclear how strong these models will get. I think it's very dangerous to be in a place where we're unable to join the conversation when that time comes. So yeah, I mean, I'll stop there, but I do think it's important for us to be ready to strike when the opportunities come.
Can I will have, I will get you. I was just going to say, people, I think we can take 2 questions from the room, and then Abeba. That's all I was saying. I wasn't going to put in my comment, yeah.
Yeah, just to quickly clarify, I'm not by any means objecting development of AI, even deployment where it's necessary. I consider myself a technologist. I consider myself, I get really excited whenever there is like a new tool released or a new model out there. But it's entirely different to fully embrace AI, to be positive about AI. On the one hand, what you find often is this narrative that pitches optimism about AI. You are talking a lot about potentials. I'm talking about the reality. The potential, there is the potentials. We don't know if it's going to happen. We don't know what will come of it. But this idea of pitching potentials and criticisms against each other, against innovation, is not only inherently uninformative, it's also unscientific. Look at any academic field. Science itself is built on the principles of replicability, falsification, reproducibility. None of that exists in AI research. I am an auditor. A lot of my work focuses around actually investigating, systematically and scientifically investigating whether AI systems that are deployed with really grandiose claims, whether they stand up to scrutiny or not. Unfortunately, a lot of that kind of work falls under this very negative, anti-innovative narrative that is pitched against this positive potential. We have to get on the bandwagon. We have to be part of the conversation. That dichotomy is absolutely false. If we actually want to get on the conversation, if we want to be part of the AI, and we should be, what can distinguish us from what's happening in the rest of the world is grounding our AI development, our deployment in actual scientific principles on only embracing AI systems that can only bring benefit to our communities, to our people, not to large companies, not to AI, not to the AI industry. And that's what's happening at the moment. And again, like, there is inherently nothing about AI that will revolutionize the world, that will make things abundant. There is inherently nothing. Because unless we actually, we actually ensure there are proper mechanisms and guardrails that, shepherd AI systems in a way that are developed in accordance and in alignment with fundamental rights, in principle with, respecting for persons and so on. That's what I'm arguing for. I'm arguing against this really just, blindly jumping on the bandwagon just because it's AI. we don't need to adapt it just because it's AI. We can distinguish ourselves by doing the actual work and only getting on the bandwagon on AI systems that are proven to be, beneficiary for our communities.
Yes. So
I think
just quite quick. But Abeba, I totally agree with you on grounding those systems in our realities. That is a must. I'm actually supporting more people doing AI in Africa because we need to adapt those technologies to our context. 100%. Can these technologies be sometimes badly deployed, be overhyped? Absolutely. Yes, this happens. Yes. But this being said, this is a technological revolution that is a fact. When we talk about potential, look, when I created my company 10 years ago, I created it back home in North Africa because I wanted to test this hypothesis. Do we really have potential or not? I could have very easily done it in London or New York or wherever. No, I wanted to do it back home to really see, can we really build projects that are ambitious, that do deep tech innovation, or is it just hype and potential, like you say? Yeah. And the thing is, 10 years later, I can tell you it's no hype. And actually, I've been surprised by this journey. If you had told me everything that would happen, I would have not believed you. Yet it happened, and it's not just our specific case. I see amazing entrepreneurs. So I think it is extremely dangerous to underestimate the economic potential that we have for the continent. Yes, we need to ground it. Yes, we need to be careful. And yes, we will make mistakes. But this is a wave that is really happening, that is proven by countless other players all across the world. Saying no to AI, it's like saying no to the internet or no to the cell phone because we need to verify stuff and this. Of course we need to verify, of course we need to adapt, but I can tell you something, this technology is changing the world and it will change our world. And the more we are part of it, the more we have a chance that it changes our world in terms that are good to us. If we say, oh, no, it's not proven and whatever, it is proven. We have 1,000 benchmarks done by all the companies in the world. You have reality on the ground. You have innovation done by Africans. And this is really important. We put a spirit of innovation there. And we need to embrace the technology in a pragmatic and realistic way. But saying we shouldn't embrace and this is a fad and we're talking about potential, that's not proven. Look, I've been there. I've done that over the last 10 years. I can tell you the potential is much, much, much bigger than you think.
Okay. And the one is like some of these we can go on all over. Yeah, we'll do the questions. But I think on one is like, look, we want to encourage us to have a different way of thinking about our shared futures, and I think this is part of it. Is that bringing these pieces together and then trying to navigate across the spaces. I'm just trying to make sure people in the room. It's not like to go like we have to have the discussions and the conversations, and the thing I'm happy about is that we're having it to ourselves, right? Not, to exchange in those pieces, and I'm very thankful for the panel for being able to bring these points in. I think there's a question there at the back. It's hard. We could have a whole other summit.
It's a fascinating panel. My name is Martin. I'm a faculty member at a university in Kenya called Strathmore. I'm also involved in an AI startup. I want to direct my question to Karim and Dr. Abeba. Very fascinating exchange. Assume you had access to $500 million. So just for a moment, imagine $500 million. That's roughly 5% of Equity Bank's asset base. And assume for 36 months, you had unlimited, unrestricted use to the $500 million. How would you use it? Provided it was for AI, how would you use it?
I'll start. So I recently founded and running a research lab called the AI Accountability Lab. And that's basically what I want to do. And I'll tell you maybe a little bit about what we do at my lab And that's where I would invest it, maybe a little bit more. So what we do is, obviously, yes, I see the advantage of AI. I see where it can, I see its potential, but in a very, very limited way. But I also see, especially over the past few years, I also see there is a massive discrepancy in basically over the past few years, maybe even the past decade, the AI company has completely taken over, everything, the market, 20 years ago, if you look at the wealthiest corporations, you would find a lot of variation. You would find a lot of diversity from automotive companies to, food chains, supermarket chains. That has completely changed now. AI companies, big tech is not only at the top, their power has become so unprecedented. They are basically, they are above the rule of law. They are basically doing whatever they want. If you, especially with US politics, with the rise of Trump administration, we are seeing that big corporations are actually doing a lot of the progress that have been made globally. They have removed guardrails to fact check their social media platforms. This is Meta. They all have, before they have pledged not to use AI for military, one by one, starting from, OpenAI, Anthropic, even Mistral. They have Google, Amazon. They have all abandoned that pledge. They have all walked back their commitment to respect civil rights, civil society rights, fundamental rights, to respect DEI. Where I would spend it is ensuring that there is data on, on whatever they are doing, their contracts, their data center operations, even like benchmark results. We don't have access to benchmark results. So the benchmark results coming out of these corporations, we are supposed to take them at face value. This is what I mean by I'm a scientist first and foremost, and I believe in ensuring that the AI we develop and deploy adheres to basic scientific principles such as replicability, transparency, and none of this is true. There is absolutely no information. All the AI research happens, most of it happens under corporate labs with very little, independent audits, independent evaluation. So where I would focus is, as a scientist, obviously, I would come at it from a scientific point of view to improve transparency, to improve accountability. I believe in making the most powerful corporations, they are my target. I believe in making sure that they are held accountable for the systems they choose to develop and deploy. And that's where I would focus in, training talent, in building compute clusters, in training PhD researchers, and so on. Because first and foremost, we need a transparent system. We need accountability so that we can adhere to the rule of law.
Actually, totally agree with that. I think, yes, we do agree. We do agree on a lot. And so. And by the way, it is true that the field has become more closed recently, and that's not a good thing. Fortunately, we still actually have an open source movement. And when you see models like the Llama series or the DeepSeek R1, for me, this is a great opportunity for us Africans, because really this means that we have powerful systems that are completely open. Like you have the weights, they're free of rights, and so Abeba, you can actually do all the experiments that you want because you do have access to the model, and there is nothing that is not available, which is good stuff, and we need more of that. Now, coming back to the interesting question about the $500 million, right? Yes. What I would do if I had access to $500 million is that I would launch at the same time several projects that are additive to each other, so that the compound is a lot more than just the sum of the pieces. So we discussed renewable energy, and by the way, renewable energy is not solar. Solar is the big one, but geothermal is very powerful. I mean, Africa is full of renewable energy resources. So I'd start with electricity generation in an extremely competitive way, acquire some data center capabilities, and at the same time have a modern educational program to teach people not just how to write code, but how also to use AI agents and give them that capacity. So you would launch these three, $500 million, probably thinking something like 150 million on renewable energy, 100 million on data center, 100 million on education, and the rest, what you do with it is you encourage from the people who are getting this education that are going to have access to compute power, because we discussed earlier, if you remember today, our limitation is compute. If you don't have compute power, you're not going to be part of the future. It's as simple as that. We absolutely need this, and at an affordable and green energy resource. So you have these. Then for the remaining of the money, you create, which is in the order of what, $150 million, you create a system which is incentivizing young talents to create their own projects, to cater to the community. And this is also something where we agree, Abeba, we do not have enough projects that are grounded, that take care of the needs of the communities. And so you're essentially providing seed stage financing to many startups that are going to tackle multiple specific aspects in healthcare, in robotics, in like all the typical, anything you could think of that where there is a real need. Data also, creating our own data assets, not being dependent. And so actually, if you do what we just described here, the net value you're creating could actually be bigger than $500 million on top of the human benefits and the independence versus the large corporations, which we need in Africa. So what I'm saying is we could go a really, really long way with a bit of funding, but importantly, a smart strategy.
Okay, thanks. I can't, it'll be very tough, I think, in this.
It's doable.
Okay. No, it's not even that. I'm supposed to be on the other side of Kigali. I know Kigali is not far to go from one place to another, but this is going to be tough. I think it was Stephanie. Okay, the way we're going to do it is we're going to take 3 questions. After those 3 questions, please note which ones you might be interested in. We're going to be doing a closing remarks in that way. I had the last question, and that was going to be the closing question, but I will abandon that idea because this has been fascinating. So we'll do Stephanie, Anisha, and then the one on that side. So Stephanie, the mic.
Thank you guys for the panel. It was very, very interesting and insightful. I'm glad that benchmarks came up a few times. I think you all mentioned benchmarks, and we also started with the discussion with sustainability because, and also I didn't introduce myself. I'm Stephanie Ifayemi. I'm from Partnership on AI. We're very engaged in, for example, the work at the OECD, and one of the pieces of work that OECD has is around trying to develop a taxonomy or benchmarks for environmental impact and sustainability. So here, I think what we found is that actually we don't have the benchmarks just yet when we think about the sort of environmental impacts of across the value chain, everything from extraction of resources through to the, transport of materials needed to, even develop GPUs through to the training of the models through to post-deployment. So the energy use, for example, as people are adopting AI and using the models themselves. I think it's great that we've talked about the opportunity, and I think that the debate we've seen is really important, that there's a strong opportunity here, but we need to understand the risks most clearly to ensure that we can grasp the opportunity in the best way, and part of that for me is really getting the benchmarks right. So with that context, I think the question for me is that when you think about where a lot of the work to understand the risks is being done, a lot of sub-Saharan African countries are left out of the discussion, and that's going to be important in the because it will inform how the benchmarks are captured, and including capturing the risk in a way that accounts for the ways in which African countries can experience the harms. So maybe we've talked a lot about financial investment. I think that's come up throughout the day, but something I've been missing is how do we ensure that the way we grasp the risk accounts for risks by ensuring that African countries are at the political table to ensure, and also standards bodies where a lot of the benchmarking is being done, because otherwise we're kind of, I think as Abeba said, jumping into this is an opportunity, this is opportunity, but we need to get, we need to design that in a way that ensures that we've been part of the risk conversation too, to really see the outcomes, I think. So maybe the question is, and just to summarize, and sorry it's a long question with a lot of context, the question is, what do we need to do outside of the finance question from a political perspective to ensure that we aren't left out of those dialogues too?
Okay, then the mic should come up here quickly. Oh, thanks, Stephanie.
Hi, so I'll reintroduce myself. I'm Anisha Peters, and I am the CEO of the National Commission on Research, Science and Technology in Namibia. What we do is we're not only a research funder, but we also determine the research priorities for the country that goes together with the national development goals. Another part of what we do, we're a regulator. We regulate everything in research, science, and technology. We also regulate biotechnology. We regulate biosafety. We regulate space science. If Starlink is asking to set up whatever, that comes to us. So in that, we've also turned away a number of AI companies from outside and researchers who say, well, we want to come set up a lab in the desert because we want to do X, Y, Z. So participating also, I myself have participated around the world in developing metrics and evaluation mechanisms for AI systems. So coming back to the poverty discussion, there's a difference between poverty reduction, which is what I think the professor was hinting at before when he was explaining, versus poverty elimination. You can never get rid of poverty, but you can reduce it. Now, there are, across Africa, already many use cases in different areas that can contribute towards economic development and can contribute towards poverty reduction. Those were the examples that we gave that came out of our report for the ASRIC. The other thing is also, if you look at agriculture, healthcare, water, energy, renewable energy, even oil and gas, even nuclear, if you look at all of that, right now, AI is what is the big driver towards that. And it's an augmentation. It's not a replacement of the humans. It's working alongside. If you do smart agriculture, it's not the same as eliminating the human completely. If you do, for instance, in green hydrogen right now, I'm commissioning a big study alongside South Africa, for instance, on green hydrogen and AI. It's like the big talk. And what is it? It's actually to see how do we reduce the footprint, or how do we sort of look at the climatic changes, the community changes with setting up so many green hydrogen plants. So this is why I'm saying AI is considered as an augmentation, but in all of the sectors, you can see its footprint and how it can assist us towards poverty reduction. And I think that was, if I remember, that was what the professor was also hinting at. Thank you.
Okay, so more comment there, and we're still on opportunities beyond finance. And then the last, there. Let's keep it at 30 seconds, because yeah.
Yeah. Hi, I'm Betsy Moravi, a research fellow at iLab Africa at Strathmore University. So Karim, you said that technology revolution in Africa has been there for a long time. You know, it started with internet access will change everything. We are still working on it. Then it went to smartphones will change everything. We are still working on it. But the one technical innovation that I'd like to point out that kind of we saw the potential and it kind of transformed everything was mobile money. And the reason for that is because it addressed a need. So banking the unbanked. We had a lot of people who couldn't, you know, access formal banking. So there was a huge market potential. And then there's also it didn't need internet access. All you needed was a feature phone, which were affordable at the time because the cost of mobile phones had drastically gone down. And so it was an opportune moment. And so it has transformed the economies of sub-Saharan Africa quite exponentially. So with AI, my question is, what is that innovation that would change or transform our economies? So computer vision models came and went. We are still, waiting. Language models are now here. So the language is the new focus. We are still waiting, and you're being told it's the answer to transforming our economies. So I think we need to be forward thinking. So maybe I'd ask each panelist, what is that AI innovation that you feel as the continent we should concentrate on? What's that specific problem that you are working on and you feel that you could get other people to work on it as well?
Okay, so we're going to start with Tim as we're closing and just looking at, opportunities beyond the thing of just financial. Right, and then the last is also connected.
I believe we haven't even started. So we really haven't started. And I think AI will be leapfrogged in almost all aspects of our lives once we achieve a quantum computer. Because once we do that, encryption changes and we can't even communicate as easily as we are right now. And all channels become unsafe, and possibilities of adoption into other areas of our lives, we shall only feature them or understand them then. And that's why it also would be very hard to benchmark anything in the AI space. In fact, there's been lots of discussion about what should and what should not be allowed. The possibilities are endless. We're just setting off. But we should benchmark on some issues. I think issues to do with ethics and ethical AI is a must. Because that's a common thread that will, what do we allow? What kind of applications do we apply? If you actually do a bit of research of military applications of AI, I think that's what Berhan has a lot of issues with, because it comes, the application come with a bit of trampling of fundamental rights. So on financial, I just talked about the break that's just about to happen. Even M-Pesa will not matter anymore. So that's my perspective.
Thanks, Tim.
About augmentation.
Tim, I think just for time, maybe let's do Tayo.
Thanks for the questions. So the second question, honestly, I don't think we know. I definitely don't know. The two sectors which excite me the most are healthcare and education. I think education would land first and have meaningful impact, and healthcare further down the line. To the first question about being in the room, I look to the governments. I think governments will ultimately have a role in denying or approving how things go, and they have to be wise and forward-thinking and do the right things for their countries. So those are my answers.
Okay, I'll make it very. I'll just say one thing. I'll just say, I mean, we all want to be excited, and it's great that you are doing all that. But what I want to say is, in all this excitement, how many of us are asking, as we think, this technology is revolutionizing sub-Saharan Africa or banking the unbanked, how many of us have looked in depth into the people at the bottom of society, the poor women living in rural areas? What are the economic and the societal impacts that these the application of these technologies have on them? What is under the surface? What's beneath the surface? Because I can tell you, the recurring theme, whether it's research in Africa, sub-Saharan Africa, or Europe, what you find is that when you actually do evaluation and impact assessment, what you find is that people, again, at the bottom of society are systematically disadvantaged, systematically kind of disfranchised, whether even a lot of like the money lending apps, they are proven to be extractive, they are proven to be predatory, that leave people, you know, women in rural areas in massive debt. So I just want us to ask, from the perspective of the people that are, you know, very likely to be negatively impacted by this system, I just want us to look at these questions, whether if there is an actual advantage. Of course, there is an advantage, of course, to the people that are building and deploying this system. What I'm asking is like, is there an advantage actually from the perspective of those that are at the bottom of society?
Yeah, and actually inequality is a very important topic, just to be very clear. AI by itself is likely to increase inequalities, and so we need to counter that. No, of course, you know, of course we agree on a lot, and I'm glad. And actually, I was going to say also healthcare and education, and these concretely can be a solution for people who perhaps don't have access to great healthcare. One of the limitations in many rural areas, my dad was a doctor in a rural area, was that it's almost impossible to see the doctor. So if you have systems, and now we're getting to systems that on a medical performance, in certain use cases are actually getting as good or better than doctors, plus some qualified personnel, maybe not doctor level. This is one solution where you can have better healthcare, and you can have also better digital education, because for many women it's not easy to go get a job outside the home. Yeah, and so if you have systems, tutors, including AI tutors that teach you how to program or how to build digital assets. I've seen this in some countries where you have a much bigger engagement in terms of women in the developer ecosystem, and that's a good thing. So these are two examples. On my side, so tell me like what is interesting beyond healthcare and education, which are really, really big. I would say the potential in terms of economic development and startup developments across borders. You rightly mentioned like financial innovation in terms of like mobile money, etc. It has still issues. But one solution is what we call stable coins, because with stable coins, you can actually have point-to-point transactions without any kind of limitations. And if you factor that into small teams, small companies that are building products where you have perhaps 5, 10 motivated, hardworking people supplemented by hundreds of agents, you can have a very thriving agentic economy, let's say. This is for the future, it's not for today, and we have needs in education and healthcare first. But what I'm saying is, one of the things that strikes me as a missed opportunity for all of us Africans is how difficult it is to do cross-border trade, how difficult it is to go from one country to another. There are too many blockades, and those systems can offer a way to create a much more integrated and prosperous market. It's a real potential there. Thanks.
Okay. Yeah, I think in wrapping up, thanks everybody for being on the panel. Thank our panelists here. Let's give them a round of applause. And at the same time, I would just encourage people, please, as Africans, be in the rooms over the next 2 days. Have your opinion, add to the debate, into the discussion. We should not be quiet, because this is our revolution. It shouldn't be that it's people telling us. It's us saying, what is it that we want out of these? How do we want to make sure that it is shepherded, it has guardrails, all these things. It's not something that is just going to be coming out of the heavens and being handed over, because then it really won't represent what we want. So thank you, and also thank you also for this opportunity. So thanks, everyone. Thank you.
All right, we'll take this panel has been amazing. Don't you guys agree? Right? Okay. We'll take one quick picture as we prepare to close out. Thank you so much. We are approaching the end. I'll make a few quick announcements, and then folks that have time should go check out Joy's screening of Coded Bias. How's everyone feeling? Yeah? This is it. You guys have made it. You are the champions, right? You're here. It's end of day. I'm very, very proud of you. I want to thank a few people that have put this together. Qhala, led by Shiko. Shiko, please wave because no one has seen you here today. The partners, Smart Africa, Rwanda C4IR, the Carnegie Endowment for International Peace, Qubit Hub, Carnegie Mellon University, especially Professor William Mutero, Professor Moise Busogi, Professor Mitra. Moise brought a bunch of equipment here today for posters at the very last moment. Masakane, led by Vukosi, who you just heard from. The setup team at the back in the hallways, 63 Inc., we thank you. In spite of the few glitches, I think we've managed to get achieved our discussion. I want to thank the Qhala team who put this together, but I want to highlight a few people. Lois, please wave, for keeping the Qhala house going and getting this done. Asha, who's not in the room, for helping with project planning that made this possible. I want to thank Eunice. Wave, please, Eunice, for everyone to see you, with all the logistics for travel and much more. Tyrese, who's not here, for putting together our amazing website within a matter of hours. Sam, for helping with the presentations, and Joshua for your work on the index. There's a few more I'll mention at the end. I want to thank all presenters, even those who were unable to join us due to illness and other logistical inconveniences. Some of them took time to prepare their presentations, and we hope that we'll hear from those that we did not hear from. Finally, I want to thank the Colloquium Preparation Core Team, which is Michelle Ogola at the back. Please wave for everyone to see you. Right, that is, she's one of the core 3 pillars of the preparation team, as well as Kojo, who you had from before. So a few announcements. The Coded Bias is showing, and then if you've not registered for the main summit beginning tomorrow, and you need to, please email info@qhala.com for help with that. All right, so we tried to put together a conversation that represents the best of what Africa has to offer in terms of AI talent. This morning we began with West African men talking about compute. And then we moved to East African women talking about data. And then we remixed it. We brought in the Southern Africans, the Northern Africans. And then, at the very end, we had these fireworks with folks from across the continent. This lively debate that we've seen here, I hope has helped all of us synthesize for ourselves many of the earlier presentations. We've heard disagreement on many topics, and we've had voices with differing perspectives, as well as agreement as well. It's good that we have a mix of both caution and optimistic voices. My research sits at the intersection of AI, economics, and game theory, and tries to answer this very question. How do we extract the benefits of artificial intelligence while mitigating the harms? So I was seeing that debate at the stage. That was the highlight for me for the day. I agree with Karim and team about the real and potential benefits of AI, especially in healthcare and education. But I agree with Abeba's caution, especially about allocation of resources that are owned jointly by our communities and our governments, and making sure that they are not being diverted purely for private gain. I believe in some ways we may be looking at different sides of an elephant, that metaphor, right? The back, the front, the tail, the legs. But if you look at global politics, especially over the last few years, where some corporations have managed to get presidents elected, right? We need to pay attention to the warnings about uncontrolled power of corporations. I applaud Thierry and Tayo and other presenters on offering practical recommendations for how Africa should think about using its resources so that we can achieve, we can become active participants. Most of this crowd here today will not stop working on AI, right? This is the choir, right? But they can offer reliable expert advice to policymakers who can actually make those critical decisions, for example, about resources. That's the idea behind the scientific panel that we presented about earlier in the day, right? You may not be the policymakers deciding on this allocation of resources that Abeba wonders about, but you will offer informed expert advice to those policymakers to make those decisions. All said, I hope you all agree with me that we, the Africans in this room and beyond, have what it takes to drive our agency. I hope we've succeeded in having conversations that had breadth and depth as I emailed my participants to try and achieve. We hope that what you've heard and seen today will shape your own journey and help you make your contributions to making AI work for the benefit of Africa. Thank you. All right, with that, we are done. Thank you.